Welcome back everyone. In this video we're going to look at how to install the latest greatest version of PostgreSQL. So to install that, let's head over to postgresql.org, and then on the main page you will see a download button. You click on it and it will lead you to ask which platform do you use. I'm using Mac, so I can choose Mac over here. If you're using Windows or even Linux or BSD, you can use respectively. So let me select the Mac OS, and then this will prompt you to give you all the information pertaining to the version and everything. So you can see that the latest greatest version is PostgreSQL version number 13, and it's for 64-bit Mac OS platform, etc, etc. And then over here you'll see a download the installer certified by ADB for all supported pre-SQL version. So we will click on it, and then it will prompt you which version that you wanted to use it and what operating system that you want to use it. So I would like to install 13.3 on my Mac. I will select that. If you have a Windows, you can select accordingly over here. Either you have a 64-bit or 32-bit Windows over there. So let me click on download, and what it does, basically it will download a DMG file. On Windows it will be a exe file. Okay, so once downloaded, we're going to select that and we will proceed with the installation. Looks like our file is already downloaded, so let me click on it. Okay, here we go, and we'll open up the DMG file. We will simply follow along all the prompts that is available. So this is showing me 13.3.1 over here, and what I'm going to do is I will just double click on it and it should start the installation process for Postgres 13.3. So it will verify all the thing. I will probably say okay over here. All right, I will put my password of my machine. There we go, super password, and then it should start begin the installation shortly. Okay, so we got the welcome screen. Perfect. I'm going to say next, and it will say where do you want to install the package, or you use the same default area. We can use PostgreSQL Server, pgadmin4, Stack Builder, command line tools. I'm going to select everything, so you can unselect the thing. Make sure you always select PostgreSQL Server and pgadmin4 over here. Okay, because we are installing this on our local machine, so we would like to have a PostgreSQL Server install as well as the latest greatest pgadmin tool, which is version 4 over here. Click next, next again, and this is the database super password over here. This is whatever the password that you want to put it over here, you can put it over here. I'm just going to put it welcome over here, and welcome. All right, since I'm using it on a local machine, so I can just say welcome, and this is the default port. You can just leave it as it is, 5433, and click next, and this will show you okay what version of the language that you want to use it. So I will just leave it as default. So if you're using a different version, it will pick up accordingly. Select next. We give you a summary of what we have chosen over here, and click next again and next again, and it is starting to install our PostgreSQL Server plus the pgadmin tool, command line tools, and everything over here. So let's just wait for the installation to complete and we will resume accordingly. Okay, so the installation is done. So it's saying completing PostgreSQL setup results that has finished installing PostgreSQL on your computer. Launch Stack Builder exists. Stack Builder may be used to download, install additional tools, drivers, application to complete your Postgres installation. So I'm going to unselect that for now and just click on finish. Okay, and our PostgreSQL Server is installed on our system. So the PostgreSQL Server is already installed on our machine. Now, how do you access the PostgreSQL Server? To access the PostgreSQL Server, you use the pgadmin tool. pgadmin tool is a graphical interface, a web graphic interface, which allows you to interact with the PostgreSQL database. To access that, you go to your Mac search icon and search for pgadmin4. On my machine, I already had a PostgreSQL 12 installed, so I have two options over here: pgadmin4, PostgreSQL 12, and pgadmin4, PostgreSQL 13. So I'm going to select PostgreSQL 13 with the pgadmin4. So what it does is actually launch a web interface on your machine whereby you can interact with your PostgreSQL database. So let's just wait for that. So it is preparing the management tool for PostgreSQL, and it will launch this in your browser. Okay, so the PostgreSQL interface is launched over here, right? And what does basically is prompting you to unlock your passwords. So I put the password of the database server. I'm going to just put welcome over here and click OK. All right. And you are connected to the PG admin tool over here. All right. The PG admin tool is responsible for you to interact with your database and everything. So this is the interface we'll be using a lot in a lot of videos that we'll be looking at it over here. Okay. Now what you need to do over here is that you click on the server icon over here, and you will see all the servers that is installed before or exist on your machine. Now on your side, you probably have, if you have a fresh installation of pgadmin and PostgreSQL 13, you only see this part, which is PostgreSQL 13. On my end, I have a couple of databases that I've been using it in my other Udemy course. There's another course for PostgreSQL, which deals with PostgreSQL 12, and so it's about 67 hours course. So this has all the libraries over here. So on your side, you will have a PostgreSQL 13 over here. So over here, this is where we'll be looking at all the information, and we'll be creating the tables and everything as well. So if I select that, it will prompt me again for the password of the PostgreSQL server. So remember, the password that we put it was welcome. So I'm going to just say welcome, or the password that you choose before. So, all right, welcome. All right, it is connected right here. So our setup for the Postgres server and the management tool, which is a pgadmin of version 4, is all completed. Now in the next video, we'll be looking at interacting and creating several databases and see how we can leverage the world of PostgreSQL. Welcome back, everyone. We have installed the PostgreSQL version 13 on our machine. Now what we need to do is to leverage the latest greatest version of pgadmin tool. And to access that, first of all, on your pgadmin tool, go to your help, and then you can click on about pgadmin 4, and you will see that this is the version for pgadmin 4 version 5.2. all right. So this is the one, and the application mode is in desktop. It's not in website basis. Now in the previous version of Postgres pgadmin 4, which is like 4.0 or so, the application mode was in the browser. So meaning to say that when you launch them, it's launch a browser window, and then you can connect your server from the browser. So pretty much what you see over here, you can consider that this was opening up all in the browser. So there's maybe a tab on the browser, you'll see everything. So as we can see that our pgadmin version is 5.2. But what I want to show you is one important thing over here. Number one is that you can look at the Postgres website over here. This will give you all the information and everything. There's a pretty good tools available over here to look at it as well, like documentation and everything. But the second thing that I want to mention to you is the pgadmin website. Okay. Now the pgadmin website is available for you, and this provides you all the information about how to interact with pgadmin and so, and we're going to go through with that much more in detail. One particular thing that I'm very interested to show you in the later part of the videos is that the pSQL tool that they come up with. This pSQL tool is released under 5.5 version 5.0. okay. Right now what we have is a 4.2, so we need to make sure that we install the 5.5 or the latest greatest, whatever it is. All right, so let's upgrade our pgadmin tool to the latest greatest over here, and this is being released in 5.4. Now this is the tool that allows you to connect to your PostgreSQL server using the command line, pSQL command line interface through the browser. Okay, so this is something that we'll be interacting in before, so might as well upgrade it from the beginning. Okay, to upgrade that, as I mentioned, let me go through with the steps. So under the pgadmin tool, you go to help pgadmin website, and inside you go to the download on the left hand side link, and you click on it, and this is where you select your version. Okay, so whatever the version that you want to choose, you select it. So I am going to select the pgadmin 4 Mac OS, and if I click on it, it's give me all the releases that is available. So I'm going to select the top one, the latest greatest. So this is as of July 15, so I'm going to select that, And what it does, basically, it's gonna give me all the information. All right, so I'm gonna select the pgadmin 4 5.5 DMG. And once you select that, it will prompt you to install that on your disk or so. So I'm gonna just select OK. And what it does, basically, it will download the file to your, either if you're using Windows or I'm using Mac, so it's going to download the file on my download folder over here. Okay, so once this is downloaded, as you can see over here, this is being downloaded on my Mac. So I am going to select that and launch it. So the file is pgadmin 4 5.5 DMG. I'm going to select that or double click on it, and this will launch the pgadmin 4 version. I'm going to say agree. All right, opening pgadmin 4 5.5 DMG. It's going to verify the information and everything, and then we'll proceed accordingly. Okay, so the installation is almost there. So what we need to do is to move the pgadmin 4 to the application folder. So this is accessible on the Mac machine over here. Okay, so it's going to prepare the copy to application. And since I'm going to probably replace it. So the idea over here is that we wanted to get the latest greatest pgadmin 4 version 5.5 to use, so that we can use the new features and, more importantly, the SQL utility that is now built in inside. So we are going to wait for this installation to complete, and then I'm going to relaunch the pgadmin 4 tool. All right, looks like our installation is pretty much done. So the pgadmin tool is all up and ready. Okay, so what we're going to do next is basically we're going to relaunch the pgadmin tool and then see the latest greatest version. So let me close the window over here or minimize it, and I am going to close this window too. And then from the pgadmin tool, I'm going to go to close and then leave, and this is being exit. Okay, so let's look at it, the pgadmin tool. So we need to make sure that we go under application, because we move the pgadmin 4 to the application folder for the Mac. So I'm going to select that. This will give you the pgadmin tool from the application directory. All right, so it's verifying pgadmin 4, which is perfect. And what it does right now is verifying the pgadmin 4 with all the new updates and everything, and then launch it again. So if you are on the Mac, make sure that you are not just selecting the pgadmin 4 by going to the search. You need to make sure that you select the pgadmin 4 under the application folder. So this is where we install the latest greatest pgadmin 4 over there. So always choose the pgadmin 4 from the application folder. And I'm going to show you another method as well whereby you can do that at the same time. I will click OK, open on that. Starting pgadmin 4 tool for us. pgadmin 4 is started, it's loading, and I'm going to say welcome. All right, and let's look at the quick version over here, right? So I'm going to go to help, about pgadmin 4, and we got the 5.5 over here with the desktop version and everything. So this is the latest greatest we have installed. And if you notice, if you see the icon over here, this is the one that I was talking about. This is the PSQL command prompt that you will be able to access. All right, so our pgadmin interface is all updated with the latest greatest, and if I click on it, I can see my servers. I will select my Postgres SQL 13. I'll put the password again, welcome, and we are connected to our server. Okay, so pgadmin 4 installation with the latest greatest version is already updated and all up and ready. Okay, so it's important to understand that the Postgres SQL 13 version and pgadmin tool, the latest greatest version, you should install it on your system, because this is what we will be using it. Now if you found any problem or so, feel free to connect me and then I'll do the needful. So the pgadmin tool is all installed on our system. Now what we're going to do is let's go through with that very quickly, what the pgadmin tool does it or so. There are a lot of ways you can access that over here. Now I'm going to go through with you very quickly. On the left hand side, this is where you'll see all the Postgres SQL database structure. So by default, the Postgres 13 installed with a default database called Postgres over here, and then it has all the information over here. It has catalogs and everything, the subscription, schemas. So if I click on schema, this is all where your tables and everything is inside. So schema, public, and then you have all your tables over here. All right. So this is an internal database that PostgreSQL uses over here. So we're not going to use that. What we're going to do is we're going to start creating our own databases over here. Okay. So this is where we're going to be interacting with the database. Now the PostgreSQL comes with a query tool as well, and this is what we're going to select a lot, and we're going to be interacting. So if I go back to database and select a database, you can see that all these tools are unhighlighted. But when I select a database, you can see these tools are highlighted. So the very first tool we will be using is called the query. So if I click on it, this will open up a query editor over here. All right. So this is what we call the query editor, and this is where we're going to type all our select commands and everything. So this is a query tool window, and whatever you type, the output will come over here. All right. So that's one thing. The other thing that we'll be doing over here is that the pgadmin tools have a lot of great capabilities, meaning to say that if you wanted to launch again a new tool, it's fairly very simple, i.e. if you want to launch another pgadmin tool, it's very easy. So what you do over here is basically, again, you click on the tool again, and you can see that this is now moved from this window to this window. So you can run multiple PostgreSQL commands in different windows and see the output accordingly as well at the same time. So this is something that we'll be looking at it in greater detail in the next video, but just to give you a quick perspective that the pgadmin tool will be used to interact with our database. Last thing that what I want to show you is that beside these two tabs over here, and you can see the very first tab is called PostgreSQL 13, and it's showing you that you are connected with a database with the user Postgres. This was the default user, and then this is a version 13 over here. All right, and then same goes over here. Now there are other things, for example, dashboard will give you the server health, if you give you all the properties of your server, where it's running, and etc, all these things. And then any SQL which has been written over here. So this is all the SQL create commands that comes straight away with it, right? So this is how the system creates the database and everything, all the various statistics that is available for the server, any dependency which is all there, or any dependent variables that is available is also displayed over here. So we're not going to be looking at more focusing on this, but we will be looking at a lot more on the query tool, and we will be creating a lot of databases over here, and then once the database is configure, we're going to be running the query tool over here. Okay, welcome back everyone. In the last video we installed the PostgreSQL on our local machine, but in a practical world you probably be accessing the PostgreSQL in some kind of a managed environment, i.e. the PostgreSQL or your SQL server might be installed on a Google, Amazon, IBM, or any of your maybe personal platform or so. So most of the time you'll be accessing these databases on the cloud. So why don't we do the same thing over here? So there are so many ways whereby we can install a PostgreSQL on the cloud, on the internet. Google, Amazon, IBM, all these people, these companies provide a very good robust services. I know one company called Elephant SQL over here. This is a very good company also. They provide a very good PostgreSQL service hosting as well as an instance as a service. So why don't we use that? And this comes with a free tier as well, so we can always use that for our educational purpose. So first thing first, go to elephantsql.com. I love the name, by the way, Elephant. And after that, what you need to do is you click on get a managed database, and they give you a different shared instance over here. So we're going to choose a tiny turtle. If you want to use pay $5 or $10, you can get a pretty good information, pretty good access as well. So you click on try now, and what is going to happen is that it's going to prompt you for your login name, password. So you got to create your login over here. I've already created the login in the Elephant SQL, and I've also logged in. So once you're logged in, you're probably going to see a screen like this. Okay, and inside you won't have any instance. Instance means there is a server. Okay, so I've already created one server before, so why don't we create a new one? So I'm going to click on create new instance, and inside let's put a server name. Let's do PostgreSQL. We'll say queries, and let's do Udemy. You can name that anything you want. So we're going to select the turtle plan, which is free. I like the turtle. And then you select the region or data center nearby you. I'm okay with North Virginia. Okay, click review. And here we go, click instance. And you just created a server instance of your Postgres server, right? So click on the entry that you just created over here, all right? Now this is a full-fledged server, Postgres server. This is all latest created Postgres SQL version 13 as well. Now this server is reside on this address. That's number one. This is on region. There is a user and default database. So by default, they put this dynamic user and default database name. Okay, so you need that as well. There will be a password. You can select that to access the password. Then we also have this URL. So if you are accessing this through a programming language, you probably need to access this URL as well. Okay, so and then the size is about 20 megabytes, which is fine for us. All right. The other thing also important is that you have a full-fledged browser as well. So I can run queries, create tables, and all sorts of different things, all right? And you can also select the table. So right now there's no table over here, all right? And of course you have stats and all sorts of different things as well, okay? So first thing first, what we're gonna do is we're gonna create an instance to be able to access through our PG admin tool, all right? For that, what we need is the following. So First, we need the server address. So I'm going to copy this one over here. I'm going to head over to my PG admin tool, right mouse click, go to create and server. All right. And inside the server, let's put the name of the server. So let's put it Postgres SQL. I'm going to put queries Udemy. All right. And in the connection tab, you paste that address. Okay. The one that you have it over here, pnets. You might have a different name address, so please do the same thing as well. Now in the 5432 is fine. Maintenance database and username is PostgreSX over here, so we got to change that to this. Okay, that's why I say user and default database. So I'm going to copy that, paste it over here too. And then last but not least, we need the password. So I'm going to click on this I sign, copy it over, and paste it over here. All right, and then click on save. All right, that's it. And what's going to happen is going to access an instance over here for the server over here. So we can access this server from here. Now, do not use these passwords or so, because I'm probably going to rotate that as well to a different password or so after the video. Try to create your own server over here. This is a free service as well. Okay, so important thing to note that we already had a user and a default database over here. All right. So we can access this database OGHSFDSN. Now this is a little bit thing over here. So you can expand that over here, and you have 1900, almost like 2000 over people who's accessing this. But the good part is that this is in alphabetic order, A and all sort of thing, right? So if you go at the OGH side, if you go all the way to OGH, let's try that. Right, and OGGGGGG, and you will see not the cross sign. Here we go, that's our database. All right, so once I select that, I can expand that. I can go to schemas, and this will give me all the information about my schema. And from here, if you notice, there's no table over here. All right, so what we did in this video, we effectively created our own Postgres SQL server on the client using the Elephant SQL. All right. So why not you stop the video and follow along, or create the server setting on own. And once you're back, we are going to be fire up this server with a lot of different data, and we're going to run so many queries. In this series of the video, we'll be looking at building our knowledge on SQL queries by looking at an employee management system. So before we jump in and look at the queries in PG admin, let's understand the database model. Now I'm going to make it a very, very simple model over here, but you'll be surprised after so many videos and so many queries you're going to be running on this very simple model. But this model itself can give us a lot of information about the practical approach of running questions and answers from our database. So what is the database model for our employee management system? So it's going to be an employee management system. Very simple. It will have only 2 tables. That's it. No extra tables, no very high level, dependencies and all sort of stuff. So I want to start very simple, but I want to be going very deep inside. Okay. So you'll have an employee table and you'll have a departments table. So employees will have their own information, and then each employee will belongs to a department. Okay, so it's going to be one-to-many relationship or so. Okay. The other thing that's going to happen is that let's look at it individual tables. So for example, employee table will have this simple structure. So you have employee underscore ID, which is the ID. You have employee name, name of the person, mostly varchar. This will be integer. You have a job. You have its manager information. Again, this manager information would be in the integer format. The hire date, when this employee was hired. Any salary information, again, integer value. We're going to keep it very simple, like numeric only. We have a commission. Some employees will have some commission, some employees will not have a commission. And then of course the department ID, which department ID they are belongs to, right? Similarly, like that, you'll have a departments table. The departments table is very simple. You have a department underscore ID, you have the name of the department and the location. That's pretty much what we needed actually, okay? So out of these two tables, there must be some relationship, right? You have an employee table and then you have a departments table. So how these two tables talk to each other? Can you identify a key over here or a foreign key inside, let's say, employee table? Yes, as you can see, you have a department ID. So in the employee table, department ID is a key to connect to our department table. Okay, so that's a foreign field inside employee which pointing to a departments table. Okay, so this would be a department ID and which will communicate between employee and departments, i.e. we can connect the employees table and the departments table together. Okay, very simple information, no very advanced thing, but you'll be surprised the amount of the things that we can run with these two tables, and this will help us to understand a lot more about in terms of like how we can build simple to advanced queries on these two tables. Okay, so in the next video, let's populate these tables over here. We're going to go back to our pgadmin tool and then start creating those tables and insert the table one. In this video, let's populate our two tables, i.e. employees and departments. So let's create the table first, departments over here. So we know that in the department, we say that we want a department ID, we want the name of the department and the location. 3 fields over here. So let's create that over here. Just to know that in the department ID is going to be integer, name and location will be a varchar. Okay. So let's go to our pgadmin tool. Make sure that you logged into your Elephant SQL instance over here, and then you are selected the table over here, and make sure that you can run this query editor. So once you click on the query editor, it will open up a new query editor whereby you can fire up all the queries. Okay, so I'm going to use a simple command called create table, and let's do departments. All right, and inside the department, we're going to define the information inside. I can always run a right mouse click, create table as well visually, but I want to show you how you can create it through the SQL query. Okay, so first thing first, we need a department ID. We want this to be integer. Okay, and then the second thing, we need the name. We want this to be varchar. Let's make it 100 characters. And what we want to also do, make sure that this is not null. Okay, and then location, varchar, again around 200 and not null. Okay, very simple. And the last but not least, we will do a primary key definition, and this will be related to department ID. Okay, very simple definition of the table. Now if you want to know more about how this whole definition of the table more in depth or so, my course is available on Udemy. So go to Adnan Wahid, search for Adnan Wahid, and you can find a lot of the other courses. So the one those courses like PostgreSQL Bootcamp, go from beginners to advanced. It's about 60 over hours. Very, very, very detailed course as well. And I keep adding more and more stuff inside as well. And of course, you have other courses to look around like Python. Mega Python is the recent one. It's also about 45 total hours, master readers, and bootcamp information in terms of practical Python or so. But coming back to PostgreSQL, you can find a lot of great information. So for example, if you want to look at how to create and modifying table, there's a whole lot of videos available for that as well. Okay, so highly encourage that you have a look at this as well if you need a lot more in depth over here. The purpose of this course is to help you to get acquainted with more of a simple to advanced queries, okay? But if you want to get more information about creating the table, modifying it, and all sort of, again, on the query side, you can take a look at Postgres bootcamp, Go from Beginner to Advanced, 60 plus hours, is a bestseller as well, okay? So we're going to go back to our PG admin over here, and inside we have create table, departments, department ID, integer, name, location, and primary key, okay? And normally what I like to do is also do it this way, and we can always, maybe we can just leave it as it is as well. I don't like the name and this to be highlighted. I like this to be more towards like the information. So let's do that, department name and department location, okay? So this is a little bit longer, but that's okay. We can even do DPT, RD as well. So I like to keep it this way. So I'm going to run that, okay? So it said table created. If I right mouse click, go to refresh, you can see that table is created over here, okay? Once the table is created, let's insert some data inside. So I'm going to do a quick insert, okay? Again, if you want to know more about how to add a data or so, refer to my course earlier in the Postgres SQL side. So inside we'll say department ID. We will do a department name and department location, okay? And we'll do our values, and inside the values we can define the thing. So maybe we define 10 over here, and I have created a very simple file for that as well. So let's double check over here. So we have programming, research, sales, and operations. So let's add those guys over here. So we have programming. So we'll say name of the group is called programming. Location is basically, we can just define the department ID as it is. We can always define the location later on as well, or just define it over here. Let's do New York, okay? And then let's do 20. And then location, we had the other one is called research, okay? And then importantly, let's do Dallas, okay? And then these are some sample data, but I carefully created this data so that we can do a lot of other things later on with the queries, okay? So let's do, this one is Chicago. Chicago is a nice place as well. So there's the others as well. So 40. And then inside, let's do a operations, and these operations are in Boston. So in New York, in US over here, right? So I'm going to run this one, and let's double check over here, insert into departments. Okay, and let's run this one. Okay, and then we have insert 04. Now to double check the data, we can do a select star from departments, okay? And I can select and search this whole thing. So I can select the selection and then run it. And here we go. We got the programming New York, research in Dallas, sales in Chicago, operation in Boston. Okay, so our first table department is all up and ready. Okay, now all these queries, I'm going to be also attaching it to our video as well. So you can always run it as well. Okay, but as I say, always try to do it side by side. Pause the video if you wanted to do it at your end as well, and then try to do it over here. So the best way to learn and enjoy this course is doing it by yourself, right? There is no point to get these queries and just run it at your end. I mean, you will not see the potential gain out of it as well, whereby if you were to write each and every text over here, I am very sure that you're going to learn a lot more. Okay, so this is already done. Let's create our second table. The second table is the employees table over here. So we got employee ID, name, job, and everything as well. So I'm going to just take this one over here as well, just to FIR basis, and I can make a comment at the same time. So this is my employee table. Okay, let's make it employees table. Okay, employee table. Okay, again, create table employees, and inside the employees, let's define our employee ID. Let's do it int. Okay, we need employee name. Let's make it varchar. Yeah, maybe 100. And what should we do? Not null. Yes. Okay, And then the second one is job. Should we make it integer or should we make it a varchar? Yes, varchar, because it will be a varchar. And let's make it not null as well. Okay, we need to hire people which should have some job. And let's do a hire date. The hire date would be a date type. Okay, and of course not null, of course. And then salary, right? Salary should be integer. Let's make it simple, and of course not null. You need to have some kind of salary. Now what about commission? Okay, commission is also integer. Should we make it not null or so? What do you guys think? All right, so for those who are saying not null means that we have to make sure that every single employee has been paid commission, which is not a practical way, right? So we don't need the not null over here. Okay, what about the department ID? Department ID, again, this should be refers to this. So since this is integer, we'll make it integer too. Okay, and of course we'll say not null over here as well because it's a foreign key. And what about the manager ID? Manager ID means like an employee will have some kind of a manager as well. Okay, so how many of you will say, okay, integer is fine. What about not null? Should we put it not null? Every single employee in the company should have some manager. How many will say yes? How many will say no? Think about it. Well, if you look at it practically, yes, everyone should have a manager. But what about the main guy who will build this company, like a CEO of the company? He will not have any manager, right? So if you make it not null over here, what happens is that the system will prompt a manager ID for the CEO. The CEO will not have any manager ID, so we can just leave it as it is, okay? So we got pretty much over here. We have employee ID, integer, employee name, varchar, not null, job, hire date, salary, commission, department ID. I like to put it this way, all the IDs either at the beginning. Normally, I do it like department ID, manager ID on top, and then have an employee name. But it's again depends on you, wherever you are wanted to create that. Okay, so I am going to do that. And then one important thing is the primary key. Okay, yes, how can we forget about it? So employee ID, let's make it simple. We are not talking about a very complex structure whatsoever. I can always define a foreign key over here as well, but for now I'm going to leave it as it is because in the later part of the videos we're going to implement that as well. Okay, so employee table, let's run it and let's double check primary key employee ID because there's a comma over here, and let's run it. Okay, boom, right mouse click, refresh, we have employee table. Okay, and if I run it, select star for all columns from employees. Okay, and if I run this, how many records will have? 0, right? Because we just created over here. So this is 188 milliseconds, 0 rows affected. Boom, we got everything integer. 100 character, date is date, salary is integer, commission is integer, department ID is integer, manager ID is integer as well. Okay, now we have the employee tables created. Now let's populate the data. Okay, again, this data, I've specifically created this data again to populate it so that it works very well with our queries. So I have this sample already inside, so I'm going to just copy that. And again, all this is available for you to play around. Okay, so this has basically employee ID, employee name, job, hire date, salary, commission, department ID, and manager ID, and then you have everything. Now, important thing, you might see the nulls over here. Nulls basically is the location whereby we don't have the data. For example, the idea over here is that some people will not have commission. Some people have, like salespeople will have a commission, okay? But manager will not have commission over here. Manager, no commission. Manager, no commission. A person from analyst side that has no commission, okay? So if you wanted to define and import this information to our table, make sure that you put the null over here, right? So I am going to take this and select this section and run it, and you have 14 records added. Now, if I go back and run select star from employees, you can see all our employees are there, number 1, okay? You can see that this is Smith is the name of the person. His job is admin. His hire date is 2019 in December 15. His salary was about $1,000. He has no commission. His department ID is 20, right? The one that we created. And then his manager is manager number 13. So Mr. Ford is the manager for Smith. Okay. As you can see, all of them has a manager ID except the CEO. Mr. King, who is the CEO of the company, doesn't have any manager ID. That's why it's null. Remember, that's the reason we did not put the not null over here. All right. So congratulations, we just built our two tables, departments, employees, and trust me, with this small data, we'll be learning tons and tons of information and how we can create the data stories from our data and much more through amazing world of the SQL queries and much more. Welcome back, everyone. Now we have our tables, we have their data inside as well. So let's fire up our SQL queries. So the structure of this entire course is going to be that we're going to be playing around with the data that's stored in our table. We're going to try to solve some queries. So I will have some kind of a text over here. We're going to review the text or what's the text looks like, and we're going to solve the text over here, right? So let's look at some of the filter data that we can get from our table. First of all, let's get all rows and columns. So for that, it's very simple. We can do select and star. Star basically give me all the columns. And then we have a from clause and the table name. So maybe we want to get all the data from employees table. Okay, and once I select that, make sure that whenever you're running your query, you select the query that you're running, because you have other statements in this file or so. Maybe you don't have that on your side, so it's up to you how you want to do it. I normally select this area where I want to run the query, and then let's say, because it's going to just reconnect our server again, and then you have all the data over here. So employee ID, name, job, hire date, salary, commission, department, and manager ID. How about you pause the video and try to get all the data from departments table? I highly recommend that you code along, i.e. whenever you wanted to do the exercises, do it together. While I'm talking about it, while I'm typing it, you should also try to type at your end, all right? Or if you wanted to pause the video and go back to your system and do that, please do that. Now, there are two ways to learn all these things. Number one is, of course, you can get all these things somewhere and, just run this one, copy, paste in your PG admin tool, and it's fine. But I can guarantee that you're not going to learn so much out of it. When you're actually typing select and star and from and whatever the table, you're actually going to learn a lot more. So I highly emphasize, this is how I learn. I normally don't try to get the whole code and then dump it and then just run it and then say, oh yeah, it's all good over here. You don't get to learn so much. So please, my humble request, code along, all right? So this is the journey we're going to go through together to have a win-win situation. So the best way is to code along. So pause the video and try to select all the columns from departments table. All right. Let's look at it, ours and yours queries together. So select star from departments. Okay, and here we go. Once I run that, you'll get all the departments. So you have ID, name, location, and all the departments over here, right? Now, sometimes you don't want to get all the columns. Now, when we use the select star, it basically tells give me all the columns. But in a practical world, your table might have a lot of columns over here. So it depends, you might have a fat table or you have a long table. When I say the fat table, is like it has lots and lots of columns. It's called fat. And when you have a long table, you probably have not so many of columns, but you have a very long rows, as in you have a lot of data. Now in the programming world, in the database world, it's always good to have long table, not so much of a fat table, right? Just to give you a perspective. So sometimes you don't want to use, or I would say highly recommend, don't use the select star from a production system, because it will pull up all the records, all the data from your table. So for a small table, it's fine, but becomes an expensive query to run on the server. So this is where you can retrieve the subset of rows, all right? So why don't we do that? So let's get the employee name. We'll get the department over here. So why don't we try and get employee name and department from our employees table. So we know that our employee table is this. So you have employee ID and employee name, and then you have a department. All right, so let's try to get these three columns over here. So similarly, we have a select. And by the way, I can always do select in a smaller style as well. Whichever is easier for you is fine. All right. And from here we can do the needful. Both are going to work. Okay, so it depends on what style you want to do it. Okay, Now, there are a couple of ways to do this actually or so. Normally what I try to do it whenever I'm running a query, I like to structure the query. So I always say select and start and from. Okay, so this is my structure. So I'm saying, okay, fine, I'm running a query. So in the select, what are the columns that I'm looking? I'm looking employee ID, and then do a enter, and then we have employee name, and then you have a department ID. All right, and then after that we have the employees table. All right, now this query, of course, once you run, you're going to get exactly what you're looking. Now if you look at the visual style of the query, it's far more better than one line. That's my opinion. It works over here, but from the learning perspective, I like to create this way. So whenever I'm looking at this visually, I can see that, okay, so this is the column, this is the query, etc., etc. Okay, so try to make these practice so it will be helpful for your learning curves. So again, why not you pause the video and try to complete the additional column of salary over here. All right, pause the video and do the needful. So normally I'm going to copy this, and then let's double check once you are come back. Okay, so I'm going to do a comma, and the column is called salary. Okay, and I'm going to run that. Okay, remember, I'm selecting what I need to select, and make sure that you run the selected portion of the query. Right, you have employee ID, name, department, and salary. How easy is it? Okay, now let's look at some more filter information, because whenever you are trying to access the table, you probably want some kind of a filter data. And this is where the where clause comes in. Okay, now if you want to get more information about it or so, I have a course on the Udemy that you can access, and it has a full course availability with all the detailed information. And so I've got like 5 courses on Udemy as of this today, and then it has a lot of information like Postgres bootcamp. This is a 60 hours. This is a bestseller as well. Highly recommend that if you want to go very, very deep about Postgres SQL database, lots and lots of things, then this is a perfect course for that. In addition, you have a Python, you have master readers, mega Python as well. This is the latest greatest one, and then you have a lot of exercise for Python as well. Okay, now if you look at this particular course, as I say, this has 67 hours and 18 minutes, and I constantly update this every single time. So if you're looking, creating, modifying tables, you want to query the data, and all the filter information that we are going to be using it, some of it. But if you want to get in-depth information, like say, can we use column aliases with where, and etc., etc., this is the perfect course for you. So go ahead and do the needful as well. Okay, now as I said, the purpose of this course is to look at the data and create the data stories from the queries. Okay, so I presume that you have some kind of a knowledge of the Postgres SQL in terms of like SQL language as such. All right, so we will be looking at running these queries more and more. All right, so let's look at the filter information over here with the where clause. So what we are looking is, we are looking view all employee assigned to department ID number 20. Okay, again, let's filter our information. Let's create the structure. So we are looking, let's say star, let's pick up all the columns, and this is the employees. Okay, and I like to create the query step by step. So view all employees. So this will give us all the information that we are needing. Okay, now you have a assigned to department ID. So there's a where clause over here. Okay, so normally I'll put a where over here and then enter to give a space over here, so I can create multiple conditions over here. So department ID is this one. So we are looking at department ID equals to 20, right? So that's a 20, and I'm going to select this one, and let's run this one. So you have access to all the employees belongs to ID number 20 over here, department ID number 20. Okay, how about multiple condition? How about you say I want to get all the employees where department ID is also 20. Oh, let's try this is a 10, right? So why don't you pause the video and try to do that over here. So I'm going to copy this over here for you and pause the video and see whether you can do it, and we're going to learn together. Okay, so it's as simple as changing this one to 10, and let's run this one, and now you have the 3 employees belongs to department ID 10. Okay, so far we have a where clause which has one condition, but we wanted to get maybe multiple condition. Okay, So maybe we wanted to try a query whereby we want to get all the employees which are either department number 10 and or 20. All right, so our query is, we are looking department ID either 10 or 20. Okay, so how do we do that? Any ideas? Anything? All right. Yes, basically in the where clause you have a n and or functionality as well. So I can do an or, and I will say department ID equals to 20. Yes, and let's run this one. Okay, and what the system does is that since we put an or condition over here, what the system does is that it's either going to look for this or this actually. All right, so it's going to pick up all the records of department number 10 or all the departments of the department ID of 20. So you can see 10 and 20s are displayed over here. All right, also as I mentioned over here, that when you structure the query, write it this way as well. It's very nice to look at it as well. So I can see every single condition. I try to break it into second line as well. Okay, although you can write this in one whole long line as well, that's fine. Okay, now how about you try to do this query, pause the video and see. We wanted to also look at this condition and also with employee who earned a commission. All right, so you want to get an employee who has not the null values over here, right? So why don't you pause the video and try to do that, and then we're going to come back and review that again. Okay, so let's double check your query and our query. So first of all, our condition. Okay, the column of the question is commission. Okay, and in the world of SQL, you have this very clause. It's very simple, is not null. Okay, so if you want to see all the employee which has commission zero, null, then you just say is null. All right, so I'm looking at is not null. And once I run that, what will happen? It will run all these three statements either, right? So here we go. You have 11 records. So you have the department IDs 10 and 20s, all right? And also you have the employee who has a commission is not null, right? So number one, all the 10 and 20 employees, they don't have a commission whatsoever. But then in the department number 30, he found 1, 2, and 3. These guys have the commission. Okay, that's why it's pulling up. Okay, so it's very important to understand the where clause and then also understand the or condition. All right, now I want to give you also one more thing whereby I want to see, for example, I want to look at all employees where department ID is let's say 30 and have commissions. Okay, right, and have commission. So anybody wants to give it a try, right? Pause the video and try if you can do that as well. All right, let's do that. So number one, department ID is 30. All right, and I'm going to delete this clause, and then instead of or, I'm going to use the and clause over here, right? And have commission means I have to delete the not as well. Okay, and let's run that. Okay, now you can see that, hey, you know what, these are employees, well, you know what, not null. This should be not null. All right, have commission, meaning you have to use the employees which has commission. So here we go. So you got employees with department ID 30 and commission, it has to be not null, right? So what the system is doing, it's taking this, it has to true both conditions. That's why we have and over here. So the system is going to filter all the records with 30, but then at the same time it's going to see that all of these 30 department ID 30, make sure that the employee also have the commission some numbers. If these two conditions met together because of the and, then it's going to display over here. All right, now let's make it a simple, more beautiful aliases as well. Let's suppose if your manager say, hey, you want, I want to get some employee information, so you probably want to put it not this way or so, right? You want to probably put it a little bit more better. So how about we change salary to employee salary or something like that? Okay, so how do we do that? This is what we call the aliases. So in the world of select, we'll do employees. Okay, and let's try employee ID. All right, and I'm going to take employee name. All right, and let's take a salary over here, right? As simple as that. So if you wanted to get the data, very simple. I'm going to run this one. That's fine. That's okay. But then if you want to make it a little bit beautiful, I can say employee ID, right? And once I run this one, okay, let's see what happened. So number one is saying that, hey, you know what, this employee ID, syntax error near employee ID. Why? Because it's an as over here, right? So we need to make sure that we put it in such a way that it works. So now you have this not in single quote but in double quote. So you can see the employee ID has to be, because you're making a space over here, right? I want to give you a couple of more. So if I do employee ID or let's do this over here as EMP just to illustrate that. All right, I can make any aliases using the word call AS. Okay, so you can see this being string. Okay, if you wanted to make like a space over here, like no space whatsoever, I'm going to run that. It's going to give me an error because this single hash over here doesn't work over here. It's like what we call save. So single quote is not going to work. So for if you wanted to give a name over here, I can do this way as well, right? Which is same, right? And it's going to work over here. But if you want to make a space over here, for example, right? This is where the double quotes works over here very well. Okay, so now you can see the employee ID. Okay, so how about we do employee ID number, right? Let's make it more English style or whatever you want to do it. Okay, now why not you pause the video and then maybe change this one to a proper employee name with a space, and also salary as an employee salary. Okay, pause the video and come back and we're going to review that together. Okay, so let's do employee name and then as employee salary, and let's run this one. Now you have a beautiful output over here ready to give to other users or whatsoever. Okay, so this is how you can use the aliases over here as well. All right, now we can always do additional one as well. Let's try add a employee commission inside as well. So commission as employee commission. Okay, and let's run this one. Okay, just to show you that this is a very, very powerful way to do an aliases. We can do a beautiful aliases and more. All right, so in the next video I'm going to continue looking at the aliases and give you a new perspective in how we can use the aliases using in the where clause and much more. Welcome back everyone. In this video we'll be looking at the aliases, but we're going to reference them in our where clause. So let's take a very practical example. For example, we want to take all the salary and commission from employees where salary is less than that. So let's build our query first. So I'm going to do a select and then from, we're looking at employees table. Okay, and we possibly have a where clause as well. Okay, so the column that we are looking is, let's try employee ID and we'll take a salary and we'll also take a commission. All right. Now in the where clause, we're going to put salary, which is less than 5,000. Okay, and let's run this one so that we can get our information. So yes, these are all the guys who has the salary less than 5,000. That's perfect. Okay, there are 13 guys. Now what we want to do is that we want to utilize the aliases over here, right? So maybe instead of we calling salary, for whatever reason, we want to call this employee salary. Okay, just to illustrate that. So once I run this one, it's gonna still work, no problem, right? Because it's showing that yes, but the only thing is the column name has changed over here. It's renamed as an alias employee salary. Now what if you will say that, hey, you know, instead of salary over here, why not I use employee salary? So how many of you will think it's gonna work or not? Okay, you want to pause the video, try it on your end, and then come back. That's perfect too. All right. All right, so let's see whether what you have found out on your end. So once I run that, here we go. It's a call employee does not exist. So that's strange, right? Although we put that alias over here, but in the where clause, it is not coming up. Why? This is very important because the select query has a way to execute information step by step, right? So in a traditional world, right, when you supply the select and then from and then where clause, right, normally the where clause will evaluate it first before the select. Okay, so in this query, the SQL engine is going to look at not this one, it's going to look at, okay, so what is the condition over here? So this is the condition, right? It's going to say employee salary has to be less than 5,000, but then and then after that he's going to look for, okay, from this table, but in this table there is no column called salary, employee salary. It has salary, right? That's why it fails. It does not exist. Okay, so it is very important to understand the flow of information or execution pattern or what is executed first. Okay, so what's the solution? For whatever reason you still wanted to use it, you can still use it as well. All right, so how do we do that? Is very simple, and this is something we're going to be looking at a lot. All right, so first of all, I'm going to make this whole thing as it is. So first of all, let's run that, and it's going to run, no problem, right? Now if you wanted to use your aliases over here, we're going to wrap this whole thing into another query, right? What we're calling is this, that we're wrapping your query in it as an inline view. You can reference that with the alias column, right? So I'm going to do another select, and this is something we're going to be using it a lot when we are going to do the window based queries later on as well. Okay, so I'm going to push this whole thing over here. I like to kind of put it it's a little bit more format. So what we are saying that, okay, so this is your outer query, this is your inner query. Okay, so inner query, if I select it, perfect, it's going to run, no problem, right? Now if I try to run that, I'm going to get an error over here. Okay, so once I run this one, you'll say, you know what, I don't know what you're doing. Subquery in from must have an alias. All right, so first of all, we're saying that this is your inner query and this is your outer query. So outer query must have an alias. That's what the system say, when you have to have some kind of alias. So I can do as X over here, right? And once I run that, boom, no problem over here. It still works. Okay, so what we can do is a couple of things over here, right? Now we still haven't used our employee salary over here, right? Now if you notice, the output of the query is employee salary over here, right? And although I use the condition inside, what I can do is I can take this whole thing and then let's run it this way, okay? And it's going to still work it. And then after that, I can put my where condition as my outer query. There we go. Okay, so now it's saying, hey, you know what, I don't see the salary column here. Why is that? Because the output of this is not the salary, is the employee salary. So once I change this one, okay, and run it, I can see my employee salary is over here. So we have used our aliases over here. So if you want to use the aliases or referencing alias, you need to make sure that you put your query as an inner query and then reference that with your outer query. Number one, outer query, select star from, this says, okay, take all the columns is returning from here, and then have an alias. And then once you have this data, you can then apply filter condition on the final data. Okay, and this is very practical. A lot of time in the clickanalytics.com or so, we have some really long queries and we use heavily aliases over here, right? So just to recap, the way it's going to work is that the select statement is going to first run your inner query. It's going to produce some data. It's going to pass this information to your outer query. The outer query is going to take this and has to have some aliases for this data. That's fine. And then after that, with this data that is coming up from outer query, you can apply all sort of filter condition. Make sure that whatever the data, whatever the column that's coming out of your outer query, you should reference that based on those column names. Okay, not the original column names. All right, so that's to show you that this is how you can reference an alias column, and this is something we're going to be looking at, the inner query and the outer query. Okay, now let's look at it some more information. Let's say if you want to concatenate columns, there will be practical solution whereby you need to maybe add or combine columns together. So one of the examples is that, what if you wanted to put employee in such a way, let's print first of all, select star from employees, okay, and I'm going to run this one. This is fine, but what I'm looking is I'm looking in output of the call, a query for your manager, and the manager say, hey, give me all the employees and I want the output something like that. I want their name, and then I want something like works as a whatever the job they have. Okay, so we've got to combine the employee name and job over here. Okay, so both of them are correct or varying, so perfect, they can combine together. All right, so how do we do that? So this is where we can use what you call a built-in concatenation. There's a lot of ways over here we can do that. For built-in concatenation, you can use double pipes over here as well to combine columns, and there are so many things that you can do it. Okay, so I'm going to do from employees. Okay, now in the column, first column is the employee name. Okay, and I'm going to combine that with the pipe. All right, and I can have my single quote over here, and I'll say work as a, I'm going to pass this one, make a gap over here, and then I have another pipe over here, and then what's the second column is a job, right? So I'll say job. Okay, and once I have this, let's run this first. Okay, so here we go. Okay, perfect. It's Smith works as admin, Alan works as a salesman, blah blah blah. But if you look at it on the top, it's a question column. Why is that? Because we haven't provided any aliases. So why don't we do that as, you know, let's say job title. Okay, let's run that. Here we go. Now you have a job title. So what we did is we use an alias, right? And we also use a concatenation style. So you're using the pipe. So you're taking, this is the column, this is another column over here. So if I take away this whole thing over here, let's try this actually. So I'm going to take it out, right? And I run that. Okay, it's still going to work, Smith and Adam, right? But if you want to make it more better, beautiful or so, that you can do it over here as well. I can even do this. Okay, let's make it even better over here and run it, and you say Smith works as an admin, Alan works as a salesman. So this is how you can concatenate columns together over here, right? So in the next video, what we're going to looking at is we're going to look at some more condition logic in our selection statement. Hello everyone, let's look at some of the conditional logic that we can apply in our select query. So for example, let's say we wanted to look at a result set whereby we want to see if an employee salary is paid 2,000 or less. We want to return a underpaid message. Or if an employee is paid 4,000 or more, we want to look at a message called overpaid. Okay, so in our employees table, we got employee information and we have a salary. So anytime anybody who is paid less than 2,000, right, we wanted to make sure that this is, for example, this is an underpaid person, right? And if the employee is paid more than 4,000, we wanted to put against this employee, we want to put it, let's say, hey, this employee is overpaid, right? So how do we do that over here, right? So let's use what we call a case expression. This SQL comes up with so many different things, and you can use the cases when you are extracting information from the select statement. Okay, so we'll do a select and from, that's the table is employees. Okay, and then inside what we are looking is that we are looking a condition over here, but which is a logic. But if you look at it, we are not filtering any data. That's a very important thing. So we are doing a conditional logic. We are saying that, hey, display all the information with a condition. The condition and filter is different thing. Filter, you're probably going to use a where clause, but over here we're not filtering. We're just doing a conditional, i.e. we're looking at each and every row, and based on the row data, we are putting in information outside, which is what we call the condition logic. So one of the ways is we can use a case expression. Okay, so let's do that over here. So why don't we try and look at the employee ID, and let's look at a salary. Okay, so these are the two information. That's fine for us. That's what we are looking, right? We can even put a employee name as well. Okay, and let's run this one. Okay, so we can see that the employee name. Now what we want to do is basically saying that, hey, if the employee salary is paid less than 2,000, we want to return a message called underpaid, right? So why don't we condition that? So case is very simple. Now whenever we use as a case, we want to do an end as well. Okay, so case means that you are putting a logic over here, right? So case and then, so I put a cursor on this, so just for the presentation over here. Now in the case, we can apply a couple of things. All right, so for example, we can say when our salary column is less than equals to 2000. Okay, then we will put underpaid. Okay, that's it. And let's run this one first, okay, and see what happened. Here we go. So you can see under employee salary, so this guy has 1000, 1800, 1400, so they are underpaid. These are underpaid, right? Okay, so whenever it looks a condition in our columns based on data, it is outputting information. See how nice is that? So basically you have actually created an additional column based on the condition of the data, based on the data that is inside the table. Okay, so this is as simple as that. So you'll do a when clause and do the needful. Now if you want to make another condition, you'll use the same thing, when, and you'll have a then. Okay, that's how the system is going to work, right? So why don't you pause the video and then try if you can do an employee when it's paid 4,000 or more, we want to display the data as an overpaid as in case over here, and this case is basically an output over here. All right, so we will rename this as well later on, but why don't you pause the video and see whether you can do that. Okay, so let's do salary, and this time around I'm going to greater than equals to 4,000. Okay, and then this is overpaid. Okay, and now let's run this one. Okay, so now it's running the information, and then you can see that Mr. CEO is definitely overpaid, but then other guys are fine. Okay, so if anybody is we can make an even condition like 3,000, right, and run it, and you can see that, hey, this guy is overpaid, this guy is overpaid, etc., etc. Okay, so anybody who is less than 2,000 and 3,000, they are fine. But what about the other guy like this and that? So there's no definition over here. What that means that their salaries are okay, right? So why not we condition that as well? Okay, like in the case you have a when, there is another clause called else. Okay, this is basically a condition, and the system works is that it's look at the case, the salary, when this is the condition, this is the condition, is going to run it. If there are two conditions doesn't match, then it's going to just display this actually. Okay, so if the salary is not less than 2,000, the salary is not greater than 3,000 or equal to 3,000, then it's going to just output this actually. Okay, and let's run this one, and now you can see that overpaid, all the columns will have some values. Okay, now you have an okay salary. Okay, last but not least, we can do an alias over here. I will say salary check. Okay, and if I run this one, now you have a very nice good output over here, right? The employee name, salary check over here. So you can see, hey, these are the overpaid, underpaid, and these are the okay guys. So in the entire salary bracket, I think 2 guys is being paid very well, but most of them are underpaid over here. Okay, so the whole thing is that as you can go through with this data, you can see that this data is very simple data. But what I'm trying to use is all the functionality, all the major functionality for select statement over here, and then utilize all this to create the data stories, right? So with the same simple data, we can do a lot of different things. So whenever you are trying to filter a condition logic, you can use the case statement. Case comes with case and n. You can do an alias, and then you have a when clause along with then. All right, if the conditions what you are putting over here does not met, you can do an else as well. Okay, so in the next video we'll be looking at some more information, maybe limiting number of rows returns, and as well as running maybe some random records from the tables and so on. Welcome back everyone. In this video we're going to be looking at 3 things. Number 1, what is order by clause, what is the limit, and what is the random. Okay, so we're going to look at step by step. The order by basically help us to order the data that is returned from the SQL query. So a lot of time you're probably using it so much. Okay, the limit is going to help us to limit the number of records that's returned, and then you have a random function which is going to pick up some random data. So let's do it step by step over here. So we have our select star from employees. This will give you all the data. As once I run that, first of all, what's going to happen is that it's going to say that there are 14 records in our system, so it runs, right? This is based on whatever the initial order is there. Okay, So what if you wanted to run all the employee information, but you want to order by employee name? How do we do that? So it's the same thing. We're going to say select star from, in fact, let's do our magic way of doing it, right? So it's even better. So employees, okay. And then inside I'll do an order by clause, okay. And the order by clause basically provide us what columns we want to order by. So I'm going to say employee name, okay. And I'm going to select this one and make sure that the first one was Smith and Allen and etc. Right now, once I run that, here we go. You got the alphabetical order in ascending order. So Adam, B, C, F, etc. etc. Okay, so this is what we call the order by. All right. So what if you wanted to do an order by, this is ascending, but you want to probably reverse that. I want to get all these guys like W and Z to go first or so. That can be done as well. Okay. So I'll copy that, and very simply I can do a DESC as an alias, or not the alias, but as a text over here right after the order by. Okay, so if I run this one, I'll run that, and what would happen is that it's going to reverse W, T, S, M, and then you have the A over here, right? So it's very important to utilize the order by, whereby you can order by all the return information. Okay. So this is very simple. Now, what if you wanted to do this again, but this time around, let's say we wanted to do order by salary in descending order. So why don't you pause the video and then try to do that, and we're going to look at it together. Okay, so we got salary, and then that will first of all give you all the salaries. Perfect. This is all the salaries in 960, etc., etc. But what we are looking in the descending order. Okay, so highest salary will be on top. Okay, and here we go. There we go. So the highest salary is the CEO. Right after that, you have a Scott, then Ford, Blake, etc., etc. Okay, as I say, I promise you guys, right? With this simple data, we're going to do so many data stories out of it as well. So you have very good information. Say, hey, within this, what is the highest paid people over here? What's the lowest paid people over here? Right? So if I run this one over here, so this is another thing. You can select the area of your choice to run it, and this will run it over here. So this is the least paid. This guy James is a poor guy in the whole organization, followed by Smith and Adam. They've been like paid really, really low. Okay, so that's how you can utilize that order by. Now, if you want to do, or let's say employee order by salary in descending order, but you want to probably look at it, not all the employees, maybe the top 5 guys, right? So how do we do that? So I'm going to copy this over here. Okay, and once I run that, of course, I'm going to get all the 14 records, but I'm not interested in 14 records. I'm only interested in the, what do you call, the first 5 records actually. So this is where the limit clause comes in. Okay, and limit always takes into numeric numbers, so I can do a 5. Okay, so what the system is going to take is it's going to run this query, but it's going to limit the records to the first 5. Okay, here we go. So go, these guys are the highest paid people in the company. All right, so what if you wanted to pause the video and then try the poor guys who's not being paid very well, like maybe the first 5 guys who's not being paid well. So your employee say, hey, your manager say, hey, give me all those guys who's not being paid well, but I only wanted to limit the last 5 guys actually or so. So how do we do that? So why don't you pause the video and do the needful over here. Okay, so we're going to take out the descending, and I am going to run that. And these are the poor guys, 960,000 or so. So James, follow all the way to the Martin. This is the records actually. Okay, so far we learned order by, very, very important. We also see the limit clause help us to, or keywords which help us to limit the records. Now look at the random. Okay, the random is basically a built-in function which provides us to just extract the data from the table randomly. It has no precedence or no favor. It just takes the random data. Okay, so what about list random employee order by salary in descending order, but with limit of 5 records actually. So I am going to take these guys over here. Okay, and I'm going to run that. First of all, right, this is employee salaries, right, this way. So what I'm going to do is very, very simple. I'm going to do a quick random over here, right. Now instead of order by salary, right, Probably we wanted to take list random employee, 5 random employees over here. Okay, so let's take I think the query should be like list 5 employees randomly. Okay, how do we do that? So we'll have a select star from order by employees over here, but in the order by, instead of a particular column, right, I'm going to just use the function as such. I will do it random over here. Okay, and once I run that, and this will list all the random information. So you get Ward, Black, or so, but if I run it again, you'll see different names. If I run it again, you'll see different name. So at any point in time, this wouldn't be same people actually, right? There's a possibility. I'm not saying mathematically it can be possible, right? So there are business justification of having something like that. So when you are doing this machine learning and AI or so, you want some kind of a random data, not like your data that you wanted to have access to. So these functions can be very, very useful as well. Okay. So the key things to take away over here is that you can have your order by to order the records that's coming up from the table based on your column order. Ascending, descending, by default is always ascending, but you can put it DESC for descending order. Okay, you can also use the limit to limit the record. Highly recommended. If you're running a production version, select star from columns, limit 5, limit 10, limits 20 or 100. 100 is a little bit more. Okay, and then you have the random function, which will give you like any slice of information at the same time. But again, what we did in this is that we implement this random through order by, and we also employ the limit 5 as well at the same time. Okay, so we're going to continue our journey to look at more and more information. So for example, in the next video, we're going to be looking at finding some null values in our data and maybe change null values to maybe real values. Welcome back, everyone. Often number of time when we are dealing with a data, you probably have values null in your columns. And that can be problematic because these null values can give wrong expressions in terms of data. Your query might break, and you got to do all sort of different conditions as well. Okay, so it's very important to find those null values, and then second, to convert them with something more meaningful data. And this is very simple database administration task because you're going to get a lot of this data from CSV, from your JSON files, from elsewhere. So let's take an example over here. First of all, we're going to find null values in our employees table. So if you look at select star from employee, you can find null values. So null is represented over here, over here, over here. Okay. So you have these commission column, which contains a lot of null values over here, right? So how do we access and find those values? First is very simple. We're going to do a select star from employees. Okay. And then inside, again, let's try this. I like it. So here we go. And then we'll have a where clause. And in the where clause, the column is commission. Okay. And we can do is null. All right. It's very simple. This keyword is null will provide all the employees where commission is null. All right. So you can see there are 11 people who has no commission whatsoever. Okay. So for whatever reason, basically, you wanted to transform these nulls to maybe real values because you probably wanted to use them based on some column, some data or so, right? Maybe you wanted to use it with some case conditions or so, right? How do we do that? So there are a couple of methods that you can do that. Number one, I show you a way to find all the null values. The other way is to find not null values. So this will give you is not null, will give you all the employees which does not which does contain some commission. All right, so you got to look at the both sides of the equation. Okay, so what if you wanted to find a way whereby you wanted to get all these null values to become something else? Maybe instead of showing null, you want to put them as 0. Okay, so there are a couple of methods to that. One is called call ESCE. So basically, call ESC function takes one or more values and an argument, and then function returns the first non-null value in the list. So the value of the commission can be replaced with some other number. Maybe we can replace that with 0. Okay. So how do we use this actually? So it's very simple. We're going to do select. Let's try this actually over here. Okay. So I'm going to copy and paste over here. And instead of where clause, right, I'm just going to keep it as it is. But instead of this, let's try employee ID, employee name. Okay, we'll do a salary. I'm going to also put commission as it is, but then also I'm going to put a new column, right? And I'm going to use that as the replacement. All right, so you can see side by side. Okay, so I will use a call ESCE. All right, that's the function. The function takes an argument. So what is the column that you are looking at it, right? So the column is called commission. Okay, so this is MISION, commission. And what it does basically is going to check the commission column, right? If there is a value, it's going to just return the value. If there is a null value, if there's no value, it will prompt us, say that, okay, what value do you want it to replace with all the null values? So for here, we can use a 0, okay? So I can say that commission new, right? Or something like that. Okay, so I'm going to run that, and now you can see that this employee name, salary, commission. So commission is all coming up, but then you have a new column that we just created based using the call ESC function, which takes the column, and if there is a value, it's going to just return the value. That's the value. If there is no value, if the null value, is going to replace this with this 0. Okay. So all the null values is now replaced with zeros over here. And I can put anything over here. I can put 1 inside, okay, and run it. Okay. Now, important thing, this is an integer over here. So if I try to do this over here, right, and run it, okay, what will happen? It's also going to put it over here, but it's going to turn this one to integer over here. So if I do something like that, and run it, okay, you probably get an error because this is not a number, this is a text over here. Okay, so important, whenever you are trying to do this, you should replace based on the data type that you have in your column, which is integer to integer. Okay, pretty good way, right? So you can find the null values and you can transform them to real values. Okay, so this is a one method called ESC function. That's very good. So this is really good. Okay. Now the other way is that we can use the built-in functionality provided by database administrator. Calls SE happens to work for all database. Additionally, you can even use the case statement also. Okay. Remember the case statement that we have used before, so we can use that too. So I'm going to copy this whole thing. Okay, and I'm going to use the case statement over here, right? So in the case statement, very simple. Let's do the same thing. I'm going to delete this. Whichever is easier for you, you can do that as well. So I'm going to say case n, and let's make an alias over here. So this will be a commission new as well. And in the case statement, this is where we're going to define our case. So we'll say commission is not null, right? Let's make it this way, is not null, then simply, you know what, just display the commission, right? That's what we want. Okay, if not, we have an else, correct? Else, and then you can do a 0 over here. Okay, very simple, same thing, right? So I am going to run that, and as I say, select query is an amazing query. So you can do same thing so many different ways. So once I run that, I have the same output over here as well. So if there is data, it's going to just display that as a commission. If there is no, it's going to do an else 0. Okay. Now comparing this versus this, I like to use this as well. All right. But I want to give you both cases over here. What you learn is you can find all the null values through the is null clause over here, is null keywords. And then if you want to transform, you have two choices, call ASC function, or you can use the case statement. Depends whatever you want to do it. That can be done. Case statement can be very useful when you want to even search in multiple conditions. So maybe there are conditions whereby you want to have multiple columns over here. When this column is this and this column is this, that you can use the case statement very well as well. But for a simple condition, this works perfectly as well. Welcome back, everyone. So far, we have seen how to look at the data inside our table. We order by, limit, and all sort of different things as well. We also apply some filter through the where clause as well. Okay, but in the real world also, we're going to utilize all these things, but sometimes you want to search for patterns. Patterns can be matching a row based on a particular string, or a pattern. So why not we try and apply this thing on our tables over here. Okay, so let's build some queries over here at the same time. So why don't we list all employees with department IDs in 10 and 20, all right? Now we have used before the where clause, and we can do all sort of different ways to achieve this. So I can do department ID is 10 and department ID is equal to 20, okay? And this will work as well, okay? So perfect. Let's double check, or it should be or, okay? And run it. So you have a 10 and 20 over here. But let's suppose if suddenly you have this query whereby you have, like, say these are 5 of them, right? And what will happen is that you'll have these or same thing again and again and again. Okay, so as I say, there are so many different ways to achieve the same thing as well. I want to show you another method, right? And instead of writing this, there is another keyword that we can use. So you provide a condition. So you have a column and you define an in. And inside the in, you can define your array values, okay, or the values that you want to search it. All right, so I will say I'm looking for 10 and 20, right? So either one of them, okay? So this is an or condition, either 10 or 20 or so, okay? So once I run that, I get the same results. Now this query is far more better visually versus this query. Also, if I need to add, let's say 30 or whatever, 40 inside, I can run this one, boom, instead of writing like 4 lines of or conditions over here. Okay, so that's very, very important. So this is how you can kind of filter information in our SQL query using the in keyword. Okay, so in followed by the whatever the data that you're looking. So if you're looking at numeric data, you will provide this in numeric data. If you are looking for a string data, you're going to apply string data. Let's take an example for that as well. So let's try over here, and this time around, instead of numeric data, let's try employee name over here. So employee name, and we can say we are looking 2 people. So let's say we are looking at Smith and we're looking Ward. Okay, and since this is a character data, like string data, I need to provide that in a single code. Okay, so once I run this one, I'll get these 2 records only. Okay, so in can be very used against the pattern search within a column, and then inside you provide your data. Okay, so we have already managed to get employees with department ID 10 and 20 through the in clause. Okay, so in keyword can get you that. Now what we want to do is a little bit more. So what if you say that we want to list employee with 10 and 20 and then have either the I somewhere in their name. Okay, so in their names there should be an I. So you got Miller I here, you got King over here, and then you got a Smith, right? Okay, so we're looking this. So as I say, what you are doing over here is you are searching a pattern. Okay, so how do we do that? It's very simple. Same thing. First thing first, this is already done. So we'll say, okay, fine. We managed to get the department ID done. And then we are also looking either, right? So we're going to do an and clause within that search. And inside, we are looking for some pattern search, right? So in the pattern search, in the world of PostgreSQL, you can use what you call this this percentage sign over here, right? And in the percentage sign, you can define whatever you're looking for. So I'm going to look at this way, okay? So that my expression is going to be this way. So I'm going to say that, hey, in anywhere in the employee, if I find an I, right? Doesn't matter how many characters on the left-hand side, doesn't matter how many characters on the right-hand side, okay? This will work it out, okay? So I'm going to say, okay, and the employee name, and I'm going to use a keyword called like. Okay, this is the keyword which is used to do a pattern search, like. And then inside the like, I'm going to use my percentage sign, and I'll say I percentage sign. All right, and I'm going to run that. Okay, so it's going to run these 2 conditions, and here we go. We got Smith and King as an I and I as a Miller is all coming up over here. All right. So important thing over here that I put a parenthesis over here. Okay, then I use a column. Okay, now this column has to have a pattern match, so I use what we call a keyword called like. Okay, The like basically takes whatever is inside and then try to apply this pattern. And the pattern I use is called I. Now, if I take away this, right, what the expression is going to look for, of course, department 10 and 20, but it's going to look at employee which name starts with I. It doesn't matter how long their names are or whatever, right? So we're not getting any data over here. Okay. Now, if I take away this and I say this, what will happen is that it will say, okay, I don't mind any, whatever the name that they have, at the end of the name would be an I. Okay, so this is, think of it, this is more of a regular expression. Okay, so since we are looking at either somewhere in their name, this will work over here. Okay, all right, so this is working very, very well. Now let's extend that a little bit more and then say that yes, we have their name, and maybe in the job title we want anywhere ending with er. Okay, so we want the job title to be end with er. Okay, so how do we do that? You want to give it a try. Okay, now important thing is that we're saying that either or in their name, or. Okay, so I'll give you a little bit hint over here, so I'm going to copy that. Okay, I'm going to do an or over here, and this is where you're going to do something. Okay, so you're going to apply a column, you probably use a like keyword, and then you'll build an expression. Okay, so why don't you try that, pause the video and try it at your end, and we're going to do it together later on. Okay, so we got the job, all right, and then we can look at like, right, and I can do all sort of different thing. I can do it this way as well to make it even better, whichever is fine for you. And in the quote, what we are looking title ending with er, right? So should I do it er person over here? How many you will say yes, this will give us the result? Let's double check over here, right? Okay, so I'm going to run this one. Okay, let's try that. Select, here we go, and let's run that over here. Okay, so do we get anybody which has or job like er? No, we still get the same data, but then this is not a correct data, right? Correct, because what we are looking, of course we are looking I, but we all wanted to look at the job which has er, right, at the end. So we are looking kind of this guy, right? So instead of percentage, I'll use the first anywhere, but at the end has to be er. Okay, so once I run that, of course we're going to get more data. All right, so you get a 10 and 20, but then suddenly you have more people showing up over here because their last job is basically er. So er over here. So this is a manager. Okay, so these are the things that you can use to find pattern search in your database and so. All right, so play around with that as well. Maybe you wanted to try out and say, hey, you know what, I want to do this as such, right? So let's double check over here, and now you'll see no records, right? And if I do it this way, so let's try an or over here, and I'm going to just run it first with this. Okay, so this is the record. I get 10 and 20, an employee name starting with this, but then you have an or over here, right? And then within the or, what will happen is that it's going to look at this condition and run it, and then you're going to get more data actually, or so, because you have 10 and 20, which is perfect. Then you have employee name like I, so these guys I, but then they are not the I over here, right? So this expression is running either, right? So either this or that. That is the reason the Johns and Clarks is coming up by their name doesn't start with does not have any I inside, but since the job title has the ending er, they are showing up. Okay, so practice all these different combinations, and because this is essential for you to play around with the data and then find data stores. In the previous videos we have seen how to do a sort our database on order by clause. In this video we'll be looking at a little bit more in terms of advanced, like sorting on a data dependent key. So first of all, let's look at it how we can sort on not a single column but on multiple columns. So why don't we try to solve this query? List employees first by department ID in ascending order. So very simple, we have a select from employees. We want to list employees first by department ID. So we have a department ID and we want this in ascending order. Okay, so how do we do that? ORD as an order by, and then inside we'll do a department ID. Now, how many of you will say we should put ASC over here, and how many of you will say no needed? Correct. By default, the sort is in ascending order. All right. So if I run this, I will get all the employees based on ascending order of departments, all the 10 first, then 20 and 30 and more. Okay. Now, what if we want to do multiple sort, as in like multiple column? So same query, but this time around we want to first sort by department ID in ascending order, and then salary in descending order. All right. So how do we do that? So very simple. We'll do an ascending as an ASC, and then we'll have a comma, and then I can put the second one as an salary, and we want this in descending order. So we're telling the system that, hey, first sort of department ID and then sort salary. So what essentially we are looking over here in this query, if you were to visualize before even running it, I mean, this is how you can push your things, is that before running the query, you see what's the typical output is going to be. So what we are looking is, we are looking the highest salary paid people in each of the department. Okay, that's what we intend to do. So once I run that, here we go. So you can see that in department 10, whatever the department is there, you have the highest salary first. Then in the 20, 20, 20, you have highest salary and then lowest and lowest. And then so far, like in 30, department of 30, you have a highest salary and so, okay. And we can do even a reverse over here as well. And this time around, we don't have to kind of do the needful. So I'll run that. And then as you can notice that I don't have to put ASC over here. All right. So this will give you all the lowest paid to the highest paid over here. All right. So this is how you can run sorting on multiple columns. All right. Now, what if you want to sort based on some conditional logic actually? And this is where you'll probably be looking at more of advanced stuff in terms of sorting. So for example, let's create a query. So we want to sort all the employees based on the following, i.e., if the job is a salesman, okay, if you have a salesman over here, right, we want to sort them in such a way that we want to sort them on commission, right? Commission, okay. Otherwise, we'll sort them by salary. How do we do that? All right. So we are sorting based on the data, i.e., if the job is salesman, we're going to sort based on commission. Otherwise, we're going to sort by salary. Okay. So how do we build that? So let's take this over here, copied it, right? How do we do that? Any idea, anything that you want to do it over here? Anything we can use it over here? Maybe order by or so. Any idea, guys, before we can jump in and show you how we can do that? How about we can try a case expression? Yes, we can define a case expression. So when we do a conditional information in terms of like conditional filter or so, you should always look at the case expression. So we can utilize the case expression over here. All right. So how do we do that? It's very simple. After the order by, you are not limited to provide a column. You can put a expression over here as well. It's very, very powerful. Okay. So we're going to use that over here. So we'll do a case by, all right. And then order by first of all, and then we have a case, and then we have an end. And let's call it as you know, maybe a custom sort. Okay, custom sort as well. And since we are doing an order by, we don't need an as an alias over here, right? So we can just do case, and then inside we'll do a when. And I like to wrote first actually the minimum contents over here, right? So when we have a job equals to salesman, okay, it's all capital letter. Then what we want to do is basically what we are trying to do is that we wanted to take the order by column over here, replace accordingly based on the data. Okay, so we're telling the system that, hey, case when job is salesman, then what column do we want to sort by? Commission. So we'll say it is commission. Okay, commission, right? Otherwise we have an else, and else is basically a salary. Okay, as simple as that, right? So from the query, it looks like, oh man, how are we gonna do this and difficult? No, you gotta settle down once, you know, very simply. So we're looking at select hours from employee, order by, and then we have a case. This case is going to return the columns accordingly. So let's run this baby. Here we go, right? So what we are looking over here is the following. So with the use of the case expression, we dynamically change how the results are sorted. right? And the value passed to the order by will be like this, right? Okay, so here we go. So we have the data right now, right? We have information pertaining to all the order buys over here. So we have sales information over here, right? All the salespeople. We want, if this is sales, we want to based on commission. So commission is over here. And remember, commission is in ascending order because we're not putting anything ascending, descending. So you have a lowest commission over here first, and then you have highest, right? Over here, you have a salesman over here, right? And then you have a salesman, correct? So this is working really, really good. Now, the other thing that you can also look at it is that if this is not a salesman, right? These are the guys, then we want to sort them by salary. And again, the salary is not in ascending order whatsoever, right? It's not in descending order. So in the salary you have 960, then you have increasing as such, and then if you go over here, manager 2650, 29750, then increasing. Okay, so this query is working really, really good. All right, so there are multiple methods to kind of do that at the same time as well, right? So for example, I can even write the same query in a different way. So I can define, let's say, select. Okay, let's do select from employees. Okay, and I just want to show you there's so many ways to do that. Maybe you want to pick up the top 5 guy, you know, the guys. Maybe you want to limit the cards or so. It's up to you. So what we're going to do is let's try employee ID. Maybe we'll do employee ID. We have employee name. Okay, let's do a salary over here. We'll do a job as well. Okay, and we'll do a commission. Okay, and then after here, let's do a case, and then we'll do an end case, and we can say a custom order. Okay, and inside the case we can define the same thing. When a job is equals to salesman, okay, then we'll put a commission. Okay, otherwise else we have the salary, right? So we'll put is else a salary over here, a salary, right? And we'll have an end inside. Okay, so there are so many different ways you can kind of achieve the same thing as well. So if I run this one, let's double check over here, we have a comma and run it, and you can see the information at the same time. Okay, so this is all how you can define your information. So this is our custom order actually, and then the custom order basically is going to give you, like, this is actually a commission. So this column is either a commission or a salary over here. Okay, for normal people it will be salary, for salespeople it will be commission. Okay, so another method whereby you can actually replace the value of the column interchangeably as well. Okay, so try to use this actually at the same time. Sorting query result is one of the core skills that you probably will need it in the SQL. The order by clause can be very powerful, but we have to make sure that we use it correctly at the same time. And it's very important to master its uses, because as many of the things that we'll be looking at doing in the later part of the video, this will be essential over here, right? Pretty exciting, right? Using the case in order by as well as the case to interchangeably change the information over here. All right, so this is how you can utilize, i.e. the sort on data dependent keys and more. Welcome back everyone. In this video we will be looking at how we can combine result data sets from different tables together, right? Now for that we're going to create some temporary table, or I would say some fixed data tables as well. So let me prepare that over here, and this is something we're going to be using it later on as well. And these are very simple tables, so I'm going to create a simple table first. I'm going to call it create table T1. Okay, let's make it T1, and this is basically nothing, it's just a simple ID, and this will be int. All right, nothing much, so very simple, no primary key. I mean, if you want, I can do a primary key, and then let's make it ID as a primary key. Okay, as simple as that. So I'm going to create that. Table is created. If I do a refresh over here, that's a T1. All right, similarly let's do a T10 table as well. This is something you will be using it later on as well. So I'm going to create a T10 table as well. So that's been created, and then I'm going to do a T100 as well. All right, for now just create these ones. I'm going to show you later on how you can utilize them over here. Okay, so basically in the T1 we'll have some data inside. So let's do a quick insert into T1, okay, and then this is ID, and we'll do a values, and inside we'll just put 1. Okay, very simple. And let's run that. This has already been added, and if I do select star from T1, you can see that you have 1 data over here. This is 1. Okay, similarly, let's insert with 10 as well, T10, but the values are going to be 1, 2 and 3. So let's do that over here. I'm going to copy a couple of times. Okay, we need just 10 values. So 2, 3, 4, 5, 6, 7 and 8, and then you have 9 and you have 10. Okay, don't worry about it why we are doing it for now, because we are going to use these tables later on as well, and also with the exercise over here. Okay, so again, if I do T10, we'll see these temporary tables with some lines of code. Actually, the idea over here is to create these tables to help you to show you how you can stack tables together or so. Okay, now we have our table created. All right, let's stick to what we intend to do. So let's try and list employee name and department ID for department 10. So how do we do that? Select from employees. Okay, and then we'll do a quick where clause, and then we'll say department ID is equal to 10. All right, so we can see that information is there. Let's do a star so that we can get all the columns over here as well. Okay, so we got all the columns. Okay, what if we are only interested in employee name and department name? So let's take employee name and department name as an ID. Okay, so let's run this one. Okay, fine. Now one important thing is that this one is character, this is integer. All right, take it off. Now similarly, let's list all the department name and department ID. So we'll look at select from departments. Okay, and inside we are looking departments. So department has columns, department ID and name. So we'll do department name, and then we have a department ID. Okay, very simple. Let's run this one as well. Okay, now this is also character, this is also integer, right? So the structure for those two output results are same, meaning the data type is same. So the idea over here is, can we combine them? Yes, we can, and that's what I want to show you, what we call stacking the result sets together. So I'm going to run this one. Okay, and I'm going to copy also this thing as well. Okay, now if I try to run this, let's say together, what happened over here? So we'll say it's select error, because you say, hey, you know what? Yeah, there are two different queries together. What do you want to do? Okay, so what we intend to do is basically do a union. Okay, in fact, you want to do a union all. Okay, and once I run that, here we go, no error. So what happened is that very first query will give us the employee name, department. You can put it whatever you wanted, actually, that's fine. Okay, we can make it as journal name as well. Okay, and this is a Clark, King, Miller, and then you have a name of the departments over here. Okay, why we managed to combine them together? Because they are of the same data type. All right, so that's very, very important. Now what if you want to present like maybe a little bit better, maybe you want to put it like some lines inside or so. So you know what, you can do that as well. I can do and utilize my temporary tables that we create, like T1, and I can say select, and then I can put some dashes over here, right? There we go. And then since we need two columns, so this is the first column, is going to show a dash over here on the department ID or so. We'll provide a null. Okay, and we'll say from T1. Okay, and I'm going to combine everything from here, and of course, since we have the second query, so this is our first query, correct? This is our first query combined with this. Okay, second query, and then we need to combine that again, so we're going to do again. Okay, union all, and we have a select. Okay, so we have three queries combining together. Okay, let's run that and see what happened. Here we go. We got Claude, King, Blur, and you have some dashes showing that, hey, these are two different data sets, but same properties in terms of type, character varying, and integer, but they are different. Okay, so you can utilize these temporary tables in this manner or so. Okay, so what we did just now is that we used the set operation union all to combine all these rows from multiple tables. So very first table was employees, the second table was in temporary table, the third table was from department. Okay, So you can combine these tables together as long as these are, or the output is of the same type. All right. You can also do a conversion on the fly as well. So if the output is not there, you can make the columns to convert from integer to string, a string to integers, and all sort of different things as well. Okay. But the key thing to mention over here is to show you the usage of the operation union all. Right. Now, what if you want to combine, but then you want to filter out duplicates, right? So duplicates mean you got 10, 10, 10, 10, 20, 20. So we probably want only the records which has no duplicates, okay? So how do we do that, right? So in order to make sure to do this and remove the duplicate over here, we can take the same query over here, all right? And what I'm going to do is I'm going to copy, but instead of union all, right, I'm going to say union. Okay, that's simple as that. Okay, and let's run this one. So basically union will remove the duplicates over here. So if you notice what happened, the previous query and this one, is that this query runs in such a way that it is basically removing the duplicates over here. But the problem is that because we have this dashes over here, this doesn't like it in terms of like, you can't do a union over here. So what I'm going to do is I'm going to make this as two queries over here. Okay, and once I run that, now you can see that you have the duplicates removed over here, right? So the duplicates has been moved over here, and we have things like clock, sales, operation, research, programming, king, and so all of them are unique over here. Now you must be saying that, hey, you got 10, 30, 40, 20, but you have 10 still coming up, right? The reason being is that this union is working on a first column over here, like employee names, and it's actually taking this whole two column as a one entity. So it's going to check clock and 10. Is there is any other clock and 10 inside our query? There's none. Is there is any sales and 30 in our whole set? There is none. That's why you are getting this. So when you're doing union, combining multiple columns together, you have to take each row as one record. Okay, so to make it this way, that whereby you have only one column actually in terms of like providing the information and union. So for example, let's take the employee name out, and I'm going to just get the department ID. All right, and now we have only one column, right? And if I run that, now you can see that this only unique item 10, 20, 30, and 40. All right, as I say, practice make perfects all the time, right? Now we did this earlier, i.e. we put this whole thing, union and everything from here, right? Can we do this same thing in specifying union rather than union all of them? It most likely result in sort operation to eliminate duplicates. Now, if you have very large data sets, using union is roughly equivalent to, not really good, but then you can use a couple of different ways to achieve the same results, okay? So I'm going to copy the same thing over here, right? So I will take this two queries over here, okay, and I'm going to run it, and I will run it union all. So first of all, what's going to happen is you're going to get all the records, okay? Now what I can do, I can employ an inner query and outer query, okay? So I will say, okay, fine, I want the query, and then this is from, okay, and I'm going to push this query inside, okay? So this is my outer query, all of it. Okay, and let's make this over here, right? So this will work as well. So I will do, let's say select star, and I have to put an alias, let's say X, okay, and I run that. Of course it's going to run it 10, 10, 10, but this not contains it contains all the record, but not distinguishing the duplicates. So we want to remove the duplicates. For that, what I can do is that I can do a distinct right keyword, and then I can supply the column name, department ID. All right, as simple as that. So this is another way we can achieve the same thing as well. Okay, and now you have a 10, 20, and 30, right? So different methods. SQL is very, very universal. The select statement is a very universal thing. You can do lots of things together or so. Okay. So in this video, what we saw is that we can combine result sets from multiple tables together. Okay, we can use the union all or union. Union will eliminate the duplicates. Also, we saw a method whereby we can do a inner query and then all the data from the inner query. Although we are using union all, we can then take that outer query from here as well. What I like about the outer queries, this is style inner and outer queries, that I can run then a lot more filtering at the same time. So when you try to do filtering somewhere over here, it's not going to work really well, okay, because you're combining data together. But once you get all the data up ready with your side, then what you can do is you can do an outer query and then apply filters over here at the same time. Maybe you can say, hey, where department ID is greater than, let's say where department ID is greater than 10, okay? And once I run this one, you will see that anything but 10 is not there. So 20, 30, 40 is up here, okay? So this is how you can do combining or stacking tables together. Welcome back, everyone. In this series of the video, we'll be looking at hierarchical queries. This is something essential that you should look at it as a database admin. Hierarchical queries are the queries whereby you have a concept of parent and child. So let's look at an example over here. Let's see our example of our employee table first and see what's the employee and manager relationship looks like. So I can always do a select and a star from employees, okay? And let's run this first. As you can see that you have employee ID, employee name, and everything. But one important thing to do is every employee ID also have a manager ID. All right. So let's print that over here. So we got employee ID, and you have a manager ID. Let's run that. So you can see that every employee ID has a manager ID. Now, a couple of things to note over here. Number one is that the manager ID is also stored side by side to an employee ID, i.e. it doesn't go to any other table. Okay, now that might be debatable that you might need to make this manager ID to a separate table. One of the cases may be that an employee might be managed by more than one manager. That in that case, instead of one-to-one relationship, you probably want to create a new table. Okay. But set aside over here, the important thing to note is that you have a parent-child relationship over here. All right. So for example, this might be considered as a parent, let's say manager ID, and this might be considered as a child, or vice versa, right? But the important thing to note over here is that for every employee, you have a corresponding manager ID. So it's more of a one-to-one relationship. Now, even I try and do an order by two, right, just to look at it, the employee's information, but based on managers. So you can see that this particular employee has two employees to take care. So this can become more of a parent, and these are the childs. Then 1, 2, and 3, and 4. This is manages four employee or 4 kids actually, right? So this is what we call the hierarchical queries over here. Okay, so we need to produce the following results. So you have a column name, employee, and manager. So you probably need some kind of an alias. Now we need for every single employee, we need to put in such a way that it shows its manager name at the same time. Okay. So you probably need some kind of a concatenation as well, like works for, colon, and everything have a space. So why not you try at your end and see whether you can do that or not. And once you've done that, pause the video, come back to us, and we're going to do it together. All right, so let's go for it. Okay, let's look at this output over here, what we need to develop. So we need to make sure that we have two things. Number one, we need to know the employee name as well as the manager name. So we need to, first of all, take care of it. All right, so we can do step-by-step way to handle this. All right, so I can say select from employees. Okay, so if I do employee name over here, as if I print that, I can see my employee names over here. Okay, now we need the employee manager name also, and we know that the manager also resides in the same table. Okay, so what are some of the things that we can do? Can we do a kind of a self join or something? Yes, we can. All right, so we will have the two employees name over here. Let's make it an alias over here. So I'll have the first table as an A, and then let's do another one, employees, as in B, and then I'm going to do a comma B dot employees. Okay, and name. All right, so if I run this one, what will happen is the following. So you'll have 196 rows of X. This is more of a Cartesian products. Basically, for every single employee, is going to run for all the available combination. Okay, now this is what we don't want that, but at least we got the employee name and the manager name over here at the same time. All right, but what we need to do is basically we need to filter this, right? So how do we filter? We're going to do a where clause. Okay, and inside the where clause we're going to say that a employee ID, manager ID in fact, right? So if you go to the employee table, you have the column, and then you can see that manager ID, we can connect these two employees inside. Okay, so I'll say b.manager ID. Okay, now if I run that from 196 plus, now we have a 41. Okay, but the problem, you can see that this manager ID. So do you think this is a correct way to adjust or connect these two tables together? No, because we need to make sure that the A manager ID is equal to the employee ID. Okay, once we do that and run it, now we can see that this Smith is basically works for Ford. All right, and just to double check, there are a couple of ways to do that. Let's do a quick select star from employees, employees. Okay, and once I run that, you will see that Smith, his manager ID is 13. So where is the 13? 13 is Ford. All right, so that's correct, right? So let's run this one, and now you can see that this Smith is basically working for Ford. All right, so first thing first, we managed to get the record that we needed over here, right? What we need to do a little bit more concatenation over here. So what I'm going to do is, since we know we have everything, I'm going to take this one out, or you know what, I'll just leave it as it is. I'm going to make a copy so you guys can kind of do the same thing at your end. Okay, so what we're going to do is we will say a employee, and we will do a concatenation over here, right? So we'll say works for, and then we'll have a concatenation B. Okay, and once I run this one, you can see that you have a Smith works for Ford, Allen works for Black. The only thing remaining over here is do a quick alias over here. So we can say as, we'll say employee and managers. Okay, let's run that over here. Okay, so you can see employee and managers. Smith works for Ford, Allen works for Black, etc., etc. Now we can even do it this way. Let's do an order by, and then we'll do it order by the what do you call, manager ID. So we can say manager ID. Okay, and once I run this one, you can see that you will see all the Johns first, then Black, because this is based on the employee ID, not the employee name over here, right? So there are a couple of things you can even do. Is you can say, okay, employee as a manager, employee ID, or I would say employee name. Okay, and let's run this one, and now you can see that all the managers alphabetically is first displayed, then followed by Clark, then Ford and Johns and everything. So you can do a lot of different things. Okay, so this is how, what we did is that we take a hierarchical query and build it with a parent-child relationship. Parent over here is basically manager, and you have a more child for manager as an employees. Okay, so we managed to get the employees and manager using the concatenation method. Can we do the same in subqueries? So let's try that. Why don't you pause the video at your end and try out, and we're going to do the same thing over here too. All right, so let's build our query. So we'll probably want select, and the very first thing we need is the employee name. May not be the same output, but I just wanted to show you that how we can do the same thing with a query. Okay, so after this, we're going to build our query inside subquery, or inner query, I would say. Select, and then we will do a b.employee name, and basically what we are gathering over here in the inner query is just the manager name. Okay, so we'll say from employee B, and then we need to do a condition, correct? So what should be the condition? The B should be what exactly? It should be the employee ID equals to a.manager ID, right? That's it. And we're going to call that as manager ID. Okay, and then or manager name, and then last but not least, we'll do from employee A, right? Because this is referencing the A. All right, so this is how you can do the same result using the subqueries, right? So it depends whatever you are looking for. If you're comfortable with the concatenation like self join, this works too. So you can see Smith, Ford, Allen, and again order by two, right? I can do a descending order or so, which is the manager name. Okay, so you can see all the Blakes, Clark, Ford, Jones, everything is coming up over here, right? So it depends whichever the query that you wanted to look at it as well. I normally tend to use the subquery more, but from the performance point of view or so, it doesn't matter. I mean, you've got to probably run the whole thing. You got to run the explain, and this will give you the query optimizer, how the query runs. So you're looking at hash join over here, then sequential scan. And if I do a explain over here, right, it's probably have a kind of similar way of accessing the information as well. So you got a sequential scan, index scan is done. So it depends what's the output looks like. So this shows 108 milliseconds, and this shows, let's try 103 milliseconds. So it depends. So you got to try out all these things as well. But the key thing that you wanted to look at it in the hierarchical secure queries is you want to find out the parent or child, which is the parent, which is the child, and then you have to use the self join together, or you can use the subqueries to retrieve the same results and more. In this video, we'll look at it, the employee and manager relationship, more of a single parent and single child relationship. Over here, we're going to express a child, parent, grandparent relationship. So it's more of a sub-hierarchy or multiple hierarchy that we're going to be looking at it. Okay. So let's look at the query output that we have done earlier. So you can see that you have the employee name and then you have his manager. Okay. One thing, if you notice over here, is this Miller. Miller actually works for Clark. But if you look at it, Clark also works for another person called King, and King is the CEO of the company. All right. So from the Miller, what looks like Miller is, let me just do this one. So Miller is basically working for Clark. Okay. But then Clark is actually in turns working for King. All right. So you have like a child, then you have a parent, and then grandchild relationship. Okay, so how do we achieve that through the SQL query over here, right? So let's code this one, right? So since we are looking at Miller, we're going to be concentrating only on the Miller record for now. Okay, so with this, we're going to be looking at recursive queries that is available in the Postgres SQL, right? So the structure is going to be something like, we'll say with recursive, okay, recursive, and then inside the recursive, okay, and then let's call it X, and inside at the end of it, what we want is, we will say, let's take an example of tree. We'll take a manager ID, and then we'll do a depth. Depth means like how depth it is, like 1 or 2 level or 3 level. Okay, so this is what we're going to do that, and inside we'll have some subqueries, and then at the end we will be properly looking at select star from X. Okay, so this is a pretty much the structure we're going to do. So we're going to do recursive, and then we'll output everything inside. So at the end of the day, what we are looking is to build something like leaf, branch, and root. Okay. Now inside, what we need to do is, first of all, we need to do is to select all the records, right? Select only Miller. Okay. So that's what you're going to do that. And then after that, what we're going to do is we're going to probably do a union all with another query. And this query basically is going to run a depth actually. All right. A depth as in connecting to the tree and all. So let's look at it one by one. So first of all, let's look at select, and we're going to do from employees. Okay. And what are the columns that we are looking? So we're going to do probably a cost, because we need to prepare and do it in such a way. So it'll say Miller, branch, and root, etc., etc. Okay, so let's look at it over here. So I will probably use a cast, okay, just to concatenate everything inside. Okay, so let's do that over here, and we're going to say cast, and inside the cast, let's take the table name called employee name, and let's make it varchar, and let's make it 100 characters. Okay, so that's the first. Okay, now we do need within the employee, important thing what we are looking is, we only looking for the record for the employee name Miller, correct? So this is what we're gonna get. So within the employee, we'll get the employee name, and then after that we are looking for manager ID. Okay, and then after that I'm going to put a depth as in 0. So remember, we have a tree manager ID and depth, so I'm going to do a 0 depth over here, right? So it's going to pick up the data inside. So if I run this one now, right, so you can see that you have all the data, but if I do it with the thing like with only Miller, so you can see Miller is the one, this is the manager ID is 7, and then the column that we are looking at 0, which is the depth column. Okay, so first query is pretty much okay. So we're getting the Miller record, but we'll take this and I'm going to pass on to our recursive query. That's the whole thing that we're going to do. Okay, so the second query would be select. Okay, so we're going to do employees. Okay, and let's call it E, but then we're going to connect our recursive query over here as well. So I'm going to be connecting with X over here, and then inside the X we're going to say that we wanted to make sure that X manager ID, right, the one that we have, is equals to the employee ID. Okay, so we are connecting these two tables together, right? Recursive table and the inner queries over here. Okay, now what we needed is the following. So again, we'll do a cast. All right, and this time around what we're going to do is we'll do, let's say, employee name as varchar 100. Okay, so that's the first column, and then we need the e.manager ID. All right, so this we needed, and then since we have the depth right now, like the one that we have over here, so I'm going to take that from the X. This is where the recursive queries comes in. So I'm going to pass X, and I'm going to actually add +1 as well. So because this is going to run recursively inside our inner loop, right? So you'll get 0 and 1 and 2 over here, and once we finalize that, this will be even more easier to understand as well. Okay, so we got depth +1. All right, now what we can do is, if I try to run this, it's not gonna work because this has to go to recursive and everything as well. Okay, so let's run this way first with the whole thing. So we have the cost employee as employee var. All right, we have a manager and everything, so I'm going to run that first. Okay, and here we go. So you can see that Miller is there, this employee ID, manager ID is 7. This is the first step. Then after that, it actually goes to from this employee, which is the manager ID 7, is now checking that who's his manager. This is a 9, which is a king, and then once it reaches to king, it's checking which is his ID. Manager ID is none. All right, so this is what we did, is we did a recursive, we looping inside from child to parents to grandparents. Okay, so this is output is pretty good. Now let's try in such a way that it actually shows the child and parent over here with by means of arrows or so. So we need something like a leaf and branch or something, so it should say something like that. So why don't we do that? So I'll come to the second query, and I'm going to use X tree. Okay, so this is where we are getting the tree column, and then after that, let's concatenate inside. I can do a simple add arrow over here. All right, and we are pretty much ready. So let's look at it over here and run it, and now you can see that Miller is individual. Then you have a Miller is actually reporting to Clark, right? And then from here, Miller to Clark is actually reporting to King. All right. So you can see the depth is being created very first time, 0. Okay, then after that it's +1. This is where we did a +1 because we are running a recursive queries, and then it goes to +2 over here, right? It's awesome, right? Okay, so this will give you the, what do you call it, the child to parent to grandparent hierarchy. And so PostgreSQL itself is a very, very powerful way to do that. Now we can even do it in such a way that if you only want the depth level, let's say 2, we are looking the final result, I can even run it this way as well, and this will give me the Miller, Clark, and King. Okay, so depends what you are looking for it as well. Okay, so this is how you can create or express a child, parent, and grandparent relationship. Hello everyone, in the previous video we have seen the child, parent, and grandparent relationship. So let's take the same concept, let's move it a little bit more further, i.e. let's create a hierarchical view of a table. So you might be exposed to a table whereby you have a parent-child relationship or so. how do you express that by the form of a query? Okay, so we're going to be using the same query over here that we have used before, but then the output that I'm looking is the following. So you'll have employee tree as a one column, and inside it will start with the very first name of the employee, which doesn't have any manager as ID associated. And then it's going to go from each level over here. So it's going to first level depth, second level, third level, or whatever it is, right? So you can see that this is a pretty good hierarchy view of the table. So you have King, Blake is reporting to King. Then after that, Ellen is reporting to Blake, and then James also, and then you have Martin and Turner, etc. Then you have, after that, you have a second employee, and then you have a child parent relationship or so. Okay, so this is like a grandparent, you have a parent and then child relationship over here. So this can go at any depth as you want. So why don't you try to create this through the recursive query that we built over here, just to give you a hint that you need to put a condition over here in such a way that is always a start with a employee which doesn't have a manager ID. Okay, as long as you can do that, we should be pretty good over here, right? So why don't you pause the video and do the needful. Okay, let's build this and see what the output looks like at your end. So again, let's build recursive. So we'll say recursive, and let's call it X. And inside, since we are looking for employee tree over here, so I'm gonna just put let's say two things over here. So we'll just do employee name and employee ID. Okay, and then I'll take it as X. All right, and in fact we'll do a subquery over here, and then inside the inner query we'll do all the needful, but output what we are looking is, I'll start with select star from let's do it over here. So we'll say star from X. Okay, as simple as that. Okay, so we'll build step by step. So the very first query that I mentioned to you, what you need to do is to make sure that you take the employee, the very first employee called King. How do we do that? Because this employee is the CEO. All right, so what we need is, we need a condition where employee, where manager ID, in fact manager ID is null. Okay, so this will give you King. All right, so once you have the King, then you'll do the recursive from King. So again, let's do a cost, and then we'll do employee name, all right, as varchar. Let's do it 100. Okay, and then since we are looking in two tables over here, so let's pass employee ID as well. Okay, so this basically gives you what exactly is going to give it to you. It's going to give you employees. All right, and run it, and then you'll give you King, right? So, and then within the King is going to give you the employee ID, and this is where the recursive is going to come up. Okay, so after that, what we need is union all. Okay, and then after that, we are going to be looking at again another select, and this is where we're going to loop the whole thing. Okay, so first thing first, let's look at the table that we will be interacting with. So employees will be alias as an E, and then we're going to take the recursive X over here. But the condition is pretty much the same as what we have done before, right? Which is X manager ID is, or E manager ID is equal to X manager ID. Okay, so this is how we're going to do that. So in this, we had the manager ID equals to the employee ID. We're going to reverse that because we are starting with King. Okay, so let's do that over here, and inside we'll do E, which is the employee manager ID is equal to X dot employee ID. All right, so we're starting with the King. Again, let's do a quick cost. All right, and inside the cost, let's do a E dot employee name as varchar 100. Okay, and let's do E dot employee ID. Okay, as simple as that. So let's take this step by step and run it and see whether we get data. So we can see that you have a King followed by John, then Blake and Clark and everything. So you do have the hierarchy that we needed. What is missing is that we need like king to be added inside, and then if there is any other hierarchy inside of king, and then greater than black and greater than, it's probably going to be like king greater than John, then you have a king greater than John, greater than black. So for that, we'll use the same thing. We're going to cast, and this time we're going to look at the recursive, and in the recursive we do get employee name. Okay, so we're going to add that employee name. This is coming up from here. All right, so we'll do a grid sign, and inside we'll just pass this one. Okay, so now once I run this one, you can see that this is far more what we are looking for, right? So you got King Johns, King Blake, King Clark, King Blake Allen, King Blake Ward, all sort of different things. Okay, now one thing that we can also do is to just make sure that everything is okay, right? We can do an order by one over here, which is the employee name. All right, so let's run this one again, and now you can see all the kings first. For accordingly it's coming up. So you have a grandparent, whatever, then from grandparent to parent, and then from parent you have a child relationship here as well. Okay, so this is pretty good over here. One thing we can do at the end, we can even say, okay, this is the employee name as employee tree. All right, and let's run this one, and now you can see that this is our employee tree. We don't need the manager ID anymore. This is the whole structure of the table. You see, with a very simple employee table, we can do a lot of data analysis, data stories as well. So what we did in this exercise is to create a hierarchical view of a table. The same strategy you can be applied to any table which has some data whereby the same information is kind of recursively appear in the same table. Like the employee ID and the manager does exist, both of them exist in the same table. So you can use the hierarchical view of that table or a similar table and much more. In this video, we're going to be looking at finding all child rows for a given parent row. So for example, let's take an example of employees who works for John, and they can be directly reporting to John or indirectly. So how do we build this query? Okay, again, your friend over here is the recursive. So we're going to do the same concept, X, and we'll do recursive, and then inside we'll do a employee name and employee ID. Okay, and then we'll have a subquery inside, and then what we're going to do is we're going to do a select, probably employee name, which is from, let's do this over here, from what is table X. Okay, so first thing first, as we always do, is we need to provide the very first root condition over here. So let me just copy that over here, right? Or let's just do a simple one over here. So we'll say employee name, and then we need employee ID Y for our recursive query. Okay, and then we'll say from employees, and then we are looking which employee. We are looking employee name of employee name is equal to Jones. Okay, so let's run this first just to make sure that everything is okay. Right, so you can see, yes, Jones is there, so we got the employee over here, and I'll do this one as well, more organized. And then after that, once we got this data, we're going to do union all, and inside we're going to take this whole information and pass it to the recursive query. Okay, so we'll say from employees, and then we'll have E and X. Right, now the condition over here is we want all the employees which is directly connected to our employee or indirectly, right? So we're going to say X is employee ID is equal to E dot manager ID. Okay, so we need that. And again, let's do E dot employee name and E dot employee ID. Okay, as simple as that. So let me run this whole thing and see what happened. So alias goes later, and let's run this one, and now you can see that you have a John, Scott, Ford, Smith, Adams, all are showing up over here, right? So this is how you can directly check a child, print all the child rows for a given parent row. So the key thing over here, as you probably notice, is that this is the first line, which is very important. So this basically starts from here. Then you pass on the employee name and ID, and it's recursively basically loop inside and do the information based on the condition that you put it over here, right? So this is how you can find all child rows for a given parent. As we go through with the parent-child relationship, essentially what we are looking is to find per each row, whether this is a leaf row, is a branch row, or is a root node. So how do we find out if a row is either a leaf, branch, or root node? So on our table, what we have, we can come up with some calculation in such a way that we need to determine the type of the given node of a given row, i.e. is it a leaf, is it a branch, or root? So for example, a leaf node would be if an employee who is not a manager, so like King, okay? Then a branch node is an employee who is both a manager and also a manager, okay? So that would be a branch. So it's employee who is both a manager and also has a manager, okay? A root node is an employee without a manager whatsoever, okay? So this is like a King. A leaf node is an employee who is not a manager, okay? So if you read it from here, this is root, then it goes to branch node, and then from the leaf node, okay? And what we want to do is we want to return true, 1, or 0 for reflect the state of each row in the hierarchy. So this is the output that I am actually looking for it. So you'll have employee name, is leaf, is branch, is root. So as you can see that King is not a leaf, is not a branch, is actually a root because he's a CEO of a company. Followed by that you have a Johns, which is basically not a leaf. He is actually a branch because he is a manager as well, okay, but he's not a root. Okay, so that's in Black, Clark, and Ford, and Scott. And then after that, you have the individual employees who is just employees only. These are leaves, all right? They are not managers. They are not someone who doesn't have a manager, okay? So I'm looking to output this information. So you wanted to pause your video and then see whether you can come up over here. Give you some hints is that you probably want a following structure. So you probably have a select, okay, and I'll probably do an employee name, all right? So that's the first one, okay? And then after that, we need the is leaf, is branch, and is root over here. So you're probably looking at 3 scalar subqueries to determine the correct Boolean value, either 1 or 2, okay? The other thing, just give you a hint, is you can do a sign method whereby it's basically, and maybe you can do a count to count the rows based on the condition. And the condition I mentioned over here is a root level as an employee without the manager, branch level, and leaf level. So why don't you try to do that at your end and see you got the result similar like that, and we're going to combine our efforts together. Okay, so why don't you pause the video, practice make perfect, practice make perfect, okay? And we're going to come back again. Okay, so we got the select e employee name inside, and let's create our 3 scalar subqueries. Okay, and again, this is not the only way to access and output this information. This is one of the way, because SQL is so powerful, you can do the same thing in a very, very different method at the same time. Okay, so what I'm going to do is I have my employee. I'm going to prepare a 3 scalar queries over here. Okay, so first query that I'm going to run will be select, and since I'm using a sign, I'll do a count, okay, and a star. This is what we want. So I'm looking for a leaf. Okay, so what is the condition for the leaf? A leaf is an employee who is not a manager. Okay, so this is the condition that we need to put it over here, right? So first of all, we're going to say that, okay, we are looking for this, and from employees, okay, and let's make it a table called D, all right, as an alias. And then here we're going to put a condition, all right, where I'll do a condition in such a way that 0 equals, so because we need someone who's it's basically leaf is node whose employee is not a manager, so we're looking at 0. Okay, now inside the 0, this is where I'm going to get the second scalar query or subqueries, and this will say select star count over here. and then we'll say from employees. Okay, let's do an F. Okay, and inside the F we'll do a quick where clause. So where condition is f dot manager ID is equal to e dot employee, employee, employee ID. All right, and this will be a leaf. Okay, as is leaf. Okay, that's what we have. Okay, so this will be a leaf. All right, so the very first thing what we're looking is that if, how do we find leaf? If the leaf node is an employee who is not a manager. Okay, so that's why we have a 0 over here, and we'll say if f manager ID equal to employee ID, it's going to give you ETH leaf because it's not a manager, because we want to return the 0 over here. Okay, and as I say, sign, whenever you run it with a number, if the number is positive, it's going to give you 1. If not, it's going to give you 0, and that's what we are looking over here. Okay, so this leaf is being calculated. Now let's do a second scalar. So we'll do a select. Again, we can use a sign over here because we already used a sign for this one. So this one will be count star, and then inside count star we'll do a from. Okay, and then from we'll say employees. Okay, let's do a D, and then here we have a condition, and we are looking for is branch. So is branch condition is a branch node is an employee who is both a manager and also has a manager. Okay, so let's define this condition. So we have the D employee, so D manager ID is equal to E dot employee ID. Okay, but we need additional one, correct? And we have an end clause over here. I can do it end, and then E dot manager ID should be null or is not null. It should be not null, correct? Okay, so we'll say as is branch. Okay, so A has to be manager and also has a manager. Okay, it's not null, that's why we are looking at it. Okay, so ID. Okay, now we have the last scalar inside query, so we'll do a sign again, and then we'll count a star. Okay, and then from, okay, employees, and let's do it this one as a D again. All right, and then what we're going to do is we're going to do a where clause. Okay, and then the where clause will say D dot employee ID, and we are looking is root. So a root means is an employee without a manager. Okay, so we'll say employee ID is equal to E dot employee ID. All right, because we're passing out from E, and the D dot manager ID should be null or not null. Is null. Yes, it is null. Okay, I'm going to call it is root. Okay, all right, so pretty much our 3 queries are all returned inside. Okay, so this is the is leaf condition, this is the is branch condition, this is a is root condition, and we are taking this whole thing from employees. Okay, what is the alias we use? E, so let's pass that with E. All right, and I'm going to just run this first before the order. Okay, so let's see, and then run it. Okay, let's double check where the error coming up. Okay, so we got the null must be missing somewhere over here. Oh yes, that's fine. Okay, because we got the select already inside. And let's run and see the results. So you can see Smith is leaf, right? Because let's look at the king. So is the king is leaf? No. Is it a branch? No. Is it a root? Correct. All right, so let's look at a manager. So Smith was a manager. It's a leaf over here, which is employee. Okay, let's look at Jones. Jones was a manager, so it cannot be a leaf, it cannot be a root at the same time. Okay, this is looking pretty good. Now let's do an order over here. So we'll do an order by, and let's do it 4, right? Let's do a descending, and then 3, let's do descending 2. Okay, and let's run this one, and you can see now this everything is pretty good, exactly what we were looking. So we got king is root, then you have all these managers, okay, because they are branch, and then after that you have individual employees as a leaf. Okay, Side by side, we managed to calculate whether the row is a leaf, branch, or a root node. Okay, so I highly recommend that you practice this at your end, try to change here and there, and then apply that to your own tables or so. So this is how you can analyze hierarchical data inside your table. In this series of the video, we'll be working with numbers. So we'll be looking at how SQL or PostgreSQL query can help us to compute with a lot of functionality with numbers and more. So let's look at the average and maximum and minimum values. So let's compute an average in a column that can be achieved by means of averaging for all the rows or for some subset of rows. Let's take an example. Let's compute the average salary for all employees. For that, let's print all the values in our employees tables. Okay, and I'm going to select that and run it. What we are after is looking at the average salary over here, and then we want to compute within the salary column an average value. So how do we do that? We can use the average function, and I can pass the column, and as always do a very good alias to represent the information, and it's as simple as this. So the average salaries for all the employees in all the rows is 2234.64. Okay, now what about the average salary for each department? And this is where we are running or computing average in a column, but for some subset of rows. So I can copy the same thing over here and run it. What we need to do is we need to do a group by. So we are converting our all rows to some subsets of rows by means of applying group by. Okay, so I can do department ID, and once I run that, this will give us the average salaries for each of the department. One thing that we can also add is the department ID inside department ID, and this would be far more better. Okay, so 30, 10, and 20. Okay, one thing also we can do is maybe we want to look at the highest average salary. So for that we can do order by, and then I can do and descending. Okay, for the average salary column, let's plot that based on the highest salary. So department number 10 has the highest average salary, department 30 has the lowest salary as an average. Similarly, we can use the min and max value. So find the lowest and highest salaries for each employee. I can actually copy this one over here, and instead of using the average, I can use the min function, and let's change that to min. And similarly, we can do max as well. Okay, so max would be max function salary as max salary. Okay, and again, what we can do is see what are the maximum and minimum salaries for entire employees over here. So minimum salary is $960 per guy. The maximum is $5,200. Similarly, why not you pause the video and try to find the lowest and highest salaries for all employees by department ID. Okay, why not you pause the video, try out, and then we're going to run that ourselves together. All right. So let's see over here what we can do. We can add a department ID first. Okay, and then after that, I'm going to apply a group by. So we are subsetting the all rows to a group by. So this will split our output in terms of splitting every single thing to a department ID, and then our average functionality, minimum, maximum functionality, or computive functions will run on each of the department ID data sets. And now you can see that department ID, minimum salary, maximum salary. So 30 has a 960 minimum, maximum salary is 3,000, 10, 15, 5,200, 20 is 1,000, and 3,200. Okay, now with this simple query, you can get a lot of data stories out of it as well. And this should be your goal. Whenever you're applying a query to your data set, you want to find some facts and figures out of it as well. So this is one of the ways you can play around with numbers in SQL. In the next video, we're going to continue looking at some other information like summing the information, running total, and much more. So let's head over to our next video. Bonjour everyone. Let's continue playing with numbers. So let's look at how we can do the summing of a column value. So let's compute total salaries for all employees. Similarly, we use the average function. We can use the sum function, and we can apply to a column, or this can be an expression as well. Okay, I can call that a sum all Let's try total salary. Okay, and let's run this one, and this will give us the total salary. So 31,285 is the total salary that we give to each employee. But what if you want to compute total salary for each employee, for all employee by department? How do we do that? Let's do the same thing that we have done before. Number one, let's put the department ID so we can know which salary is where, total salary. And then after that, we'll do a group by department ID. And let's run this one. And this will give us the department and the total salaries. Okay. As you can see, let's try and see the highest salary, total salary by a department. So we can do 2 and descending. 2 refers to the second column over here, and then do the needful. Let's run this one, and now you have our department 20 has the highest total salary that people put it over there, and then followed by 30 and 10. Okay. Now let's similarly, we can do the count as well. So for count, I will do the same thing. I'll copy this one. So let's count total number of employee. Similarly, we have a count function. Okay. And instead of putting a column, I can do a star and then run it. And let's do total employees. Employees. Let's run this one, and this will give us the total employees. So there are 14 people. Okay, but what about the employees, total number of employees for each department? Same thing. We're going to do a department ID, and then let's run this one. Missing is group by department ID, and let's run this one, and you can see that you have the departments and total employees in each of it. Again, you want to find the more concentrated employees where they are. I can do that with a order by department ID, and then in fact we're going to do 2 and descending. And let's run this one. You can see the highest number of employees are in department 30, followed by 20 and 10. Okay, pretty easy, right? But pretty useful. So you've probably seen that these are very basic queries that you are running, but these are very, very effective when you are doing complex calculations and formulas and more. Okay, so let's continue our journey to our next video, whereby we were looking at the world of running totals and much. Welcome back, everyone. In this video, we'll be looking at how we can generate a running total. For example, you want to compute running total of salaries for all employees. Okay. So how do we do that? Let's build this query. So we'll probably have a select and from employees. Okay. And then inside the employees, let's print all the columns first, so we can see which columns which we are going to be work with it. Okay. So maybe we want to try the employee name, and we want to take the employee salary. So first thing first, let's take the employee name, and I'll take the salary as well. Let's take that. So now we have a data. All right. What we intend to do is that for every single employee, we want to compute a running total over here. So how do we do that? There are multiple ways you can achieve that over here. One of the effective way probably to use the window function, because window function allows you to compute the aggregate over a set of data. So how do we do that? Very, very simple. So what we're going to do after the salary, let's create another column, and I'm going to, since we are looking at running total, we probably want a summary function. The summary function we're going to apply to which column? Salary column. Correct, salary. And what we are intend to do is that if I try to do it this way, I'm going to get an error because there's no group by to complement the sum over here. So instead of that, we're going to use the over as a window function, and then let's run that first over here as a running total. Okay, so I'm not supplying any order by or anything whatsoever. Okay, so what should be the expected output? The expected output would be all. This will sum everything inside. That's why, because it's saying that yes, apply the sum function over a window, but over here we have nothing inside. So there is no partition by, there's no order by over here. So it's taking the entire data sets. I'll take all the data, all the rows, and it's going to sum that equals to 31,285. So what we're going to do over here is we're going to order our result sets in such a way that we're going to take this by salary in ascending to descending order. For that, we're going to do order by salary. Okay. Now, once I run this one, what will happen? Here we go. So now you have very first row, James, and it's the order by salary. Okay, the very first running total will be 960 because that's the one. The second one is about 1000, so it's going to combine these two together. 960 plus 1000 is going to be 1960. Okay, similarly 1960, and now you have a 1400, so it's going to combine these three values over here, and you have a 33600, 3360, and so on. Okay, now we are getting the running total over here, right? All right, so we have the sum salary over order by salary over here as running total. But let's take a look at this one. So we have 960, 19160, then you have 1400, this combined all three values, then you have 3360. Then after that, you have a 1450. We'll combine all these four values. This is 6260. But if you see over here, you have again another employee which has the same salary, 1450. But the running total is not correct. It should be like sum of all these values, but it is not showing up over here. All right. So our running total is incorrect. How do we fix that? Because what happened over here is you have a salaries has been duplicated over here, right? So when you are doing a window function, you have a subset of data that's been extracted from all rows. So how do we make this as more of a unique combination? So one way to solve this, and this is very important to note in when you are applying the window function and aggregate, this will happen. These kind of things that you should know about it. So one way to answer this or compute this would be to find a combination of salary and a unique number. So we're going to take salary plus combine with something that will give us a more of a unique data inside, and that will be applied and then computed with a sum salary. So what do you think? Do we have any unique column over here in our entire table? Any ideas? Yes, we do have it, and it's called employee ID. So by combining order by salary and employee ID, you basically telling the system that now you take the all rows that I have, but split them in such a way that you have a salary plus the employee ID as a one single row. Okay, and that will trigger a uniqueness. And once I run this one, now you will see that you have a perfect running total. So even though you have a 1450, which is 1400, you also have a 1450, you have a correct running total over here. Why is that? Because the system takes the entire data, take the salaries and the employee ID as one single row. Okay, so this becomes more of a unique row because you have an employee ID unique. The employee ID 1 or 2 is not being assigned multiple times. So you only have an employee with the employee ID 1. Okay, so this is how you can run a running total and generate a running total for salaries or anything or so. Now this is very, very important when you're applying a window functions because you are subsetting the information, but you need to make sure that you have a unique values for each row so that you can compute your aggregate function and much more. In this video, we'll be computing the moving averages. So what is the moving average? By definition, the moving average can be calculated by summing the current value and preceding n-1 values and divide by the total number of n and represent whatever the total values that you have in terms of count. Okay, so normally the moving average is being calculated by means of like a 3-point moving average or 2-point moving average. When we say the 2-point moving average, you're probably taking 2 rows and then computing a moving average is okay, but normally traditionally you probably want to do a 3-point moving average, and this is what we're going to do it over here. For that, let's create a simple table. I'll call it daily sales. We'll have a transaction date as a primary key, and you have some sales numeric data. So let's build this one, and I'm going to do a refresh. So you now have a daily sales, and inside let's put some sample data. So we have insert into daily sales, transaction date of sales, and you have some daily data. Okay, so I'm going to run this one, and once it's run, let's build a very simple query over here. So this will give you all the data that we have within our sales. Okay, so let's compute our moving average over here. For moving average, there are a couple of things. For example, we want to sum the current value and preceding n-1 value. So current value we already had. So this is the first row, the second row, this is the third row, we have current values. Now we don't have a preceding n-1 value, so we will print n-1 values over here. So any idea how do we do that? Any idea from your side? I'll give you a hint. Maybe we can use a window function. Yes, we can use the lag function. Okay, we can use the lag aggregate function over the window. Okay, so why don't we build that over here? Okay, so we'll say select from daily sales. Okay, first thing first, let's take the transaction date, and I'm going to take the sales. Okay, so let's build our column step by step. Okay, so we got the data, transaction, sales. Now we need a lag one, as in like lag data, one data up from the previous sales. So how do we do that? We can do a lag. I can apply to sales column, and I want to go back one level up. Okay, and I'm going to apply that to over. Now over here, what we should do, order by sales or by transaction date? Yes, order by transaction date, and I'm going to make this as sales lag 1. Okay, and if I run this one, here we go. So we can see that the very first row there is null value because there is no one data up. The second row we have 561, the previous value is 647, is shown over here. Third row is 741, the previous value is 561, shown over here. Okay, so we got the data all there. So we got a current value, and then we have a preceding n-1 value, and we can divide that with n. So as of now, if you want, you can calculate the moving average fine. But what I want to do is I want to calculate a 3-point moving average. So basically, instead of calculating the 2 rows and then calculating a moving average, I want to take the 3 moving rows over here and calculate the moving average over here. So this will be like this: 647, 561, 741 plus divided by 3, and then you calculate the moving average over here. Okay, followed by that is going to go to 561, 741, 970, and it's going to apply that over here and give you the moving average. So we are calculating a 3-point moving average. Okay, since we are talking about 3-point moving average, we need also the sales lag too, meaning we need to go back 2 values up and try to get the data. So we can always do that over here. Again, I'll use the sales to lag and then go to all 2 level up, order by transaction date, and let's call it 2. Okay, I'll make a comma and let's run this one, and here we go. So very first column null, of course. Sales 2 is also null. Second column, the very first value, of course, 641, but there is no 2 level up, so that's fine. But the third row is correct. So 741, the very first one, sales level 1, is 561. But if you want to go back to 2 level, this is what we have, 647. Okay, so now we can calculate a moving average over here, a 3-point moving average. Okay, so we are pretty much ready. So I'm going to combine all the values. Okay, so first of all, I have my current value, so I'm going to start over here. Okay, and I'm going to combine that with my lag. Okay, so I can do this over here, sales 1. Okay, and I will say over order by transaction date. Okay, that's 1, and then I'm going to add another values. Remember, we are calculating a 3-point moving average, so I'm going to take lag sales 2 as well. All right, and I'm going to say over order by transaction date. Okay, that's all good. Okay, and so we have our current value, we go back 1 level up, we go back 2 level up, we combine all of them, and then since we have the 3 values, right, so you have 1, 2, and 3 values, so we're going to divide by 3 over here, and I'm going to make that as moving average. Okay, as simple as that. So let's run this one, and here we go. So we got the data. So if you combine 647, 561, 741 plus and divide by 3, you'll get this value. Okay, so this is a 3-point moving average. In a moving average, what we call this a window. So if somebody say, okay, I want to calculate a moving average, you would probably ask us, okay, how many window size that you want to have it. So you'll say, oh, I want 2 or 3 and 4. That you can do that. Some people in a traditional world of stocks, you have 10, 20, 200 moving average, or 500, 50 moving averages as well, 50-day moving average. So this is where we are representing the 50 and 200 as the moving window values over here, as in like the amount of the window that we want to calculate. So right now it's 3 points, so it's going to take the first 3 rows, then it's going to push over to the next 3 rows, then it's going to push over to the next 3 rows and compute the moving average over here. Okay, so this is how you can calculate the moving averages on your data. The strategy that I run is on a numeric column. So if you have any numeric column in your database, same strategy can be used to compute the moving averages over here. Okay, so I would highly recommend that maybe you want to try a 5-day moving average on your sales, and then say that every 5 days, running 5 days, what is your average looks like for your sales. And so let's calculate the mode. So what is a mode? A mode in mathematics is the element that appears most frequently for a given set of data. Okay, so if you have a large amount of data and you want to see what is the most common data that comes within that data sets, this is where the mod can be useful. So let's take an example and apply that over here. Let's find the mod of the salaries. Okay, so we know that in our table we have the salary. So let's try select star from employees. Okay, oh, in fact from employees. Okay, that's what we are going to do, that employees. Okay, and let's run that, and you can see that your salaries are here. So you can see if I do order by, that's probably be better, order by salary. Okay, so we want to see the ones that repeats or most frequently appears, right? 960,000, 1400, 1450. Yep, that's one. Okay, and then you have 3000 over here as well, right? So the kind of 2 mods are there actually that's repeating most frequently. Okay, so let's calculate that over here. Now we have a lot of other departments as well, so maybe we want to concentrate on maybe department number 20. So we'll say this one over here. So we'll say, okay, fine, we are looking for everything, but let's take out the order by, and I'm going to say where department ID is equal to 20. Okay, because I want to take a particular department and then try to do the mod over here. So now you can see that within that you have 1000, 2970, 3200, and then you have a 3000 over here, right? Or you know what, one thing that I want to do, instead of department 20, let's try and look at a department whereby you have a little bit more of a duplicate. So you got 3000, 3200, you got 3000, 30 over here, 30, and I wanted to actually change the Scotch salary to 3000 so that we can kind of do the needful. So let's do that. Update employees. Okay, employee set salary equal to 3000, where employee ID is equal to exactly what, 8, right? So let's run this one, and here we go. So this has been done, and if I run department ID 20, now you have 2 of them. That's what I want to demonstrate that. So it's pretty good. Okay, so that's good. Now what we need to do is the following. So first thing first, let's build our query. So we'll say select from employees. Okay, and let's take where ID is equal to 20. Okay, and what we need to do, probably we want the salary as such. Okay, so that's what we are looking. We're not looking which employees or so we're just looking salary. So that's what we are looking. Okay, so to answer the mod, what we're going to do is we're going to do a couple of different things. We're going to do some inner queries to calculate, and we're going to use the dense rank window function to rank the counts of the salaries to facilitate extracting the mod. Okay, so let's do that. So first thing first, for salary, we need to check how many times individual salaries has appeared. So how many times 1000 is appeared, how many times 2975 appears, etc. So for that, what we can do a count star, and I can say as CNT over here. Okay, and what we're going to do is, since we are looking the count, we need to make sure that we group by what exactly? Group by salary. Correct. Okay, so this will give us the salary. How many times 1000 comes within this group? Once. How many times 3000 comes? Is twice. Okay, so this is a good stuff. Okay, so we already got one step done. Now what I'm going to do is I'm going to pass this whole thing as a inner query. Okay, so I'm going to say select star and then from. Okay, and I'm going to pass this whole thing inside. Okay, so we are building step by step. Okay, Okay, and I'm going to push this one side, and let's call it X over here. Okay, so let's run this one, and now we have an X. All right, so we got this whole information is all good. Okay, now what we need to do, since we have the data by means of all the counts for each of the salary, we're going to use the dense rank, and we're going to rank that based on the count over here. Okay, so dense rank basically allows us to look at a rank. It's actually pre-calculate the ranks and everything as well. Okay, so let's do that over here. So where I'm saying select star from this salary, right, I'm going to do this the following. Okay, so I'll take this. So we do need this salary. Okay, now on the second column, right, since we have this data that's coming up from here, right, so I'm going to run the dense on it. Okay, so I'll say dense, D-E-N-S-E, rank. Okay, and I'm going to run that over, and then we want this order by CNT, right? And if I do order by CNT, which is count, what should I do, descending or ascending? What do we want? We want more salaries that appear more time to be up coming up top, right? So we're going to do a DESC. Okay, and let's call it RNK over here. Okay, and I'll say select salary okay, from, and this will be there. So once I try to run this is what happened. Okay, so we got the salaries. This is the rank, right? So RNK is being shown. So this shows 3001, 2 is 2, 1400 is 2, 2975 is 2. Okay, so this is all coming up over here, but there is a problem over here, right? So as you can see, salary dense over order by CNT rank. What we need to do is to make sure that we also apply this whole thing as a separate query. Okay, so what we're going to do is now we're going to take the salary, and as you can see, the dense rank basically compute this, and then now it's showing 3000 as 1. This says that, hey, this happens more often actually. So what we need to do is pretty much take out whatever the query is there, we're going to pass in such a way that whereby the rank is equal to 1. That's it. Okay, so I can say select, okay, I can do even star from, okay, or whatever. I can do even like this whole thing. Let's just take this thing. I like to move this whole thing over here, and I'm going to say X and Y over here. Select star and run it. Now you can see the same values are here, but what we are looking is where we want rank RNK to be equals to 2. Is it? No, 1. Okay, and now if I run this one, now you can see that, hey, this is the salary, this is the highest salary, or this is the mod within an employees table whereby it appears more often, like 3000. Okay, so what we did over here is that we go from inner query, we take the data first. All right, we count salaries by means of group by. Then after that, with this data, we apply a dense rank. Okay, the dense rank is basically going to look at more frequently counts. It's going to count them as 1 and 2 and 3. That's happened, and we did it in such a way that order by CNT descending as well. Okay, so we did a dense rank order by CNT descending. So this is all coming up, and then after that, what we did is we just take only the ranks whereby the rank is equal to 1, which shows that the mod for this group of user salary is 3000. So 3000 is the common thing. Now imagine this query, you can run it on stock market data, weather information, or anything whatsoever, and this will be able to tell you the most frequent data point that appear in your small or large data sets and more. So this is a very powerful query. Again, what we are in on the quest is to find the data stories from our data. Okay, so this is how you calculate a mod within a given set of data. Okay, everyone, in this video we'll be looking at calculating a median. So a median is the value of the middle number from a set of order elements. Okay, so let's take an example over here. We have employee salaries, and what we're going to do is we're going to take the employees whereby department ID 20, and let's order them by salary. So let me just reconnect my server. So you got 100, 14, 2900 or so. It's all in order by. So the median calculation is going to be that it's going to be a value in the middle member of the set of the order number. So it's going to be somewhere over here. perhaps 2975. Okay, so how do you code that? So let's double check over here. So we're going to say employees. Okay, and what we need to do is we have a very good function called percentile count, and we're going to take 0.5 out of it. All right, and we are going to say even within group. Okay, and inside the group we're going to say order by salary. Okay, so this will give us all the what you call the average median, in fact the median for all the salaries. But what we are looking is where department ID is equal to 20. Okay, so let's run this one and see what's the value. 2975. Remember I mentioned to you it's in the middle value. So if once I run that again, you have a middle value. 2 over here, 2 over here. This is the middle value. And now we are getting it over here with a help of percentile count 0.5, which is 0.5 is like a middle number. 1 is the essential, minus 1 divided by 2 will be 0.5 over here. And we are talking about within group. So within the group, we have supplied that and we say it's order by salary. Okay, so if we don't do the order by salary, you'll have a different number. All right, so this is where we can use the window function percentile count to find the median. Okay, now let's continue and looking at some more. For example, you want to look at the averages without highs and lows value. Okay, so you have a business case whereby you wanted to take the averages. Well, you don't want to compute within the highs and lows, right? So you're looking at a information which is minus the maximum high and minus the low value. Okay, so how do you do that? You can use the subqueries to exclude highs and lows values. All right, so let's do that over here. So I'm going to say select from, and we're going to say employees. Okay, so first of all, we are going to take the salary. Okay, this will give all the salaries. All right, employees, EMPLOI. Okay, employees. So you got all the employees over here. All right, so that's good. But let's suppose we wanted to take in such a way that we wanted to take the average of this employee salaries over here, but we wanted to exclude highs and lows numbers. So how do we do that? So this will give you all the average salary 222.3570, which is fine. But what we want to do is we don't want to take the maximum high and maximum low values. Okay, so if I do select and I'll say max salary, okay, from employees. Okay, so this will give me the maximum salary. Okay, so we don't want to take this value, so minus that. And also if I do minimum, well, we don't want those records which has 960 and 5200. So other than that, we want to take and compute average without the highs and lows value. So how do we do that? It's very simple. So we can define a where clause, and inside the where clause we can say the salary not in, and inside the in we can define our select query itself. Okay, so first of all, the one that we have is this one, right? So we're gonna say select max salary, okay, from employees. Okay, and also we're going to take a comma because we are in a array, like in inside not in list style. So we're going to take this with the comma, and then the next one is min. Okay, so I normally try to do it min and max, so I know and it's in kind of order or so. Okay, so once I run that one, now you will see that our number is different. It previously was 22 something. Now we have a 2077 because it's excluding the minimum salary and the maximum salary. So where clause can be very, very powerful. Not only you can define a column, you can do an expression, and then within the column you can define in a value, like whereby you want to take not in a particular values inside, and it's going to exclude that over here. Okay, this is how you can compute averages without highs and lows values. Welcome back, everyone. In this series of the video, we'll be looking at how we can do the date arithmetic. So we'll be taking and manipulating dates with some kind of add, edit, delete functionality and much more. So let's take some example one by one. We got our table from employees inside, and we have a hire date. So this is the column that we'll be interacting a lot more. So let's try and add and subtract date within this column. So maybe you wanted to see each of the employee 5 days before the hire dates and what was the 5 days after the hire date. So how do we do that? This is fairly very simple. In the world of database in PostgreSQL, you have what you call interval. So I can use the interval keyword to do the needful. For example, how are we going to do this? It's very simple. Select from employees. Okay. And what I want to do is to look at the hire date first. Okay. So this will give me all the hire days, irrespective of the people. I mean, if you want, you can put employee name as well. Okay. So this will give me employee name, hire date as well. So Smith hired on this day. So what I want is two more columns. One will take this date and then add plus 5 days, and then the other date would be take this date and minus 5 days. Okay, so it's fairly very simple. What we can do is we can say hire date, and then we can use the interval. Since we want to add, I'm going to use the plus sign. I will say interval. Okay, and inside the code, this is where I can define months and days. So always start with a number. So I'm going to say 5. Since we are talking about day, I'm going to do a day. If you want a month, then you'll do month. If you want a year, you'll put year. Okay, it's very simple. So let's call that hire date 5 plus, I would say plus 5 day. Okay, let me just run this one first to show you the information. So 2019, 12, 15, if you were to add 5 more days, then 15 plus 5 is going to be 20. 0420, that is 0425. All right. Similarly, if you want to pause the video and see whether you can find out a way to subtract 5 days from the hire date, how would you do that? So why don't you pause the video and then come back and we're going to do it together. Okay. So it is as simple as turning from plus sign to minus sign, and I'm just make it minus over here. Okay, I'll take this one out. Okay, and now you can see that this interval keyword will help us to do the needful as we're looking at. So 2012, 2019, 12, 15. So if you were to minus 5 days from 12, 15 would be 12, 10. If you minus from 04, 20, minus 5 days, it will be 04, 15. Okay, this is as simple as that. So you want to manipulate the data, adding an additional new dates or so, this is, you can do that. So if you want to do month, you'll do month over here. So what it happens is that it'll take the same hire date, but it's going to add 5 months on top of it. So 12 is the December, and now you have 0515. Okay, and if you want to look at year, you'll just do year over here. So this will add 5 years from the current date. So 2019 plus 5 years will be 2024, 12, 15. By the way, I'm in 2023, by the way. So that's very important actually. So in fact, I mean, you can look at it how this whole thing works or so. So 2020, so 2020 plus 5 would be 2025. Okay. Now, interestingly, you can take the same concept and then you can do a lot of great things. For example, if you want to determine the number of days between 2 days. All right. So for example, we know that we have employees, Smith and Allen all. So let's try and see the hire date for Ward, okay, and then hire date for Allen, okay. And what I want to do is basically we want to find a way whereby we can do a 2 inline views to find the hire date for Ward and Allen. So once we find those days, we want to subtract one from the other. So how do we do that? For this, if you notice, we need to first find the hire date for Ward and hire date for Allen. So why not we do that first? So we'll say select, okay, from employees. Okay. If you want to pause the video and do it yourself, absolutely. Practice make perfect. So either you type along with me, code along, that's another way, or you want to pause and try out, that's even better. Okay. So hire date, and we will have a condition called where employee name is equal to Ward. Okay, so this will give us the date for hire date for Ward. Okay, similarly we have Allen, correct? So I'm going to take Allen, Allen, and let's take his hire date as well. Okay, so this is his hire date, 2020 0420. Okay, but what we are looking at is basically taking the Ward hire date and minus that with Allen. So how do we do that? Okay, Very simple. We can use this as inner queries or so at the same time. So I will do a very simple over here. So I'll say this is a select hire date and var, and let's turn this one to a query. Okay, so I'm going to take this and let's call it X over here. Okay, and then I'm going to take this whole thing as well, and I'm going to turn this one to Y. Okay, so we got we got the data which is coming up from here as considered as X, and then we have a data that's coming up from here considered as Y. So we got the queries already ready. What I want to do is very simple. I'm going to do a select. Okay, we know that we are going to get the hire dates, both of them, so maybe we can rename that as, let's say, var hire date. Okay, and this one would be as Ellen hire date. Okay, so we got two columns, so I'm going to do very simple. Let's try select star. Okay, and I will say from, and we have the whole thing inside, correct? As simple as that. Okay, so let's run that first. Okay, let's run it, and you can see that we got the var hire date and we have Ellen hire date as well, correct? So what we need to do is very simple. We just need to minus. So let's put var hire date. We have Ellen hire date. Okay, and what we are going to do is we'll just take var hire date minus Ellen hire date. Okay, that's it, and let's run this one, and we are going to get our values. Okay, so let's double check. We have Ellen hire date, we got a comma, and let's run this one. Here we go. So it's just 2 days. All right, so it's only 2 days apart that they've been hired together. So 2020 04 24 22 or 2022 04 20. Okay, so as you can see, the difference is just 2 days over here. All right, so this is how you can find number of days between 2 days as well, because dates formats are same, so you can basically use a simple arithmetic to find the days between the dates as well. Okay, let's continue our journey in the next video, whereby we're going to look at, let's say, number of business days between 2 days and much more. Bonjour everyone. Let's take how we can compute a date differences. For example, we want to compute the following query. For every employee in department number 10, you want to determine the number of days between the day they were hired and the day the next employee, can be in another department, was hired. Okay, so let's take that over here first. So we have employees. Let's print their name, employee name, and then we'll do a hire date. Okay, let's do a simple hire dates over here. So what we are looking basically is the ability to compute that in such a way that we have Smith. So whatever the next available hire date is there, we want to take that. All right, so most probably we want to do an order by as well, hire date, and also we want a where clause whereby department ID is equal to 10. Okay, so let's take that and run it. Now we'll see all the employees. So this is the 2020. We want the next employee over here, then you have a next employee. But what we want to do is to count how many days are there. Okay, so that's what we intend to do. There are a couple of methods we can do that over here. We can use a method of scalar subquery to find the next hire date relative to the current hire date. So we can use the lead window function for that as well. So let's draw that over here. So we can take select. Okay, we'll take from employee. Okay, and let's take a condition. I'm going to copy it for here. Okay, so this will give me all the employees. But from here, what we're going to do is we're going to take the department ID. Okay, we'll take the employee ID. Okay, employee, let's take employee name. All right, and then we're going to take the information pertaining to employee hire date as well. Okay, so hire date. Now so far what I have done is I've taken all the information from employee table. So why not we take the E over here, references as an alias. Okay, and we also do a E as in department E. Right, now what we also wanted to do is the following, i.e. we wanted to make sure that all this information is displayed first. Okay, so we got the department, we have employee, we have a hire date as well. Okay, all good. Now what we are looking is that from this hire date we want the next hire date. So how do we do that? It's very simple. We'll do a lead, L-E-A-D. We'll do it for hire date. Okay, by default is 1, so I'm going to just keep it as it is, over. And then inside, should we do order by employee ID or date or so? Yes, we need to do it date. All right, as next hire date. And let's run this one. And here we go. Okay, so number 1, hire date. That's the column. And let's run this. And now you can see Clark was hired 2020-06-09. The next hire date was 2020-11-16. So that's the one. King was hired 2020-11-16. The next person that was hired was on 2021-01-23. 2021-01-23. All right. You see how beautiful it is actually. Now what we need to do is to minus these 2 days. So what we can do is to push everything on side, and I'm going to do a select. First of all, star. Always try, make sure that everything is all good, working. Okay. So we're going to do all this inside. All right. Right. And let's call it X, and let's run this one first. So we got the whole data. Perfect. Right. So now we have a column hire date and next date. So now over here, what we can do is we can say, okay, we want all the columns, okay, from this, but then also we need the next hire date minus X hire date. Okay, I will say differential. Okay, and let's run this. Here we go. So the next hire date was about 160 days later. We have a second employee hire. Then from there, after the second hire, which is the CEO, the next employee was hired and 68 days later. Okay, so this can be a very powerful query to understand and look at the date differences over here, right? So we have a subquery which does the magic. We have a lead which takes the next available next hire date as well, and side by side push it on the same row as well. So this lead lag is really powerful as well. Okay, and then we turn everything into a subquery, scalar subqueries, and then once we have all the columns, we manage to do all kind of different expression and much more over here. So this is how you can simply do a date differences with different logic and much more. Bonjour everyone. Let's take how we can compute a date differences. For example, we want to compute the following query. For every employee in department number 10, you want to determine the number of days between the day they were hired and the day the next employee, can be in another department, was hired. Okay, so let's take that over here first. So we have employees. Let's print their name, employee name, and then we'll do a hire date. Okay, let's do a simple hire dates over here. So what we are looking basically is the ability to compute that in such a way that we have Smith. So whatever the next available hire date is there, we want to take that. All right. So most probably we want to do an order by as well, hire date, and also we want a where clause whereby department ID is equal to 10. Okay. So let's take that and run it. Now we'll see all the employees. So this is the 2020. We want the next employee over here. Then you have a next employee. But what we want to do is to count how many days are there. Okay, so that's what we intend to do. There are a couple of methods we can do that over here. We can use a method of scalar subquery to find the next hire date relative to the current hire date. So we can use the lead window function for that as well. So let's draw that over here. So we can take select. Okay, we'll take from employee. Okay, and let's take a condition. I'm going to copy it for here. Okay, so this will give me all the employees. But from here, what we're going to do is we're going to take the department ID. Okay, we'll take the employee ID. Okay, employee. Let's take employee name. All right, and then we're going to take the information pertaining to employee hire date as well. Okay, so hire date. Now so far what I have done is I've taken all the information from employee table. So why not we take the E over here, references as an alias. Okay, and we also do a E as in department E. Right, now what we also wanted to do is the following, i.e. we wanted to make sure that all this information is displayed first. Okay, So we got the department, we have employee, we have a hire date as well. Okay, all good. Now what we are looking is that from this hire date we want the next hire date. So how do we do that? It's very, very simple. We'll do a lead, L-E-A-D. We'll do it for hire date. Okay, by default is 1, so I'm going to just keep it as it is, over. And then inside, should we do order by employee ID or date or so? Yes, we need to do a date. All right, as next hire date. And let's run this one. And here we go. Okay, so number 1, hire date. That's the column. And let's run this. And now you can see clock was hired 2020-06-09. The next hire date was 2020-11-16. So that's the one. King was hired 2020-11-16. The next person that was hired was on 2021-01-23. 2021-01-23. All right. You see how beautiful it is actually. Now what we need to do is to minus these 2 days. So what we can do is to push everything on side, and I'm going to do a select. First of all, star. Always try, make sure that everything is all good, working. Okay. So we're going to do all this inside. All right. Right. And let's call it X, and let's run this one first. So we got the whole data. Perfect. Right. So now we have a column hire date and next date. So now over here, what we can do is we can say, okay, we want all the columns, okay, from this, but then also we need the next hire date minus X hire date. Okay, I will say differential. Okay, and let's run this. Here we go. So the next hire date was about 160 days later. We have a second employee hire. Then from there, after the second hire, which is the CEO, the next employee was hired and 68 days later. Okay, so this can be a very powerful query to understand and look at the date differences over here, right? So we have a subquery which does the magic. We have a lead which takes the next available next hire date as well, and side by side push it on the same row as well. So there's a lead lag is really powerful as well. Okay, and then we turn everything into a subquery, scalar subqueries, and then once we have all the columns, we manage to do all kind of different expression and much more over here. So this is how you can simply do a date differences with different logic and much more. So these are the video we'll be looking at working with the ranges. For example, you want to return the department ID, employee name, and salary for each employee along with the difference in salary between the employees in the same department. Okay, so let's build this query over here. So first thing first, we need the department ID, we need the employee name, and we need the hire date and salaries as well. Great. So why don't we do that over here? So we have all this information. Let's pick up our information first thing first. The first step is to just print the column that we needed over here. So we'll take department ID, we'll take the employee name, okay, and then we'll take the salary as well, and then last but not least, let's take the hire date. Okay, so we got this information is all appearing. All right, department, employee name, salary, hire date. Perfect. Okay, the next thing what we need is we need to find the next salary. So once we are in the Smith, the next salary is over here. When we are at Allen, the next salary is here. So any idea where we can get this information? Yes, it's very simple to get that through lead over window function and find the next salary for each employee within their department. Okay, so how do we do that? It's very simple. We'll do a lead, okay, and then after that we'll pass a salary, okay, and then we'll pass over, okay, and then we have partition by, okay, and the partition by we need to make sure that this is department ID. And also, not only department ID, we need to make sure this order by as well. So we'll say order by hire date. Okay, and let's call it like salary. Okay, and let's run this one over here, and we should be all good. Okay, so you can see clock. All right, that's the information over here. And what we can do is we can even say, let's say, do this for a particular group or so, right? But for now, it's okay because we are getting the hire date, okay? And then after that, we are getting the next salary as well, okay? So as you can see, 26,500 was the first salary for clock. Next one is 5,200, so it's coming up. For King 52,100 is the actual, the next one is 1500, so 1500 is coming up. Now you have a 1500 over here, and then next one is 1000, but 1000 is not coming up. Why is that? Because this is partitioned by department ID. Okay, so we need to make sure that this is being taken care at the same time. As I say, that's having the same value for department ID or so. All right. So the employees hired last in the department will have a null value for the next salary. Okay. So as you can see, if I go all the way to the bottom, you'll see the null value over here. Okay. So this is done. All right. So the next step is to take the difference between each employee's salary and the salary of the employee hired immediately after them in the same department. Okay, so how do we do that? Very simple. This is where we're going to use this subquery over here at the same time. Okay, so we already had the department, employee, salary, hire date, lead over here, right? So let me just push this one inside, and I am going to take select. Okay, and I always start with the star and from, and I'm going to put this whole thing in the subquery. Okay, and then let's take that as an X or so. I'll just leave it as it is for now. And what we need is the following. So we need the department ID. Okay, we need the employee name. Okay, we need the salary. Okay, we need the hire date as well. And then since we are getting the salary, okay, and then we have a next salary staff as well, so we can take the difference, correct? So I can say salary minus next salary. Okay, and let's call it difference over here. Okay, as difference. Okay, so we can always do a bracket, but it's up to you, whichever way is fine. And once I run this one, you can see that we have the data over here. So let's do X over here, or C. All right, and let's run this one. Okay, employee, EMPLOM, and let's run this one. And now you can see that the difference is here. So clock 2600, next employee. So in fact, you know what, let's take the next salary also side by side. So I will take that after here, next salary, so we can see the actual difference. And let's run this one. Now you have the clock, next salary is here, the difference is this one, correct? It's a negative. All right, welcome back everyone. When you are dealing with a large amount of data, it's very important that you split the data. So either you get the request coming from an app to your database side, or you're running a query. It's always important to you by limit the output of the data. So there are traditional methods is like limit and all sort of different things. I want to show you a way whereby you can actually do a pagination. For example, you want to return the first 5 salaries from the employee table, okay, and then the next 5, and then so forth. So how do we do that? So we have this employee table already inside, and we have these salaries. So I'm only interested to the first 5, and then I want to return the next 5 and so forth. So how do we do that? This is where we can utilize the row number window function as well. So we can apply the row number function and then apply that on the window. Okay. So how do we do that? It's very, very simple. So first of all, we're going to take row number. Okay. And I'm going to apply that to over, and this one we can put an order by salary. Okay, and let's do the row number over here. Very simple. Okay, so I'm going to just run that, and as you can see, this will show you the row number. Okay, to make it a little bit better, what we can do is I can put a salary as well. Okay, and now it will display each of the salaries. So this is my running number 1 2 3 4 5 6 7 8 9 10 and 12. Okay, but what we are only interested is to look at the first 5. Okay, so again, what we can do is we can put this whole thing as a scalar subquery, and I can do a select straight away from here. So always do select star first, make sure that everything is okay, and then we can do the needful. So I can make this as an X and run this, so we have the same information. Okay, now since we have access to the row number and salary over here, we know that we only want the first 5, so I can utilize the RN over here. Okay, so over here I can define a where clause, and I can say where RN is between 1 and 5. Okay, as simple as that. Okay, 1 and 5. Now if you want to include and exclude and all sort of different thing, that's one thing that you can do. Okay, between, and let's run this one, And as you can see that 1, 2, 3, 4, 5. So we got the data, right? Now, if you wanted to return the rows 6 to 10, what you're going to do is very simple. Now from 6 and 10. And once I run that, now you'll get a 6, 7, and all the way 10 over here, right? So this is as simple as that. So if you want to paginate the data from your system, row number is your friend. And again, you can subset in such a way that, okay, whatever the order or partition you want to do it, you can do it over here. And row number basically auto-generate within each of the sets. And this is where, once you have the set data with the row number, you can do and apply your filtering from here as well. Okay, so this is how you can very easily use the window function row number over inline view X, which will assign a unique number to each salary in increasing order starting from 1. And this is how you can do the pagination and more. In this video, we're going to show you how you can skip a row or n rows, in fact, based on the condition. And so, for example, you want to query to return every other employee in the table employee. So you want the first employee, then you want the third, then you want the so forth. Okay, so how do we do that? Now from the query, it looks like it's very difficult. So it's actually not. It's not very, very difficult. So I'm going to show you the way. Okay, first thing first, what you're going to do is we're going to make sure that we have our employees table, and inside we're going to see what kind of information you are looking. So we probably want the employee name inside. Okay, so once I run this one, I'll get all the employees. But what I want is the first one, then third one, and then fifth one. We don't want Alan, we don't want Jones over here. Okay, so how do we do that? Very simple. Remember the wonderful world of row number, we can apply from here. Okay, so what we're going to do is we're going to say row number, okay, and we'll say over, okay, we're going to say order by, and this time around, since we are talking about employee name, so I can just do an employee name and as RN. Okay, as simple as that. Okay, and then let's take the employee number over here, and I'm gonna run that. That's it, employee name. Okay, let's comma and run that. Now you can see that this is 1, 2, 3, 4, 5. Very simple. It's auto-generated +1, right? So we are looking only the every other row. Okay. So creatively, what we can do is we can take this whole thing, turn into a query, subquery, scalar subquery, I would say, star from, let's take this and make this as X query. Let's run this one first, so it's all good. Yeah. Now over here, we can do a quick where condition. Now I can use a mod, okay, and I can say row number is divisible by 2 or not. And that's the one. So we can do a quick modulus over here. Okay, so in and you can do mod, which is basically to skip even numbers rows over here, right? So I'm going to run that, and now you can see Adam, Blake, Ford. So 1, 3, 5, 7, 9, all these guys are coming up. Okay, so this is how you can do like return every other employee, or in fact you are looking for the odd number employees over here. So the trick over here was that to use the row number over order by employee, so you get a auto generated number. Once you have the number, you can apply some maths, simple maths over here to get all the non-even number rows over here. Okay, so this is how you can skip n rows in your table and more. We wanted to limit the result set to a specific number of records based on a ranking of some sort. For example, you want to return the names of the salaries and employees with the top 5 salaries. So how do we do that? Very simply, let's look at the select star for employees, and you have all the salaries. Okay, now I can always do an order by salary over here, descending. Okay, and once I run this one, I'm going to get the highest paid salaries over here. No problem whatsoever. Okay, so this will give me all the information that I needed as well. Okay, so this is what the information looks like, and so. But what we can do is we can be creative now. The solution of this problem depends on how you want to do the data, what kind of business logic that you're looking at it. I want to introduce you over here the window function, because the window function will depends on how you want to deal with this information. And so we can use the dense rag that each tied to salary and will count as only one against the total. Okay, so how do we do that over here, right? So first thing first, we're going to use the window function dense rank over the inline view X, which will do all the work over here. Okay, so let me just take this over here. I'm going to run that, and first thing first, let's do an employee name. Okay, and then after that we'll take a salary. Okay, that's very simple. So we're going to take all the employees and salaries. Then after that, let's do a dense rank. Okay, and then you define what are the criteria. So we are actually looking order by salary, and then we don't want the salary ascending order, we want this to be descending order, right? So let's do a dr over here. All right, and once I run this one, as you can see that King, which is the CEO, has higher salary, so you have a dense record 1, 2, 2, and then you have a 3 and 4 and 6 and 7 and 8. Okay, so you got a couple of guys who have multiple same salaries at the same time. Okay, so dense can be very useful, because this actually not just add 1, 2, 3, 4, 5. It's actually look at the individual data points for salary as well, and it's going to rank accordingly. So if the same values, it's going to rank same. All right, so this is very powerful. Okay, so now it's what we can do is, once we have this death number, we can simply select a where clause out of it is, and then see, okay, how many records that we are looking at it. So I'm going to just push this one inside as a scalar or subquery, and I'm going to do select star from, and let's run this one with a inline view of X. Okay, and let's run this one, and you get the same information, right? Since now we have everything inside, what we can do is we can do a quick information, and we'll say, okay, our direction has to be that it needs to be less than 5. Okay, less than or equal to 5. And once I run that, here we go, we got all the guys, right? The top 5 salaries, which gives within the employee. Now you might say that, hey, this is not on, this is the 7 records, but why it's I only asked the 7. The reason being is that you have multiple people with the same salaries, right? So if you were to take this approach, right, and if I run that, and if I do a limit, let's do 5 over here, right? So as you can see, that you got a CEO, you got King, Ford, Scott, Blake, and Jones over here, right? So you probably think, yeah, I think these are the top 5 guys, but if you notice, you have 1, 2, and 3. These 3 guys have the same salary, so that's not a true representation of top end records, right? So limit can be used, but then what I like to do is to use the ranking, because ranking can give you a really good information. And within the rank, now this is a much better thing. So you have a group of 4 data points. Within that, you have the records over here. So this is now a much better way to look at the top end record in your table and so. Okay, so use the dense rank over the window function, and this will give you a far more better results in terms of taking a top end records within your table and more. Welcome back, everyone. In this series of the video, we'll be looking at the wonderful world of window function. So what are window functions? Window function, like aggregate function, performs an aggregation on a defined set or a group of rows, but rather than returning one value per group. So when you use the group by functionality, is normally run on the entire rows that is part of the SQL query. But in the world of the window, the aggregation or the assignment of the data is done on a group of sets. Now, window function can also return multiple values for each group. That is not available in group by. And also the group of rows to perform the aggregation is what we call the window. So let's take an example over here. All right. If you want to go through with more example, check out my Udemy course, PostgreSQL Bootcamp, which has like tons and tons of information about the window function. Okay. So Udemy PostgreSQL Bootcamp. Now let's look at some of the functionality over here. Let's try count the total number of employees across all departments. So we got the employees over here. So in order to count, what we can do is we can just use an aggregate function called count. I can call that as CNT, right, from employees. Okay, employees. And let's make it this way, the way we are doing it, which is count. So here we go. Now you have a 14. So important thing over here is that this aggregate functionality is run on the entire data sets. Okay, So what happened is that it takes the data first, and then on top of all the rows, it's actually applying the count. Okay, so what's happening over here is this functionality is done on the entire group. Okay, now, but often you might find yourself wanting to access such aggregation data from rows that do not represent an aggregation. Maybe you wanted to do it aggregation based on some condition. Maybe you want to group by departments and then count the functionality of the group over here. Sorry. And this is where the window functions comes in. So for example, maybe you want to aggregate data, the total count of employee from all the rows but one per employee. So how do we do that? Okay, let's do that over here. So let's try select, okay, and from employees, okay, and inside the employees I'm going to use, let's try employee name, okay, and then let's try department ID, right? So we got the department ID. So I'm going to first run this query. This will give me all the employees and department. But what you wanted to do is that you wanted to count by all the employees within a department. So how do we do that? It's very simple. Again, you'll do account star, and we will do SCNT over here, right? Once you try to do that, you'll probably get an error because it's going to say that this should be appear in group by or so. Okay, so what you cannot do is you cannot just I can do group by 1 and 2. This will work over here, but that's not what we are intend to do. We wanted to group based on individual groups over here. Now we don't want to use the group by. This is where the window function comes on place. Okay, so what I can do, I can use an over clause, and then once I run this one, this is what happened. The magic will happen, and now you can see the employee Smith, department 20. And now if you look at the department 20, it has total employees of 14, etc., etc. Okay, so this is run a count on all the rows. Okay, so the window function invocation in this example, count over everything, is basically runs in such a way that the over keyword indicates the invocation of a count will be treated as a window function. Okay, so if you don't use this, this will be a normal aggregate function, but if you use it over this count, that this aggregate function is going to be a window function. Okay, and so what did the window function count, star over do exactly? For every row being returned in the query, it returns the count of all the rows in the table. That is what this expression looks like. Okay, now as the empty parenthesis suggests, the over keyword accepts additional clauses to affect the range of rows that a given window function consider. So any absence, any such clauses, the window function looks for all the rows in the data sets, and that's why if you notice, you have all 14s appearing over here. And that's why you see all the 14 repeated in each of the row of the output, because we are not basically doing any partition, and this is something we're going to look at it. Key things to take away is that you want to apply aggregate function. You can use and turn them to a window function as long as you apply the over clause. Okay, so this is the beginning of a great utility of window function, which is then they allow you to work with multiple level of aggregation on one row. That is the beauty. Group by, you cannot do that. Group by basically tells you that, okay, you want to group by aggregate on this entire data sets, whereby the window function allows you to parse and split the data based on your conditions. Okay, so this is very, very important. Now, one thing to notice, and we're going to go through with lots and lots of examples later on, is we wanted to make sure that you understand the order of execution. So it is important to note that the window functions are performed as the last step in SQL processing prior to order by clause. This is important. Okay, so for example, let's try to filter employee with department 20 and 30. So how do we do that? And this is probably we're going to do it with a where clause, correct? So I'm going to copy this one. I'm going to save this thing over here. All right, so we got the query, but inside we're going to do a where clause. Okay, and inside the where clause, let's make it caps. All right, I'm going to say department ID is equal to 20. Okay, and let's select and run it. Now remember, this was 14, right? Now what happened over here is actually showing you 5. Why is that? Okay, so value of the count for each row is no longer 14, it is now 5. Why is that? Because in this example, this is where the where clause that restrict the result set to to 5 rows. Hence, the window function will count only 5 rows. There are only 5 rows available in the window function by the time processing reached the select portion, okay, over here of the query. So from this example, you can see that the window function performs their computation after the clause such as where, okay, and the group by as well. Okay, so if you take away this, of course, it's going to give you 14, but once you apply the where clause, the window function always runs after everything before order by. So where clause gives you 5 rows, so it's going to run the count based on the number of rows that is there, which is 5. Okay, so if even though you try 30 inside right now, you'll see a different result. So now you'll see that 30 means that there are 6 rows that's been returned. There are 6 employees in the department ID 30. That's why the count for each row is being done as 6. Okay, so now we are pretty much good in terms of understanding the window function. Number one is a very, very powerful function available in PostgreSQL or SQL itself. You need to understand, number one, is that if you want to turn any aggregate function to a window function, this is how you can do it using the over clause. And then the ordered execution is very important. So don't be surprised that, hey, you don't get the data. The window function always process last prior to the order by clause. Okay. In the next video, we'll be looking at partition by clause, which define the partition or a group of rows to perform an integration and aggregation over. So let's jump on to our next video. In this video, we'll be looking at partition by clause. So use the partition by clause to define a partition or group of rows to perform an aggregate over. Now you can think of this whole thing as a moving group by. So as we have seen earlier, you can use empty parentheses, then entire result set is partition that a window function aggregate will be computed on. And that's what we've done over here, right? Without anything. But when you insert the partition by clause inside, things get changed. So you can think of a partition by clause as a moving group by, because unlike a traditional group by clause, a group created by partition by is not distinct in a result set. So you can use partition by to compute an aggregation over a defined group of rows, right? And then rather than having one group represent all instances and so. So let's consider the following query, i.e. let's count employees by department. So we'll do a select from employees, okay? And then let's print the employee name, all right? And I'll do department ID as well, okay? And let's run this first. Okay, so these are all the employees, these are the department. But what we want to do is that we want to count all the employees of each department. Okay, so how do we do that over here? So what we can do is we can employ a aggregate function, okay, count star, but then we'll apply a window function. And inside the window function, if I run that, of course, we're going to get the count, no problem. But all the counts are same because it's running for entire result sets. But when we do a partition by, and we define, let's say, a column, and over here the column is department ID. So what the system is going to do is it's going to run this, and it's going to take all the result sets in such a way that it's going to partition them for each of the departments. So think of it that this is one window. This is the second window, 20. This is the third window, as in 30, etc. Right? So based on that, it's going to run the count over here. Okay. So as you can see that it's basically partitioning your entire result sets based on department ID. So you have 1, 2, and 3. So that's why you're getting the 3 counts for each row. In 20, you have 1, 2, 3, 4, and 5. That's why you are getting 5, and so on. Okay, so you can use the partition by to compute and aggregate over a defined period of time. Okay, so this query still returns 14 rows, but now the count is performed for each department ID, and as a result of partition by department ID clause. Now each employee is the same department, all right? So each employee in the same department in the same partition will have the same value of count, because the aggregation will not recompute until a new department is encountered. Also note that you are returning information about each group along with the member of each group. You can think of the same query if you wanted to run this and then write this without a window function. How do we do that? So we're probably going to do select from employees. Let's do an alias, and then we'll do an e.employee name. Okay, employee name or number is exactly the same thing. Let's do employee name, and then inside I'm going to do a query, which is a scalar query. So we'll say select count star from employees. Okay, D, and then we'll say where e.department ID is equal to d.department ID. Okay, as CNT. All right, so if we run this, this will produce the same result as such, right? As you can see, Smith 5, then you have 6 or so. Let's do an order by 2. And once I run this one, the same output is going to be appearing like Miller, Clark 3. So this belongs to the same employee. And if you want, you can even do a department ID. And if I run this one, and you will get the same result. So Smith 20 over here, and let's do it for employee ID number, say let's do it with 2. Okay, so 1 and 2. Okay, and let's run that, and now you can see 10, you have 3, 20, you have 5, and then you have 30 as in 6, the same query. But if you look at it, this is a far more better in terms of readability, in terms of even performance as well. Okay, so this is the same query, but we return in a different way, but a much more efficient way. Okay, now additionally, what's nice about the partition by clause is that it performs its computation independently of other window function, right? So you can have more aggregate function within the window. Okay, so for example, let's try, we're going to return each employee, their department, number of employee in their respective departments, their job, the number of employees, and everything. So this is going to be a long query over here, right? So let's do a from. What I want to show you is that you can employ multiple aggregation and it's run independently. Okay, so let's run this one over here. So this will be employees. Now inside our column, what we're going to do is let's try department ID, and then after that I'm going to do a count first aggregate function. We're going to apply a window function. We'll do a partition by, the first one we want to do is department ID. All right, so we can call that department count. Okay, let's do a job over here. Let's define a job. So we have a job over here, such a column. So let's define that. Same thing, we're going to do another count and over, and this time around I will, instead of doing a partition by department ID, I'm going to do by job. All right, and I will say job count. Okay, and that's it, right? So, and let's run this one first. As you can see, I'm applying 2 aggregate function over window function, and each of the partition is same. So this works independently, i.e. what will happen is that partition clause will perform its computation independently of the any other window function. And this can be done by providing a different column over here as well. Now if we can do an order by 2, all right, this will be like all the department counts over here. First, this is 3. So within department number 3, you have a job count 3 as a manager. Within the department number 10, you have 4 admins, and you have 1 CEO as such, and then you have an analyst, 2 analysts in the department ID 20, and then admin as a 4, etc. So this is not a true representation of it. As you can see, the employees in the same department have the same value of department count, and employees who have the same job position have the same value of job count as well. Okay, now it should be clear by now that partition by clause work like a moving group by clause, but it does so without affecting the other item in the select clause, and without requiring you to write a group by clause as well. So there's, as you can see, there's no group by clause. There's nothing you need to worry about over here, because this is a very, very powerful window function. Okay, so partition by is something that we use a lot in Click Analytics and a lot of places whereby we need to dissect the data rows based on a particular column or even an expression that we done as well. Okay, so in the next video, we're going to look at the effects of null. There are cases whereby you have a null values comes in, and how partition by can help us and more. How do we handle the nulls in our query, especially pertaining to partition by or window function? Like the group by clause, the partition by clause also lumps up all the nulls value into one group or partition. So let's look at it first and see whether this is true or not. So I'm going to use a traditional way of counting all the departments. Okay, so maybe we try and count all the commissions actually, right? So we'll say let's try departments. Let's do that. Department ID. All right. And then we're going to say how many departments are there as such. Okay. And we will say employees. Okay. And since we are using an aggregate, I'm going to do a group by one. Okay. So once I run this one, you can see that there are three departments. Of course, there's null value. So what we can do is instead of departments, let's try commissions, because some users or employee does not have a commission. So once I run this one, as you can see that A is counting all the people which has a commission: 501, 401, 1501, and then there are rest of it which has no commission. They are being considered as a null. So all the null values is now considered as a single group, and there are 11 employees. Okay, so this is how a normal group by clause works, i.e. it takes all lump sum of all null values into one group or partition. The same principle applied to partition by as well. So we're going to say select from employees. Okay, again we'll do a commission. All right, and after the commission we'll say a count. Okay, and we'll do an over window function. Let's do partition by commission. Okay, and let's do a CNT over here. All right, and as you can see, we don't have any group by clause whatsoever inside. So you have 401, 501, 1501, and then all the null values has been partitioned as a single group over here, and that's why you're getting 11 over here. Okay, so like the group by clause, the partition by clause lumps up all the null values into one group or partition. Okay, so the effect from nulls when partitioning by is similar to that from using a group by function. Okay, now what we can also do is instead of painting the null, I can maybe use a call sac, and in the call SCE, I can define that if there is a commission value, perfect. If not, let's do, instead of putting null, we'll do a commission value as in -1. Okay, so once I run this one, let's comma and run this one, and you can see that you have 400, and these are the people who has no commission. That's why you are getting, instead of a null, I'm just replacing it by -1. Okay, so this is the one way, because what happened right now is the count star right now is very important because it's used. This function returns rows. So we can see that there are 10 employees having null contact. So there's no commission whatsoever. It's like 1, 2, 3, 4, 5, 6, about 10, which having a null commission. So what happened if we, instead of using the star, we use an actual column? So I'm going to keep this one as it is, but this time around, instead of star, let's do an column itself, commission. Okay, now let's see what happened if we use the commission. So what do you think it's going to be happening? Any idea? Why don't you try on your side, do a pause of the video and then come back. Okay, let's run this one. So we have a commission, okay, and run it. As you can see that you have 400, 500, 0. Now you have the value as in 0. Okay, previously we have some values over here. So you have 11, and now you have a value 0. And why is that? Okay, the reason being is that the query uses count commission, right? Which means that only the non-null values in the commission column are counted. Non-null values. So there is one employee with a commission of 0, one employee with a commission of 300, and so far. But notice that the count for those with null commissions, the counts are always 0. Okay, and this is why, because aggregate function ignore null values. The aggregate function ignore null values, and more accurately, aggregate function count only non-null values. Okay, so it's very important when using the count. Consider when you want to include nulls, you use count, you count in star, but if you use count column to avoid counting nulls. Okay, so use count star if you want to count not null. You use count with a column over here if you wanted to not count on the null values. Hello everyone. The order matters in window function. So sometimes the order in which rows or returns are treated by a window function is material to the result that you want to obtain from a query. So for that reason, window function syntax include a order by clause. Okay, so order by clause can be placed within an over clause. So you use the order by clause to specify how rows are ordered within a partition. Okay, how rows are ordered within a partition. Now, remember the partition is the one that is called taking all the data sets that we have and is partitioning based on whatever the column that you're looking at. Okay, but sometime once you have your individual partition, you want to also order within that. Okay, so when you use an order by clause in the over clause of a window function, you are specifying two things. Number one, how the rows in a partition are ordered, what rows are included in the computation. Okay, so this is very, very important. Now let's consider a query that we will be looking at it, whereby we're going to be sum and compute a running total of salaries of employee in department number 10. Okay, so in the department ID, we're going to run with that. Okay, so let's do that over here. Select from employees. Okay, first of all, we need a department ID. So we'll say department ID is equal to 10. Okay, and I'm going to just take all the data first. Okay, so we're going to build this step by step. So these are all there are three guys who has in the department ID, Clark, King, and Miller. This is their job, this is their hire date as well. So you can see 2020 06 09 11 and then 2021 01 23. We can always order by as well. This is their salary, no commission, department ID 10, and manager ID. So what we intend to do basically is to take the employee, but on each of the row we wanted to do a salary sum based on department number as well as overall salary, and then also the running salary as well. So let's build this over here. So first of all, let's do an employee name. Okay, and then after that, let's do a hire date. So we have a hire date. Okay, let's run this first. Okay, so we got two data points. That's good, two columns. Now what we're gonna do is let's do a salary, and what I intend to do is the following. So once I have a salary, what I want to do is that I want to do a salary based on the department over here. So that will be 265. Then this will be 5200. That will be about 1500 or so, right? So let's do that over here first. So I'm going to do a sum, and I'm going to do a salary sum, and I'm going to apply a window function over on partition by department ID as total 1. Okay, or in fact we can say department total. Okay, and once I run this one, and again remember this runs on each row basis. Okay, so what we are saying to the system is this clock, this hire date, this is salary 26,550. But if you look at the total sum for these is 9350, 9350, 9350, correct? So this is 5, 6, 7, 8. 8 plus 5 is whatever it is. This is all coming up as a department total. Why? Because we tell the system that, hey, we wanted to do a sum salary, but over a window function. So take all the data that we have partitioned by department ID. So in all of the department ID, you have 3 records. So it's going to sum all the salaries, and now it's presenting this way. Okay. Now let's do this without the partition by. So I'm going to do salary and over as total, right? So let's try total 2 or whatever. Okay, and I'm going to run this one and see the effect. Okay, so as you can see that this is also showing the total 2. Is there any reason why those two numbers are same? Anyone? The reason being is that you are doing a filter over here, which is department. Okay, so when you have a department ID 10, there are only 3 records, and that's why even though we don't have any partition by inside, it's actually running for all rows returned by the query. That's why the 9350 department sum and this one is same. So if you were to remove this and run that, then you will have a different total number. Okay, so that's very, very important. Now let's look at a running total. Okay, so we're going to say salary and we'll say over. Okay, and this time around what we're going to say is that instead of partition by, because we already had a department ID, so that's fine, but I'm going to use an order by and hire date. Okay, so once we do hire date, this is would be an ascending order, right? So once I run that, here we go. You see how beautiful it is. So you can see that Clark is hired at 2020 0609. You have 2650. Okay, this is the total, which is again the same thing. All right, now running sum, let's do a running total, in fact. Okay, and once I run this one, and here we go, you can see the running sum. So this is the running sum 2650. This is, think of it like this is the first employee hired at this date, so you have a 26. Then you have a king hired 5200. So if you add 5200 plus 2650, this is 7850. Then you have a third employee based on the hire date, okay, 1500. So if you add this plus this plus this, it's going to be 9300. Or in fact, you can do it this way: 2600 passed over here. Then your next employee 5200, so 26 plus 50 plus 5200 is this. Then you have a 1500. This will be added to 7850, and now you have 9350. Okay, so just to keep you on your toes, I've included the sum with the empty parentheses right over here. And notice that both department total and total 2 is same. And why is that? Because in the where clause, the filter result cell that we have is salaries for all the department, only number 10. Okay. And also for summation, in case there is only one partition, the entire result set, which consists of only salaries from department number 10. So you have a department total and total 2 is same. Now looking at the values returned by column salary, right? So this is the salary. We can easily see that where the values of running total come from, as I mentioned, right? So you can eyeball all the values and add them to yourself to compute the running total. That's what we did over here at the same time. Okay. So this is how you can actually utilize the order by clause within the window function. So as you also notice that I don't have to provide partition by and order by together, right? You can do either one of them as well. So over here, what we are saying that, hey, for the entire set that is returned, first order by hire date and then compute the salary. So that is why we are getting the running salaries over here. Okay, this is based on ascending order. So it takes the data, this entire data set's ascending order first, then after the ascending order returns the rows and then compute the sum salaries inside. So I can tell you Windows function is a very, very powerful function. It's very important that you test it out, do different things as well, get the graphs of it as well. So as you can see, this one single table can give you so much history, so much output, so much data, information, and much. In this series of the video, we'll be looking at the meta queries. So what are the meta queries? Meta queries are the queries which gives you the inner information about your RDBMS structure. So as a database administrator, you need to know where are certain internal information are stored within your SQL database. So it might be the table names, table columns, the indices, the foreign key, primary keys, and all sort of different things. So you should know about it as well. Like you normally interact with tables over here, but you should know that how this internally being stored in your database structure and so on. Okay, as part of an administrator, this is important to know about that. Okay, so I'm going to show you some of the basic ones that is always important to know about it. So for example, if you want to see the list of all the tables that's been created in a particular schema, how do we access that? Okay, so what do you mean by schema over here? As you can see, when you browse through your database over here, right, you'll see a schema. So now right now I have only one schema, so I can create a table in a different schema as well. Okay, or number of tables in a different schema. Think of a schema is that a separation of information. So you might have one schema for everyone. So this is why we call public. But maybe you want to create another schema over here. Let's say create a schema, and as simple as that, maybe for internal use, or maybe for accounting, maybe for something more secure. So the Postgres database or SQL servers, as in like DB2 or Oracle, does provide all this functionality as well. Okay. So what if you want to list all the tables in a particular schema? So our schema name is called public over here. How to list all the table names over here. Okay. Now this is where we can find all this information. So normally there is a table called information schema.tables, and this contains all the information for Postgres related tables. So I'm going to do select from, and then inside a particular table called information schema dot tables, right? So I'll do all the columns that is stored over here. Once I run that, you can see that it has 182 rows inside. You have table catalog, which is the database name. You have a schema, like you have public schema. There's an internal PG catalog, and so okay. And then you have a table name itself, table type. You know, all those different information is available as is insertable table. There's not, etc. So, for example, this particular table is not insertable, okay, because this is a table type. It's not a base table, but it's a view type. Okay, so you can find all this information. So if you are looking for all the tables, you can see all the table name is in this column. So I can do table name. Okay, and once I run this one, I'll see all the table names inside. Okay, these are all the internal, external, all the tables are there, right? So you might have another table called column contains all the columns and also domains and all sort of different things. So as a database administrator, it's important that you should know about it as well. Okay, now let's look at how to find listing a table's columns, right? So of course you can access actually a table name over here and their columns very easily, but what if you want to run this through a query? Okay, how do we do that? So likewise, in our information schema, you have a dot tables, you have a what you call dot columns. So I'm going to copy that over here, and I will start with all the columns, and this time around, instead of table, we'll call it columns. Okay, and let's run this query over here. Here we go, and you can see all the tables related information. So 1700 over rows are being created, returned, because there are some internal table, there's a table that you've created and stuff like that. Okay, so these will give you all the tables columns. So what if you are looking at a particular table of your choice? So maybe you want to look at all the information and within the employees, all the columns. Okay, so how do we do that? As you can see, you have a database name, tables schema, and table name. So we can define where clause. Okay, where, and inside I can say table name is equal to employees, and select and run it, and now you'll only get these 8 rows over here. So this will give you all the information that visually you can see it, but now in the query as well. So your manager ID is actually gives you table name, column name, where exactly is the position. So it's the first number 1 position. This is what's the second one is employee 2, and then column any default value is nullable or not. What is the type of the data column? All similar different things. So numeric precision in terms of radix and stuff like that, and a lot of different internal information is available as well. So especially like what is the catalog looks like, it's a database, what is the schema, is a PG schema, what's the UGT name, var chart, etc., etc., right? And there's a lot of internal information that is out there that's actually help you to look at the information and much more. But it's important to know how to find these information as a meta queries. You're probably wondering that why do I need to actually look at it? Because in a practical world, you probably wanted to insert dynamic information in your table. So for example, you say you want to insert some information within the employees table in a particular column, let's say salary, but you wanted to ensure that whether the salary column exists in a table or not. So these kind of queries would be very, very useful in that case. And trust me, in a practical world, this is something what we call dynamic query generation that is required, and then we use a lot of meta queries for that as well. Okay. The last but not least, let's look at it, all the listing index columns for a table. So you want list indices, their columns and their column position, if available, in a index for a given table, right? So let's look at it all over here. So I am going to run a simple command again in Postgres SQL. As we have seen, like PG catalog was there. So in the PG catalog table, there is a PG catalog schema, there is a PG underscore indices that is available as well for us. Okay, so I can run select right from let's do star. Okay, and inside the PG catalog, so I'm going to say yes, I'm looking for PG catalog dot PG indexes. PG is for Postgres. Okay, And I'm going to basically run this one first just to look at all the indices that is available. So it's like 121 indices inside. Now, if you notice over here, if you have created any indices before, a unique index or normal index, this is going to be available over here. And you can see also the command. This is basically creating a unique index. This is a normal index. If you look at it, create index. Now, this is containing the index name on a particular table and what is the field name over here, right? So most of it over here is being displayed as internal tables, right? So as you can see, there's a lots and lots of internal table, and that's maintained over here. Now let's look at this table that we have created before, right? There's a primary key and all sort of different thing. This is also coming up as a T1 was the temporary tables. You have a T1 P key, and then this is the index that's being created inside as well. Okay, so this command is very useful because if you wanted to do a query optimization, meaning to say that if you want to run your query much faster and you want to see which tables have no indices, they should have index before or so, that is available. Of course, you can use the pgadmin tool over here, but remember, if you have a fairly large table, and you will have, I mean, in a typical practical environment, you have like 500 or 1,000 over tables as well, even more actually. So in that case, running this visually might be a little bit challenged, but if you know all these meta queries, it will be very, very useful. So this is how you can list all the indexes that's been done on a particular column or particular. So this is how you can look at all the indices that are being created on various different tables in your database. Listing constraints on a table. So what are the constraints? Constraints are such a critical part of relational database that it should not go without saying that you need to know what constraints are on your table. Now, listing the constraint on the table is very useful for a variety of reasons. You may want to find out table missing a primary key, or you want to find out which column should be a foreign key but are not. And also, so to list this constraint is very simple visually from the pgadmin. So you can go to your schema and inside your table. So for example, let's take a look at department. And if I expand the department table, you can see over here, let's say constraints over here, right? So I can see that there's one constraint over here, department underscore P key. P key is normally refers to a primary key. I can do a right mouse click, go to properties and go to definition. And it's going to say that this is a constraint on a column called department ID. This is under the PG table space, PG default, etc. So this is how you can look at a constraint. And now constraints allow the data to be inserted in a table in a more orderly fashion, meaning say that they allow you to check condition and which the data should be inserted into a table. So maybe you wanted to make sure that columns are not nullable, or you want to make sure that whether there is a particular type of string should be added to this column, to the table or so. So these are very, very useful. And so it is important to know that what are those constraints on which tables or so. Again, if you are dealing with hundreds and thousands of tables, it's very difficult to go one by one. So this is where the meta queries comes in place. Basically, essentially, you need to look at the constraint on a table by means of two tables. So one of them is in the formation schema, it's called table constraint, and the other one is called key column. So let's look at the first one first. So this will list all the constraint, everything. So remember the one that we just look at it. This shows that this is the catalog as in database. This is my schema as in public. So you can see over here as in public, the catalog is this one, is our table. Okay. And then within that you have a department underscore key. That's the one. And this is for which catalog again. And then public schema. This is on a table called department. Is this a primary key? Yes, it is a primary key, etc., etc. So there's a lot of things that's available within this table as well. Okay. Now, if you wanted to list constraint on a particular table, it's very simple. I can actually do this over here. I can say where, and I can say a dot table name is equal to employees. Okay. And let me run this, and this will show me all the constraint on employees table. Okay. Now you must be wondering that, hey, what are these constraints that is I haven't created whatsoever, but why they have been created? So these are internally created by the Postgres database. So they are checking conditions over here, all on your employee table and more. Okay. and this is like enforced at the same time. Okay. Now, again, one of the other things that we can also look at it is what you call the columns usage as well. Okay, so these constraints happens on columns, right? So you can see that this appears on department ID, and this is a very good table that also allows that as well. Again, you can see that the information schema key column usage will give you whether this information, for example, this is all the database, you have a schema, you have a constraint name, table name, etc., etc. Okay, so why don't we combine these two together and then print it out the listing constraint on a table. Okay, so first thing first, what we're going to do is over here we can make sure that I can do a where clause, right? So we don't want anything other than public, so this will be important. So maybe I can make this as a column B, and inside the B we'll say we have a table schema, okay, and then table schema is equal to public. Okay, so this is the column that we are looking. Okay, so once I run that, you can see the same records coming up at the same time. Okay, now what I'm going to do is I'm going to combine these two tables together. Okay, so let's do that. I'm going to make a copy of this statement. Okay, let's do it over here, and then inside we're going to say that okay, we are looking for two tables. So let's me run this one this way so it's more manageable, and you can see the other table is information schema, and we are looking key column usage, and this is B. Okay, now since we have two tables, let's combine them together. So we have some condition, and we'll say end key a dot table schema. We are looking for public schema. Okay, and let's do some more. And the table that we are looking is already table employees 1, so this is good. Now what we need to do is we need to make sure that our table name A should be equal to table name in our column schema, column usage over here, right? So we'll say table name is equal to B dot table name. Okay, and then also we'll say A dot table schema, whatever the table schema is, also equal to schema is equal to B dot table schema. Okay, and also let's look at the constraint name. So we'll want to make sure the department key is also equal to in the first to second table as well. So table, I will say constraint name is equal to B dot constraint name. Okay, so let's take a look and run it, and now you can see that we are looking at this particular information within this query, within the meta query. So it shows you not only that, what's the database, what's the public schema, what's the schema name, what's the constraint name, and it will show you okay, which table was that employee, is it a primary key or not. So instead of looking two separate tables, we combine them together. We got a really good information inside. Okay, so this is how you can list constraint on multiple table or on a single table. Constraints are such a critical part of relation database that it should go without saying that you need to know what constraints are on your table. Welcome back, everyone. You want to create dynamic SQL statement perhaps to automate maintenance tasks as a database administrator. For example, you want to create a dynamic SQL to count number of rows from all tables. So let's suppose you have like hundreds and thousands of tables. If you wanted to type this or so, it's going to be very hard. Okay. Now this can be done through some clever methods, i.e. we're going to generate a dynamic SQL statement out of it as well. So we can use a lot of help from the meta queries that we have learned. Okay. So remember, there was a meta query that we have used to look at all the tables that exist in our system. Okay, so this is the one. So why not I try that at the same time? Okay, now the concept is to use some of a string to build a SQL statement. Okay, so before using it, let me run this first. Okay, I'm going to show you this list all the tables that is out there in our system. So I'm going to do a star because we are only interested with a schema. So we'll do where clause where table a schema is equal to public. Okay, that's number one. So we're going to filter out all, not the one that is inside our dynamic tables or so, like created by internal system. And also we don't want the views, we only want the base tables. So I can do another condition, table type is equal to database table. Okay, let's run this one. So we're only going to get the one that we created in our schema over here. Okay, so let's look at these like thousands of tables. All right, so meta queries can be very useful. Now to generate a statement whereby we will count the rows is going to be the following, right? So typically it's going to say select count star from the table name. So let's take employees tables. Okay, and once I run that, this will give me all the employees count. All right, now if you were to run that with thousands of tables, it's going to be very difficult. So what we're going to do is we're going to take the string all the way from here to here, and we're going to turn this one in such a way that it's going to use our queries over here. Okay, so let me show you this. So once I run that, I only are interested in the table name. So instead of all, I will say table name. Okay, first of all, we're only going to look at the table names. All right, now we can do a with query over here. So we'll say with data as, and we're going to turn the whole thing inside our inner query. Okay, so let me just format that for you. Okay, so as, and then inside we'll say select star from data first. Okay, so this is the same query, but what I want to do is I'm going to create a string out of it as well. So we got the table name. Now we want the table name to appear as in such a way that it will say select star count from T1, T10, etc, etc. So how do we do that? It's fairly very simple. So instead of star, I'm going to take this part, okay, and I'm going to put a quote inside. Okay, and after the from, what I'm going to do is, we know that we have a table name also output over here, so we're going to say table name. Okay, we're going to pipe that inside, right? And what we need also this exclamation mark, because if you're running this through a script, you want to make sure that this runs one by one. Okay, so if I run this whole thing and see what happened, you have generated a dynamic SQL over here, right? This is from the query that we have it, and then we created our individual statements. So it's like count from T1, T10, T100 and everything. So remember, you have like thousands of tables. This will be fairly very easy to run. So you can take a Python scripts to run it, or maybe an individual, like different ways to access that. Maybe you will do a lambda function in it to run these ones. So there's various methods, but the key thing over here is that you can utilize a lot of meta queries, a lot of your inner queries, outer queries, with query, recursive queries, and you can generate your dynamic SQL as well. So a dynamic SQL basically is running the statements, but then we are doing over here is we are piping it in such a way that the strings combine together. So the concept over here is to use string to build your SQL statement. So highly recommend to you that you try and do the same thing as well. Maybe you wanted to try out, select all column. Maybe you want to have thousands of tables and you want to say, hey, I want to look at all the empty rows in the column based on some conditions or so at the same time. So the imagination is all up to you how you want to use it or so, but this is how you can utilize your meta queries to generate, or any queries to generate your dynamic SQL for a lot of things like automated maintenance tasks and much more. Welcome back, everyone. In this series of the video, we'll be looking at international depth information from World Bank. So World Bank is a very big authority in the world which provides a lot of data on all the various different countries in terms of like how much depth they have and how much money they have given to them, and etc, etc. So we're going to download this information from the World Bank and then analyze that over here. So it's a very good way to look at globally how the information can be taken and how information can be utilized using the SQL database and much more. So I've already prepared some data for you guys before. So let's prepare and upload our data to our test database that we have. Remember, our database was in our main site, so we are on the PostgreSQL queries Udemy. As you can see, we have these tables over here. We're going to create tables over here, a new one as well. So you can create the same thing in the SQL browser or Elephant SQL, or you can use the PG admin tool over here as well. Okay, so what I'm going to do is basically I am going to create a table over here, and then I've also attached this file to this video as well, so you can later on do the needful. So what we are intent to do is to create an international depth table which has a country name, code, indicator name, indicator code, which all of them are variable char, and then you have an actual depth over here as a numeric. And then later on, we're going to insert this data as well. So as you can see, this is a very simple data. You have country name, country code, you have an indicator name, indicator code over here. And then last but not least, you have a depth over here. So how much depth they have. Okay. So I'm going to copy this one over here, go to my pgadmin tool or LFN, whichever is good for you. You can do that. And I'm going to run that. Now our table is created. If I do a refresh over here, you can see the international depth table is created with all the columns of our choice. Okay. So next, what we want to do is let's just leave that and make sure that we insert all the data. So I'm going to select all of it over here. Right. Let's go to the bottom. Okay. And let's do that. Copy. And I'm going to paste it over here. Right. So you can see the last entry is about 22,323 records over here. So we're going to just select that and run that. So here we go. The record has been added. So let's double check whether we have the data or not. So if I do select star from international depth, and let's do a limit of 10 and run it, you can see we have the data. So the data is very simple. You have a country name, country code, indicator name, indicator code, and then you have an actual depth as well. Okay. So the idea over here is that you have the sample data, and then what we're going to do is we're going to run some data stories out of it as well. We're going to look at how this data can tell us a lot of information about the global countries and we're going to apply all the knowledge that we have gained so far on the SQL system and see what kind of data stories we can run on top of it as well. So let's head over to our next video where we'll be firing out all the commands and more. Welcome back, everyone. Let's analyze our international depth data. So we know that our data is in international depth. We have a country name, country code, indicator name, and indicator code, and the depth, which is the numeric data. Okay. Let's find out some data stories out of it as well. For example, let's find the number of distinct countries in our table over here. So how do we do that? It's very simple. First of all, we'll look at the select. Of course, this is coming up from international depth. Okay. So over here, since we are talking about the number of distinct countries, we probably need some kind of aggregate function. So we can try count over here. Okay. And feel free to pause this video and try to do this exercise by your end as well. Okay. So if I do country code over here, or let's try country name, and then maybe we make it an alias as total distinct countries. Okay. And then let's run that. So let me before I run it, do you think it's going to give us the correct results or not? Let's run this first. Okay. So you're getting 23, 22 over here, and that's the same amount of information that we have in our system. So if I do select international depths, okay, and I'll do a quick star, which is to select all columns, you can see the total number of rows is actually 23, 22. So the first query that we run is also showing it 23, 22. So where is the problem? The problem is that we did not put the distinct over here. Okay. So once we did the distinct, we can see that these are all the different countries. There are 122 over countries that have the thing. So we can see that there are 122 countries present in the table. And as we saw in the first selection, there is a column called indicator name as well that can be briefly specify the purpose of taking the depth as well. Okay, so let's look at it. So if I run this one, you can see that this is the indicator that actually tells you what's the depth looks like. So this is like disbursement, interest payment, external debt, etc., etc. And then you have a code as well. Okay, so why not we find out all the distinct depth indicators? Okay, why don't you try to pause this video and see if you can do the needful. So what we want to do is we wanted to do a distinct indicator, and then from the international table, and maybe we can do it order by depth indicator as well. So why don't you pause the video and try to do that, and we're going to come back and do the same thing. Okay, so let's do from international depths. Okay, and over here, since we are looking for distinct, so I'm going to use distinct, and then we are looking for indicator name. Okay, and we can even say distinct indicator name. Okay, and then from there, as you can see, indicators over here are, to be more precise, let's do depth indicators. Okay, and once I run this one, you can see all the international depths, okay, with the S, and run that, and you can see all the distinct depths over here. And we can even do a quick order by, so we can say order by, and I can use probably the alias as well, distinct depth indicators. Let's run this one. Now this is in ascending and descending order. Okay, so these are total 25 global distinct indicators that's available over here. Okay, so this shows you that there are several countries who are taking the depth, and these depth from the World Bank has been distributed among 25 major depth categories over here. Okay, so now what we probably wanted to see is to look at it, what's the totaling of amount of depth owed by each or all the countries maybe. Okay, so we want to take all the depth that is owned by all countries. Okay, let's do all countries. So how do we do that? Very simple. Select star international depths. Okay, and then inside, since we are talking about all the depths, so what function, aggregate function, we can use that? Of course, sum. And what's the column? Is called depth. Okay, so let me just run this one, and you can see that this is the number. This is the total depth that's right now based on our data available from the World Bank for all the amount of depth that globally run that. So this is like I don't know, trillions dollars. So probably wanted to round that. Okay, first of all, maybe you wanted to divide that to maybe more of a billion or something. So we can 1 2 3 4 5 6. Maybe we divide by a couple of million. 1 2 3 4 5 6. Okay, and then after that, maybe we do a quick round as well. Okay, and once I run that, this might be a better way to do that. So let's double check over here. So we got sum, and then we're going to divide that with 2 rounds. So we have a little bit better number with 3070795.26. Okay, so this will show you that this is the total amount of depth that is in USD that is owned by different countries around the world to World Bank. World Bank is very, very, very powerful over here. Okay, so this will give you a sense of how the overall economy for the entire world is holding up as well. As I say, you got to look at all this information. You might find that these are some of the basic information that we can apply, but the kind of information it gives you is the most important. Okay, so as I said, this will give us a sense of how the overall economy of the entire world is holding up. Okay, now let's look at a little bit more, and in the sense that we wanted to look at how an individual country is holding up. Okay, so now we have the exact total amount of depth owned by several countries. Let's now find out the country that owns the highest amount of depth along with the amount. Okay, so note that we need to make the depth, for this we need to make sure that depth is the sum of different depths owned by country across several categories. Okay, so let's do that over here. So again, pause the video and try to run that on your end. Okay, depths. And then since we are talking about country, so there are a couple of things that we need to do, right? What do we need to do? Yes, we need to make sure that we'll have a group by somewhere, and then we also have an order by as well, because we wanted to do it highest by. Okay, so let's define the structure. So what are the columns that we need to do? We need the country name, so we'll call it country name. Okay, and then we need to do in what depth, of course, and then what do we need to do on top of the depth? We need to highest depth, right? So what we're going to do is we're going to do all the sum of the depth for each of the country. Okay, and let's call it total depths. Okay, and then after that, what we need to do, we need to group by exactly country name. Yes, and then what we need to do, order by 2, or I can do total depth, whichever is fine. Okay, so maybe we wanted to limit this one to 10. Let's run that. So this will give you the countries with the highest depth over here. So here we go. This is all the countries with the highest depth. Okay, now if you look at it over here, this is in ascending order, right? Okay, so maybe we wanted to do it in descending order. And this will, so the least amount of debt that we have is Sao Tome over here. All right, this is amazing. Tonga is the last one, very small country. So here we go. China is the highest over here. Okay, so it was China, and then if you wanted to do it a little bit more breakdown of China, that can be done as well. All right, so you can see country with the highest depth is shown over here. Let's continue our exploration a little bit more about looking at the average amount of debt across indicators, the highest amount of principal repayments, and the most common debt indicators and other variable debt issues that we can learn from the database in our next video. In this video, we'll run statistics on international debt data. Let's continue our journey over here to find the data stories. So the next one we wanted to look at is the average amount of debt across indicators. So if you look at select star from international debts, okay, and you can see that you have a indicators. So we have several indicators, indicator names and their code, and then this debt distribution has been distributed among them. Okay, so we wanted to look at the average amount of debt across indicators. How do we do that? Okay, so for that, what we can do is I'm going to take the same thing, and first of all we need the indicator code. So we can say indicator code. Okay, maybe we can look at as depth indicator as an alias. Okay, after that what we need is of course the indicator name. Okay, this is we need it, and then what we need to do average. So what kind of function that we should use? It's called avg, and we need to apply to what variable, what column? Depth. Okay, and maybe make this as average depth. Okay, so this will give you the international depth averages over here. Since we are talking about the averages, we need to do what? We need to do group by. Okay, and then this would be a group by based on what we call the depth indicator. Okay, so the one that we have it on top, indicator. All right, and then we also want to do indicator name as well. Okay, and then what we probably want to do is maybe let's run this first and then see the data first, and then we can do all sort of order by or so. So this will give you like 25 rows because we know that total number of distinct indicators are 25, and this is giving you all the indicators and then their average depths over here. Okay, so we probably wanted to organize this with order by descending. Okay, so order by descending on average depth. So order by descending as an average depth, DESC. All right, so this will give you a really good information about globally. So looks like the principal repayment on external debt, long-term amount, current US dollars, and principal payment on external debt, private non-guaranteed PM amount, current USD, is the highest, followed by disbursement of external debt, long-term over here. So it looks like DTAMX, which is date amount, DLXF.CD. This is the internal World Bank code. These are the highest top two average amount of debt across indicators for all the countries. Okay, so this is a good information because this will see that we can see the indicators DTAMT, DLXF.CD tops the chart of the average debt, and then the category includes repayment of long-term debts. So country takes on long debts to acquire immediate capital. That's normally the way it is actually. Okay, now an interesting observation in this finding can be that there's a huge difference the amount of indicators after the second, right? So from these two, after that there's a huge difference. So you have 5349 something, and then you have a 217. So there's a distinct difference between after these two, right? So we probably wanted to look at it a little bit more. So this indicates that the first two indicator might be the most severe categories in which the countries owe their debt. Okay, so we can investigate this a bit more as to find out which country owes the highest amount of debt in the categories like the one DTAMT, DLXX, CSD. Okay, so I'm going to just copy that over here. All right, so why don't we build this query? So the highest amount of principal repayments, and that's why it's showing principal repayment. Okay, so which country normally owes the most, the highest amount of principal repayment? Okay, so let's do select from international debt, and please pause the video if you wanted to try out on your side. Highly recommend. and also double check the thing at our end. Once you're done, pause the video, come back over here, we're going to do it together. Okay, let's do that. Okay, so we need a couple of things. We do need the country name. Okay, and then after the country name, we need the indicator name. Okay, and then this we need it from the international depth. Okay, now what I'm about to show you is one way to access this. There are so many ways that whereby access you can do the needful over here as well. There's tons and tons of ways. Okay, so this is one way to get this query done. Okay, so over here I can run a select query itself as well. So I can say select. Okay, and I'm going to try max because you need the maximum amount. Okay, so this would be the depth. Okay, depth, and then this will be again from international depths. Okay, and then what we are interested in, which code, the indicator code is equal to the one that we have. Okay, so this is what we needed over here, right? So let's run this one, and here we go. So let's double check, comma out, and let's run this and then see the country. So let's double check international depths. I'm sorry about that. So let's run this one, and here we go, China. Okay, so China has the highest amount of depth in the long term with the World Bank. Okay, so this is the data that's coming from World Bank, and it's often a good idea to always analyze like this to validate other investigative information or so. Okay, so we saw that the long-term depth is the topmost category when it comes to average amount of depth, but it is the most common indicator in which the country owes the depth or not? Let's find out, right? So we want to find out whether the most common indicator is this or not. Okay, so how do we do that? Again, select from international depths. Okay, depths, and then after that what we need is a couple of things, right? So of course, since we are talking about most common, we probably need to count somewhere, right? For count, we'll be looking at group by. We probably want in order by two. Okay, so what do we need? We need, of course, the indicator code. Okay, since we are talking about most common, so we're probably going to look at the count. So the count would be of indicator code. Okay, maybe we call it indicator count. Okay, and then what we would need to do after that is we need to make sure that this is based on indicator code. Okay, that's one thing. And then what we want to do is order by indicator count. Okay, probably one descending, and then we probably want also let's do that over here, and we also want indicator code as in descending as well. Okay, so we can see the both thing, and let's run this one first. So this will give you the most common depth indicator across all countries. So here we go, that's the one, indicator code, all the indicator code. This is the indicator count, so 122 first. So this is the one, this is another one as well. Okay, if you wanted to look at the name, what we can do is we can change the code to name over here, and then order also group that to indicator name. So now you can see that principal repayment or external depth is the highest, followed by official creditors and I can't even pronounce that, multilateral. You got PPG, interest payment on external depth is another one as well. So this is like the highest number of indicator counts, meaning this is where the most of the depth appears within all the various countries over here as well. Okay, so you even have a bond. There are 68 countries who are in depth based on bonds over here, INT, current US dollars, etc., etc. Okay, pretty interesting, right? And if you look at it, what I did is, if I want, I can even do a limit to maybe 20 or 10. Let's try top 10, and this will give you the highest depth in each of the country, where the highest depth are within the categories of indicators. So you can see principal repayment is the highest. You have official creditors, you have a multilateral, and then you have again interest payments, disbursement of external debt, long term. That's what we have seen before or so. Okay, pretty interesting thing, right? Okay, The last but not least, one of the things that we also wanted to look at is that, so there's that, let's change track from depth indicator now to focus maybe amount of the depth again. So let's find out the maximum amount of depth that each country has. With this, we'll be in a position to identify the other plausible economic issues a country might be going through. Okay, so let's do that over here. So what we want to do is we will look at select from international depth. Okay, and inside let's do a country name, since we wanted to look at a country name which has the highest depth actually. Okay, so what we are looking at is find out the maximum amount of depth that each country has. Okay, so country, and then this is the maximum depth. Okay, as DEBT depth as, and then we'll say maximum depth. Okay, from international this, and then since we are looking at country wise, we'll group by country name. Okay, and then we probably want order by, of course this will be maximum depth. Okay, and then we definitely want descending, and maybe we wanted to look at our limit to maybe 10 countries. Okay, let's run this one, and now what you can see is this is the highest countries with the highest depth. China first, followed by Brazil, then Russia, then Turkey, then South Asia, then least developing country, UN classification, I don't know, they lump sum everything inside, IDA, India, Indonesia, Kazakhstan. All right, if I do this for 20, you can even see some more countries inside and then see what they are all actually. So you got Mexico after that, Cameroon, Romania, Colombia, Angola. Okay, so it's a pretty interesting way to look at international depth information as well. Okay, so what we did is we look at a depth owed by countries across the globe. We extracted the summary statistics from the data and then rivaled some interesting facts and figures. We also validated our finding to make sure that investigations are correct. We look at it data across country code. We look at the data across indicators code as well. We look at the individual depth information and much more. Okay, now we can run tons and tons of other information on this data as well. So I highly recommend that you analyze this data a lot more as well, and then try to find out information, what kind of different information can we look at it as well. So maybe you want to look at the top 3 indicators, but we'll look at their percentiles in terms of how much of them are in5 distributed across the world, etc, etc. Okay, so this is a world of opportunity that get the data for you guys as well. So try to apply as much information as you can, and then find the data stories that can come from the data and much. Hello everyone. In this video, we're going to show you how to import sample data into our tables, i.e. symbols, sectors, prices latest, and prices historical. So first of all, you need to download a zip file attached to this video. So I've already downloaded this file. The file is data_sectors_symbols, prices latest, prices historical zip file. I have already unzipped this file, and you will see these 4 files inside. Okay. So this contains stock price historical, latest, sectors, and symbol. So first of all, you need to download the attachment from this video and then unzip these files, because these are the files that we'll be using it to import the data into our table. So what are these files? I've opened these files to a text editor over here, and I'll show you what are these files are. So the very first file is called stock_sector.csv. And what it does basically is gives you the ID sector and sector name. So you have 1 for basic material, 2 for communication. So basically this is giving you all the sectors that is out there in the stock market in our sample database. The second file is called stocks_symbol.csv. This contains information about the top 100 companies that in randomly picked for your analysis and so. So the information over here is pretty much similar to what we have created in our table structures, i.e. you have symbol, symbol code, symbol name, ID sector, market cap, and employees. Okay. You may find some areas whereby you will see, let's say, employee is null, and that is deliberatory over here so that we can run different queries and such more over here. Okay. So this contains the data for 100 symbols. Okay. The stock prices latest contains the latest prices for these symbols. Again, this is all sample data. Again, disclaimer that the whole exercise that we'll be doing for this video and all the remaining videos is only for education purpose. Nothing, no sort of financial advice or whatsoever has been given over here. So this is purely for education basis. So you have ID symbol, you have a trade date over here, you have the open price, you have a high price, low price, close price, you have a volume over here, then you have a day change, and then you have a return over here, right? 1 day. So this contains stock prices, latest information. And then last, we have the same file, but it has the historical data for each symbol. It is called stock underscore prices underscore historical CSV. As you can see that this is the ID which is repeating, but for different dates over here. So this is the ID symbol. You have 2019, 01, 02 records, and then 03 and F4, 5, 6, 7. All right. So this contains all the records for a particular symbol. And then we are having other data inside as well for other symbols. So close to about 100 symbols data. This is added over here too. This is about 64,000 over records that will be playing around as well. Okay. So first thing first, as I say, download the attachment, which is going to be based on the file over here. So you will see these 4 files, and you can often always open these files or so. Important thing to note over here, you need to make sure that wherever these files are, you have access to that as well. Okay, so now we are going to import these files to our table. To do that, we will go back to our pgadmin tool. Now the commands that I'll be running over here will be running on PSQL command line, not on PG query editor over here. Okay, so once you are in the pgadmin tool, make sure that you are selecting the R database, which is stock market. And then after that, you will select this icon, which stands for PSQL tool. So once you run that, what it does basically is connect ourselves to a more of a terminal mode to our database structure. So you can see that we are connected to stock underscore market. Okay. Now we can fire up all the commands that we are needing to import the data. Okay. To import the data, we are going to use the SQL copy command. Okay. So the copy command is very simple. You define the table over here. You define the columns that you wanted to get the data to be populated. And then you define a from clause. And inside, this is where you will define your the location of your file. And then you have like delimiter is comma separated file. It does have a CSV header, i.e. it does have a header over here, right? Okay. So if I go to our sector file, this is our header, and then everything, the fields are separated with the comma over here. And so that's pretty much what it's doing over here. Okay. So all the codes that is here would be attached to the next video as an article. So you cannot always run that. I highly recommend that you do it at your own as well. So I'm going to copy this over here. My location for this file is at users, AOE desktop, Postgres SQL queries, and stock market and stock sector. So the very first file that we need to look at it is called stock underscore sectors, and we are adding this into our sectors database. Okay. So let's look at it in our sector table over here. So I'm going to go to my PSQL terminal, so which is over here, and I'm going to just paste that. So as I paste it, you can see copy 12, meaning it is able to upload the data or import the data into our sectors table. Okay. So as I say, very simple, copy sector ID, sector name, and over here, this is the location of the file. Okay. On your side, you need to make sure that you put your own respective location over here. So if it is on C : something, or you are on a Mac, then you need to change this. And then refer this one to stocksector.csv. Okay, so the data is added inside, and to double check, we can always do the same terminal, select star from sectors. Okay, and we can see that our data is inside. Okay, so sectors data is populated. Now let's look at the symbol. Okay, so let me copy the symbol command over here. So same thing, symbol over here, we'll copy the symbol name, sectors, market cap, and employee. The data file that we are looking is stock symbol. So this is the file over here, stock symbol. Okay, and then what we are saying is very simple, delimited, null as null, etc., etc. So just copy this over here. Okay, And make sure that when you are running this, you have a null as null also added over here. For the first one, you don't need it because there are some null values, so we need to treat null over here. Okay, so I'm going to copy that, go to my terminal window, and then make sure that cursor is blinking over here, and I'm going to paste it and hit enter. You can see that the 100 records are added inside. To double check, you can say select star from symbols, okay, and run it. You can see all the data is coming up. Okay, so I can do Q over here and it will be exit over here. All right, so the data is added. So symbols, sectors is uploaded with data, symbols now have a data. Now let's look at the prices latest and prices historical. Let's go back to our the code that we needed, and again, as I mentioned, this code is available as part of the next video article as well, or you can basically pause the video and type this at your own as well. So copy prices table, you have the prices fields over here, ID symbol, trade date, open price, high price, low, close, volume, change, return, and the location of the file. The file is stock underscore prices underscore latest, and then delimited with null as null and CSV header. Okay, so let me copy that over here, go to my PSQL window and hit enter, run, and then now you have 100 records added as well. Okay, as I mentioned, the prices latest should only contain one record for each company or symbol. Okay, so if I say prices latest, okay, you can see that okay, you can see the data over here, and I can do Q to exit the data. Okay, the last table that we need to populate is called prices underscore historical. So this will take maybe a little bit of time on your end, depends. It's about 65,000 records. So same thing, same formula. The only thing is we are changing stock prices underscore historical.csv over here. Okay, so the way the command works is fairly very simple. So you have a slash copy prices historical, then you define all the fields that you want to put it inside your table, and then you define your actual file name, space delimiter, this delimiter is comma, null as null, CSV header. Okay, so let me copy that, and I am gonna go to my terminal window for PSQL and hit enter. All right, and it's gonna take a little bit of time. It shouldn't take a little more time. So we've got 64,000 records added to our database. Okay, so we can say select star from prices, and we will say historical and limit, let's do 10. Okay, so we will show you our 10 records, meaning that the records are added in our database. Okay, so in this video, what we did is we populated all the data, the sample data for these 4 tables over here. The key thing just to reiterate over here is, first of all, you need to download the file. This is in zip format, so you unzip that, you will these 4 files. These 4 files looks this, very simple files, right, containing sample data. And then after that, what you're going to do is you are going to come to your pgadmin tool and then start typing either these commands that is part of the next video article as in code, or you can basically type this on your own. And the functionality for slash copy command on the PSQL is to populate the data from the CSV. So you're importing the data from CSV to your table. So make sure that these steps are done in the fashion that I mentioned earlier. You don't want to populate first prices, latest, and then historical. No, you first do it sectors, followed by symbols, then prices, latest, and historical. The reason being is that every single table has a foreign key associated. So you need to do it step by step. So once you have this data, we are going to fire up all our queries engine and everything, and running a lot of queries on this sample data and more. Hello everyone. Before we jump into and firing up all the queries on analysis of stock market and more, I want to take a step back to show you that how I designed this course so that you can get the maximum benefit out of it. So the idea is that I will be typing up commands and question inside our query editor. So what you will see is that you will have a query editor whereby you'll have some kind of a heading which show you that what we are intent to do. And then you have some questions or queries over here. So for example, list all data in sectors, list all data in symbol, list all data in prices, etc, etc, etc. So what we'll do is that we start typing our commands over here, right? So for example, star from sectors, okay? And then we will run these commands accordingly over here, and then the output will come, okay? So this is how I want to do a little bit more interactive in such a way that you can see directly what is the question or the query that we would like to find an answer of. And then we can see the corresponding query over here as well, okay? So one question might arise that, hey, if you wanted to refer back this whole thing, how do we do that? So the good news is that all the queries that you have over here, I will be putting up in your course, i.e. you will have a normal video course over here. Let's say this is the one of the course titled Total Sectors, Ascending, Descending. So you'll have a video over here. But right after that, you will see another article over here, associated article, which is start with code colon. So code colon and the name of the video title. So this video title will be here. Now inside, what I will do is I will put the main code over here, all the SQL code that we are running in the window. So you can always refer that as your code that you can run it on your own as well. So similarly, like list all data in sectors. So this is how it's going to look like, select star from. So I can copy that and I can always paste it in my PG admin tool over here, right? And I can run it as well, okay? So this is the idea over here, i.e. we will have the queries inside the query editor. We will solve the queries based on the questions over here, and the queries is going to be here. And also the same queries will also be available for you as part of the associated article for each of the video. So you'll have a code column, and when you click on it, you will see an actual all the queries that we have run over here. So hopefully this will help you out to test it out at your end. I always emphasize that. Follow along, i.e. whatever I'm typing it, pause the video, do it at your end. Secondly, use this code article as your way to take this and then run it at your own at the same time. So hope this will help you all. Let's begin our journey together. Welcome back, everyone. Let's begin our journey to analyze the stock market and much more through the PostgreSQL. So let's look at some simple queries over here. We have got data for all these four tables: symbol, sector, prices, latest, and historical. Make sure that you are inside. And if you have any window open before, just close that and then make sure that you are in the query editor. Okay. So I've closed all the previous windows on PSQL and anything. And I launch a very simple query editor, which you can click over here and launch it over here. Okay, so I'm going to fire up all these queries over here. So let's look at all the data in sectors. So very simple query over here, select star from sectors. Okay, and if I select that and run it, you can see all the data over here. Okay, so you have ID of the sectors 1, 2, 3, 4, 5, and then you have a corresponding sector name over here too. Let's look at all the data in symbol. So select star for everything from symbols. Okay, and let's run this one, and here we go. We got all the data. So you have ID symbols, symbol name, ID sector, market cap, and employees. So you notice that market cap, employees are in numeric format, ID sector is an integer, which is a foreign key, and then you have a symbol name, varchar 255. Symbol itself has a 50 character over here, and this is a primary key, which is of integer over here. Okay, as you can see, we got about 100 records inside too. Okay, if you scroll through, you will see all the 100 records over here. Okay, so very simple commands again. Let's run it. All the data for prices latest, so we'll say from prices and underscore latest, and let's run this one, and you will see all the data for prices latest. If you notice, we have 100 records over here because we have 100 symbols, so we want one record for each symbol only. Okay, again, this is the primary key. Over here, ID symbol is the primary key. This is the auto-generated serial number. You have date, numeric, all the numeric data for trade date, open, high, low, close, volume, day change prices, as well as return prices. Okay, as I mentioned to you, day change means whatever was the prices before for this date, what's the price right now minus that. Okay, So it's a change of the prices between today's date to the previous date. And this is in percentage term. Okay. Now all this data is sample data. Okay. What we intend to do is to utilize this sample data to run a lot of different analysis and much more. Okay. Now let's look at the price historical table. We know that the price historical table has like almost 64,000 records inside. So what we intend to do is to print, let's say, the top 100 records. So let's do it prices historical, and I'm going to fire up a limit 100. Okay, limit would allow you to limit the records. And here we go, we got the 100 records over here. Similar fashion structure over here. You have a primary key as an R serial key over here. Primary key is ID symbol. Trade key is over here. So you can see PK over here. So this is a combination. This is the unique binding, i.e. we need to make sure that every symbol has one record for each symbol and one day. Okay, so you cannot have the 12 for 2019-01-02 twice. It will not allow that. And this is how we keep the historical data unique. So this is a daily data for all the stocks over here. Okay, very simple illustration over here. We are printing all the records for these tables over here. Let's look at the sectors over here in a little bit more. Now in the sectors, we can see that we have columns. There are two columns, ID sector and sector name. Okay, so let's look at all the data for sectors. Again, select star from sectors. Okay, and if I run this one, select it. The way we are doing it over here is we are selecting that portion so that because we have a lot of queries before, so we want to make sure that we do a selection over here and then run it, and it will produce the results. So you got basic material, communication services, energy, financial services, and more. So this sectors basically tells you that there are companies belong to particular sectors. So for example, Tesla might be a energy sector, might be a financial services. Citibank might be a financial services. Microsoft may be in a consumer cyclic, or etc. etc. Depends on it. Okay, Tesla definitely is in technology company, etc. etc. So these sectors will help us to see which companies are where or so. Let's run some more analysis over here. As I say, we are just gearing up. So I wanted to do this videos, this whole course in such a way that we're going to start a little bit simple stuff, and then we gradually increase the complexity of our queries so that we can at the end of the day find that how we can analyze the entire stock market through the use of the PostgreSQL queries and more. So let's look at the sectors by sector name in ascending order. Okay, it's the same query, right? Select star from sectors, and we're going to do an order by over here. And then in the order by, we are saying sector name, right? So I'm going to say sector name, and then we want in ascending order, so I'm going to say ASC. Okay, let's run this one over here. Okay, and you will see the same result. Why is that? Because by default the order is always in ascending order. Okay, so that's the thing. Now I run this query in this way. Okay, now for more of a complex queries or so, the idea is that I will be running the same query a little bit different. So my always style is to run the query into blocks. So I try to do it in this way. So I write select first, then from. Okay, so since I'm looking at the query, I always try to split the query based on this question, right? So list all sectors meaning we are getting all the columns over here. Then say by sector name, so we are having some kind of order over here, and then the order direction is ascending over here. So first of all, select from. So first of all, from should be a table, right? So we'll say select star sectors over here, and I'm going to run this one, right? So if we are looking all columns, I'm going to do a star over here. Okay, so this is how I normally run the query. Okay, so I do it bit by bit. So list all sectors is already done. Now it's asking us to do by sector name in ascending order. So some kind of order needs to be there. This is where I say order by. Okay, and in the order by, I will put the name of the field over here. So sector name. Okay, and then since we have an ascending order over here, I will put ASC over here. All right, now I'm going to run this query over here. Okay, here we go. We got produce the same result. But for the readability point of view, this is a much better versus this one. Okay, but don't worry about it. We're gonna try both things as we go along, but I just want to show you that for more of a moving forward or so, I'm gonna try to do it this type of style so you can see step-by-step creation of the queries and more. Okay, now let's look at select all sectors by sector name in the descending order. So I can copy this whole thing over here, right? And it's pretty much the same query. Okay, and I'm going to run that, except we are talking about descending order. Okay, so let me just copy this as selection and run it. Now you can see that the sector name is in reverse order. So UTR, so this is in alphabetical order. So B first comes, then you have a CO, M first comes, CON, etc., etc. Okay, so this is in descending order. Okay, now let's look at some more information over here. Okay, say it's list all sectors where sector name contains financial. Okay, so let's build our query. Select from. Okay, first of all, we are talking about sectors. Okay, we are looking all columns. It's not saying that specific columns, it's say all sectors. So I'm going to do this. So this part is already done. Now where, so we have a where condition over here. So I am going to do a where over here. Okay, do a tab so that I can put my where condition over here. If you have multiple, this is a better way to do that. So sector name contains financial, right? So we are talking about sector name, and since we're talking about contains, the equivalent for the PostgreSQL is like. Okay, and we can do all sort of different things. This is not a like a hard query in the sense like this is the only way to get this. No, this is one of the ways. So I'm going to put a quote over here, and it says contains. It doesn't say start with, it doesn't say end with, or so it say contains. So when we say contains, we probably want the percentage signs over here, and the word that we are saying is financial. So I'm going to put financial. Okay, that's pretty much it is. So I am going to select that and run it, and you can see that we are having a one sector which does contain financial over here. Okay, if let's say if you want to do other over here, you can do other over here too, and then we'll see any sector which has other as a sector names coming up. Okay, so simple commands that we are applying, and you'll be surprised as we go along that these simple commands will help us to build a lot of data stories that will help us to understand the stock market and much more. Hello everyone. Let's look at some more information about sectors. Let's count how many total sectors are there in our stock market database. For that, we're going to use the count functionality. We can say select from, so we are looking at sectors. Okay, since we are looking for total number of sectors, what we can do is we can use the count, and I can do simple star, and let's run that first. Okay, here we go. So we have 12 sectors inside. Okay, let's confirm that. So if I do select star from sectors, we can see that how many sectors are there or not. So yes, we have 12 rows return over here. So this query works perfect. Okay, so counts is there. But then you have this thing like count. So maybe we can say a simpler alias for that. Total sectors. Okay, and then let's run that. This is much better. So we did a count functionality on records, and then we can change the output as an alias for total sectors over here. Now importantly is this is output as a big int as well at the same time. Now what if you want to do a selection of sector based on certain IDs? And this is something that we're going to do it in the later on once we're going to look at the inner join and outer joins and everything. So I just want you guys to practice this along with us. Okay, so list all sectors where sector ID are in 1, 2, and 3. So let's print first so that we can see we are looking 1, 2, and 3. So these are the 3 sectors that your manager say, hey, you know, I want some information for basic material, communication service, and consumer site clicks only. So how do we do that? So we can do select from sectors. Okay, we are looking for all columns, so this is fine. Since we are looking a condition where sector ID is in 1, 2, and 3, right? So I'm going to do a where clause over here. My column is sector ID. So I'll put sector ID. And then I will say we want these numbers in a particular sectors, right? So we want these numbers. So we are going to use the in a syntax over here. And I'm going to do 1, 2, 3. Okay. So with the help of where clause along with in, we can define that we are only interested with sector ID that are part of this array 1, 2, and 3. And here we go. Let's look at it. There we go. Sector ID. Oh, ID sector. Yes. ID sector. Yes. Here we go. And let's run that. Okay. So we got basic material, communication service, and everything coming up. What if you want to do a reverse? So you say that we want all the sectors except these 3 sectors. How do we do that? Exactly the same thing. We are going to copy this, and this time around, instead of we're saying in sector, I mean, there are a couple of methods. You can do all the remaining sectors one by one except 1, 2, and 3, but that's not an efficient query. I can do a not in clause along with where, and this will skip 1, 2, and 3 except those. It will print everything else. So 4, 5, 6, 7, 8, everything is coming up. Okay. Now, all these exercises, if you already know, perfect, no problem. But I just wanted you to gear up as we are going through, because all of these small queries, whatever we are running, we will be running it later on with a much more advanced analytics and much more. Okay. So we did a quick preview of count. We use the alias, and we also use the where condition with the in clause as well as not in clause in this query. So we haven't done a small thing. We did a couple of things over here with a lot of functionality.